I'm pleased to welcome Ralston St. Hilaire, Dean of CSU Fresno's School of Agriculture, to the stage.
Well, good morning, everyone, and welcome to today's summit on what is the future of agriculture in California. As Cassandra mentioned, I'm Ralston St. Hilaire. I proudly serve as the Dean of the Jordan College of Agricultural Sciences right here at Fresno State. And again, welcome to the Valley, and of course, welcome to our campus and the home of the Bulldogs. Today's summit hosts the Maddy Institute, Climate Now, and of course the Livermore Lab Foundation. A huge thank you to our sponsors, Wawana Foods, who will be sponsoring lunch, Writer affiliated companies, Terra Nova, Can, Soros, and Conway, and of course our exhibitors, Geoscience and Helena. Today's summit brings business leaders, scientists, farmers, public agencies, private agencies, and of course you, to this common space to talk about the future of California agriculture. Naturally, agriculture has its challenges. We know that. Some of those challenges, they are clear, they are present, and they can be solved promptly. Others can be more nuanced, and they take a longer time to solve. Take climate change, for example, as one example. Agricultural input costs, labor, water quality, water quantity, too little or too much. But California has a history of innovation, and that history has been long. It's a strong history. So I believe we will continue to be innovative in solving those challenges. California's history of solving those challenges has been really, really strong. So in speaking of the future of agriculture, today's keynote speaker has served as the Secretary of Ag since 2019. Secretary Ross has provided agricultural leadership on issues that are known nationally, internationally, and of course, she's provided a lot of leadership for us here in California. Secretary Ross is a really good friend of ag. I say this because I remember when I got here as the new dean in September, Secretary Ross carved time out of a busy schedule to visit us here at Fresno State to learn, to meet the new ag dean, that was part of it, but also to learn about what our researchers were doing in ag. And I can tell you, the Valley is very fortunate to have her in Governor Newsom's administration as someone who can articulate the challenges Valley agriculture faces. And as the Valley navigates the challenges of, groundwater issues, labor costs like I just mentioned, it is good to know there's someone in the administration who can articulate those challenges, balance them with the need for economic viability of the farmers. Therefore, I'm really, really delighted to welcome Secretary Ross to the podium to share information about the future of agriculture. A friend of ag, Secretary Ross.
Thank you. I hope I don't blow it. That was such a kind introduction. And I'm so thrilled to have the opportunity to be back at Fresno State. And looking forward to working with you, Dean, and with you, Mr. President. So nice to see you here so early this morning. I want to thank the Maddy Institute for doing this session today. It's ironic that we're sitting here having gone through a historic drought, and now we're probably looking at historic flooding, but I guess that is the story of California, isn't it? The Dean took away some of my favorite lines, which is really stressing what has made California agriculture so very successful and the envy of many in the world. And it is innovation. But innovation doesn't just happen. It takes a lot of people to help spur innovation and to make sure that we have the tools available to us to be able to adapt them to our own particular circumstances. I'm thinking of today's sponsor of this event, Wawona and the Smitkamp family, and all the innovations over their 60-year history that has made them a most remarkable, homegrown Central Valley company, a real leader in agriculture. So thinking about the future of agriculture is so intimidating. I'm going to start with just level setting. Where are we today? Because it is very remarkable. Our most recent numbers are for 2021, which was in the heart of the drought. And just like in 2014, when I had to explain to Governor Brown how we broke our gross revenue picture in the midst of a worse drought, we broke a new record of $51.1 billion in revenues in 2021. That seems remarkable because we were in the midst of a pandemic. We know how disrupted our markets were at that time. We know how disrupted getting exports out was at that time. We know all the additional things that we were doing. Of course, we always caution that that is just the gross revenue of the first transaction off the farm into the stream of commerce. It has no accounting whatsoever to what the commensurate cost increases were and what the net profits were. But it does show the power of what we do in California, which is increasingly more with less. When we think about this state and what has made us great, it is natural resources, the farmland that we have, the fact that we sit here in the Central Valley, where all 8 counties are in the top 10 producing counties of the country, and many of these counties, almost all of them, produce more than the ag revenues of many, many countries in the world. They do that because people don't give up. And yet, there sometimes feels like a breaking point. But we have great partners. When I think about this valley and the agricultural economy and what has really made it great, think about the land-grant universities that we have. What makes them such great institutions is they have a charge for public service, which has created partnerships with farmers and ranchers and ag businesses. It's created partnerships to do trials to really prove what will work on my farm for the crops that I'm farming, to make sure that this is something that really works. I call that the continuous loop of feedback that stimulates innovation and more innovation and more innovation. This state of California has the highest number of venture capitalists. We have the highest number of Nobel laureates. We have the highest number and the best public universities serving agriculture. We have the smartest, most innovative farmers, not just big and small, the whole continuum. Most people do not know that 70% of California farms have less than 100 acres. It's because of the specialty crops, the high value crops that we grow, that we can actually on small farms still, and we want to keep it this way, still generate an income for a family to make their living and to have an enjoyable quality of life. But we also know that in the process of the things that we've done, we've learned a lot about what some of our impacts are. And as we think about what the Dean just mentioned, climate change, we have to think about how we in the farming community can lead with solutions. I know that to my bone, partly because it's only in agriculture and in forestry, what we grow, photosynthesis, the ability to draw down carbon from the atmosphere and store it in the ground and hold it there, to give us that built up soil organic matter, to be a part of the climate solution with carbon sequestration. That carbon sequestration also increases our water holding capacity. It gives us resiliency. It improves our nutrient cycling so that it can, over time, decrease our dependence on synthetic fertilizers. We can lead on climate, and I believe that we are doing it now with the kinds of programs we have in California. We have spent, over the last decade, through the Greenhouse Gas Emission Reduction Fund, because we believe in the future of agriculture, almost $1 billion in greenhouse gas emission funding as incentive grants to farmers and ranchers and ag processors to reduce greenhouse gas emissions and help us address, adapt to, and mitigate climate change. Those programs include very important programs, and one of our most popular ones, because my friends are here from the Central Valley Regional Water Air Quality Board, the Farmer Program. Over $300 million over the last 5 years for farmers doing replacement engines to improve air quality immediately and reduce greenhouse gas emissions over time. We have invested $185 million to partner with farmers and ranchers to eliminate, and well, it's been on a phase out for 20 years, ag burning, $185 million. Through a Healthy Soils Demonstration Grant at the Department of Food and Agriculture, we worked with the almond growers of California to do whole orchard recycling, which has been one of the most remarkable changes in being able to phase out ag burning. And that whole orchard recycling is an almond tree is storing carbon until the end of its life, and when we can take it out and mulch it on site and return it to the soil, we continue that carbon sequestration measure. It was the work that we did in California that now has added whole orchard recycling into the NRCS standards of practice. We've invested over $200 million for on-farm water use efficiency. Most people look at how much water it takes to grow food for people and for livestock. I look at how much we continue to improve our water conservation on farms. In the last 2 decades, we are in agriculture applying 14% less water, and our productivity has increased by 38% because we're using it so precisely. Every drop, right time, right place. Oh, that's the fertilizer part. But that's the part about improving our irrigation practices, is that we're mitigating the movement of nitrates below our root zones. So when you look at these kinds of practices, they make a good, strong business case. They make a strong environmental case. But they make a good business case if we can improve the use of these resources. We're spending less on them. That's a good thing when we can get a win-win like that. We have, over the last, since 2014 and the passage of SB 1383, only in California do we have a mandate to reduce methane emissions. Our dairy families in California are leading the way. Over $383 million for dairy digesters and alternative manure management practices. Now, a dairy cow, for all of my dairy friends, I think is the original recycler. Because honestly, you can feed a dairy cow just about anything. But they also produce a lot of product besides the milk that goes into the dairy products. And we have traditionally thought about that as a waste product, to keep it out of things, away from things, a cost of doing business. But dairies are now the leaders in circular economy, because now we see that waste stream as a value stream. Capturing those methane emissions for dairy digesters, that anaerobic process, to turn that into renewable electricity and renewable low-carbon fuels. If we could change every truck that drives up and down 99 and 5, we would have an immediate improvement in air quality and reduce the asthma rates for children in the valley. And we're reducing greenhouse gas emissions. And we're creating a value stream, a revenue stream for that dairy farmer when they partner with a dairy digester developer. But it's also the alternative manure management program. Sorry to talk about manure right after your breakfast. But I get to talk about it all the time, so I want to share all this exciting news with you. When we think about these manure products, doing the separation of the water from the solids, they both have value, and we're really doing a lot of innovative work, and it was right here on this campus, partnering with NetAFIM and Sustainable Conservation and dairy farmers, that we really looked at how can we use that as irrigation water on the farm in drip irrigation for corn and forage for dairies. Reduce the amount of water used, use a water product that already had nutrients in it, reduce the use of synthetic fertilizers. They realized better and more consistent gains in their crop yields by doing that. We also can turn that solid into a replacement for synthetic fertilizer, a value, a huge value on the market today, especially as we have seen in the last 2 years, the increase in fertilizer costs, let alone the availability. Thinking about these kinds of things is one way that we can really capitalize on keeping farmers in business by being able to gain not just recognition, but a value in the marketplace for all that they produce because of how we farm in California. We do so much more than just the crop that we raise and harvest. It's the process of how we do it and being able to utilize every input in a way that really respects the very environment that we are the leaders in protecting, in doing it in a way that protects those people who work on our farms and are our neighbors. So I'm going to shift to some of the policy issues that we do have to be mindful of, because those policies present challenges, and every one of those challenges presents opportunities. Our continued work on climate change with the update of our scoping plan that was adopted at the end of 2022 has for the first time goals of working with our land managers, our land stewards, our farmers, our ranchers, our natural working lands. On crop and rangeland, we have a goal of adding 80,000 acres a year with healthy soils practices, 40,000 acres per year utilizing compost, because we want to get that organic waste stream out of the landfills and convert it to a value stream, which would be a replacement for synthetic fertilizer. Compost. Cover crops. We've seen huge growth in that. We have a goal of trying to achieve 19,000 acres a year additional in cover cropping. Those cover crops can help us hold on to our soils, prevent erosion, improve air quality, improve nutrient cycling, and hold soil organic matter, carbon in our soils for improved productivity. And 19,000 acres a year in additional no-till, not disturbing that soil. I know that it takes an investment in equipment and time. My brother did that 18 years ago when everybody thought he was crazy, and it's paid off for us in western Nebraska where there's hardly any topsoil left. We're so fortunate to be in the state of California. So that's what we're trying to do through the scoping plan. We have really held up all that's possible by working and partnering with farmers and ranchers. It's no longer as often sitting at a table with environmental groups and farmers fighting each other. More and more, it's about partnership. The realization that the vast majority of land in this state is held in the private hands of farmers and ranchers who love this land, who think every day about their legacy, about the next generation and the one after that. These are exactly the people that if we work with you, we can get faster and more superior results than just relying on a regulatory process. There is a place for regulations, and oftentimes that's to come in when we don't see the adoption that we want to, but we still need to meet the environmental goals. But I am telling you, when it comes to restoration, habitat, and biodiversity, farmers and ranchers are and will continue to be the leaders when we partner with conservation groups. I've already mentioned sustainable conservation. Tonight in Sacramento, we're going to celebrate the work that they spent 8.5 years doing. And I can't think of anybody else that would have the patience to do that. They have created a programmatic environmental process so that permitting for restoration on private lands can happen faster without all the hurdles. It was a gargantuan process. It was working with federal agencies and a multitude of state agencies to make it available, and we need it now more than ever. When I think about some of the conservation groups here in the valley, my friend down the road, Canon Michael, has done tremendous work on habitat and really looking at native seeds and how do we get more native plants, creating a business opportunity and a great partnership with a number of environmental organizations, including Environmental Defense, American Rivers, River Partners, doing things that are good for flood control. Will be part of a successful implementation of voluntary agreements, improve water reliability for the farms. These are the new partnerships that are possible and absolutely necessary for us to survive. I also want to touch on a couple of other things that we're working on at the Department of Food and Agriculture. In addition to our Healthy Soils program, which is a fairly new program, and we've already had $125 million available, and we'll have another $65 million available for land grants this year. We also have a new pollinator habitat program. It's a partnership between a number of resource conservation districts, farmers, and ranchers, all creating value, improving the resiliency of our lands to help us get through. But how can I stand here as the Secretary of Agriculture and not have said the word water yet? I bet you thought I was going to duck it, didn't you? I'm not. Water is essential to life. Water will be, in my opinion, when you look at the UN Sustainable Development Goals and the need to feed an increasing population with less available arable land, water availability and water quality, I think, will be the biggest challenge to food production. So paying attention to our water in California, with the fact that we have 69,000 farms, thank you, 69,000 farms, 70% are under 100 acres. We're a living laboratory from the smallest farmer selling direct at a farmer's market to the largest farmer who's exporting around the world. With our scientific capacity and intellectual capacity coming from campuses like CSU Fresno, with the young people that they're putting into careers in agriculture, with that energy and intellect, we can figure this out. The technology is advancing so fast. I've already mentioned how much less applied water we're using. We know we can continue to do that with new technology. As a state, we have updated our water action plan, and in August of last year, we released Hotter, Drier Future. How do we continue to be productive in food, productive in our economy, and in our quality of life, which includes environmental stewardship? When we know, based on the last few years, that higher temperatures and evapotranspiration mean less available water for human use and for ecosystems. In fact, that paper estimates that over the next 2 decades, we will have 10% less available water simply because of higher temperatures, drier soils. Evapotranspiration is something we have to deal with. So the strategy for supply is finish the projects that have been approved for funding through the Water Commission process of Prop 1. Those are sites and 6 other projects above ground, below ground storage that would add over 4 million acre feet in total of supply in those years that we have like this with atmospheric rivers to fill those reservoirs. It's taking a look at water recycling, especially in our cities that have a ratepayer base. It's an expensive technology, but it's new water. It's reusing every molecule. The goal for that is to add 800,000 acre feet a year of recycled water, taking examples from Orange County as a great example in this state of what is possible by doing water recycling and turning it into drinking water, irrigation water, and water for other uses. It's taking a look at what our good friend and neighbor, Don Cameron, was a pioneer in doing with on-farm water recharge. It's called Managed Aquifer Recharge. There are a number of projects around the state. We estimate that modestly we could do recharge on farm and in managed aquifers for at least 500,000 acre feet a year. This year, just with the permits that have been approved by the State Water Resources Control Board, almost 800,000 acre feet are estimated to be captured and stored underground with the permits that have been given. Infiltration rates are different on all soils. Not all soils are the suitable ones to do it. We want to be responsible and not exacerbate nitrate issues, but the mapping that is happening and the improved understanding of how water moves underground will help us better calculate where to do the recharge, how to do the recharge, and how to give credit for recharge. Those are yet to come, but I think those are part of it. And we must, in California, do what Californians have already done. Water conservation is a way of life. When we ended the last drought, Californians had achieved a 16% reduction in the use of water. We maintained about 13% of that. In December of 2022, Californians saved 17% water usage compared to year comparisons. It's a way of life. We know that other countries have done it. We know that's part of our future. When you total it all up, we're still going to be short some water, which means everything that we do is to use every drop as carefully as we possibly can. It is to better understand that the kind of abnormal year we have now may be the new normal years. We won't get years like this with atmospheric rivers coming so frequently, which will be a relief for everyone who's sitting in a floodplain. But these are the things that we must do to adapt. And Californians have that spirit of doing that. We have the capacity to do that. We have the scientific knowledge to do that. We have the will to do that. And we want to have even more partners to be able to do that. The last thing I want to touch on is how many commodity groups are leading the way on sustainability. When I look at our dairy farmers, they're using 50% less water to produce milk than they did over the last 3 or 4 decades. When I look at almond growers, they're using 33% less water to produce that pound of nuts. And they set a sustainability goal to reduce that by 20% more, and they've achieved 15% of that. When I look at the wine grape sector, that as a whole sector created the Code of Sustainable Wine Growing that has led to 90% of case production out of California being certified sustainable. It set the gold standard for wine production around the world. When I look at what is possible when we partner, working within our commodities, setting those goals, funding the research, we can also achieve the latest plan that Sacramento's delivering to you, which is the Sustainable Pest Management Plan. That is, where are the opportunities for us to continue to reduce our reliance on the most toxic pesticides for the good of our neighbors, the good of our workers, and the good of our environment? I think it's possible. It's a roadmap to 2050. It's not a sudden change. The marketplace is already demanding this in many places. Science, technology. This summer, Western Growers is sponsoring an international biological summit to really understand the state of the science that will help us get there. These are the types of things that only we can do in California to the caliber that we do. It's the reason I'm more excited about California agriculture than I've ever been. It's the reason that when I have a chance to talk to students, I tell them, agriculture is a great career. It's cool. It's sexy. It's all about tech, and it's all about nature. It's a wonderful way of making a living, of doing something that is more meaningful than anything else I can understand. That is that ability to produce the most nourishing food and make sure that every one of our neighbors and our citizens has access to it for their ability to live their best life as well. That's California agriculture. I would say in a nutshell, but I'm looking at all the berry people, and since Driscoll's is sponsoring lunch, I want to point out that berries have a lot of nutrition too, right? So thank you very much for your attention. I'm sorry I'm so scattered this morning. There's a lot going on. I really appreciate you being here. I appreciate you doing this conference. It's most important that you're doing it here in the Central Valley. 2 initiatives, if you don't know about them, I hope get talked about today. One is here in the Central Valley, CSU. Fresno, UC Merced, the Community Foundation, and UC Ag and Natural Resources are partners in this. An amazing, amazing work of collaboration with lots of partners, and this is for small, large, ag tech, and workforce. The other one, there's a lot going on in the Valley, but the other one that I'm really excited about is also the Northern San Joaquin Blueprint, which is all about the bioeconomy. Again, it's taking those waste streams. They are kind of the food and, well, they like to claim it, Bill, the food and beverage manufacturing hotspot in the Valley, turning those waste streams into useful products, whether it's renewable energy, replacements for plastics, and in some cases, like almond hulls, ingredients for food. These are exciting initiatives. It's wonderful to see our national labs partner with the Valley. The future's here. Thank you.
Thank you, Secretary. So the Secretary said that was scattered. I think that was the opposite of scattered. Thank you so much for being here. Thank you for those remarks. I'd like to welcome everyone to the first, hopefully, annual Future of Agriculture Summit. My name is James Lawler. I'm the founder of Climate Now. Climate Now is a multimedia education platform. So we create a podcast, video series, and events like these to try to engage with the most pressing issues that are confronting society as we face a transitioning energy future and a changing climate. So I'm very excited to welcome everybody. We had close to 700 people who registered for this event, the majority online, and certainly a strong in-person contingent as well. That just speaks to how important these challenges are and these questions are in the minds of so many people in so many different areas. So I'd like to acknowledge and thank our partners in this event, the Maddy Institute, Mark Kepler, and everything that you and your wonderful team, Lupe and Tanya, have done to pull this together. The Livermore Lab Foundation, Susan Houghton and Sally Allen, and all of the support that they've provided. As well as our university partners here, Fresno State, which is our generous host, providing this venue to have this event today, CSU Bakersfield, Stanislaus, and UC Merced, and we'll be seeing a number of representatives, presidents from those institutions here today on our panels. And of course, our sponsors, without whose support this event most certainly would not have happened. So Wawona, thank you so much for your support today. Ryder, thank you. We have Terra Nova Ranch, KSC, and our booth sponsors. Please take a look at what they're presenting. King County Water Alliance, Geoscience, and Helena Agri Enterprises. Thank you for being here. And the Secretary's comments on alternative pest management. Well, in fact, there is actually a couple of jars of real pests. We hope that they'll remain closed. As well as some alternative ways to manage those pests in other jars. Please take a look. It's very interesting. So I'd like to get us started today with our first speaker. We are very excited to have Dr. Jennifer Pettridge here today. So Dr. Pettridge is from the Lawrence Livermore National Lab, and she'll be speaking today on the intersection between agricultural practices and carbon management. Dr. Pettridge is senior staff scientist and group leader at the lab. She is a adjunct professor as well at UC Merced and a member of the UC Berkeley Innovative Genomics Institute. She leads multiple projects for the U.S. Department of Energy, including the Microbes Persist Soil Microbiome Scientific Focus Area and the Roads to Removal Assessment of Carbon Dioxide Removal Options across the United States. So with that, I'd like to welcome Dr. Pettridge to the stage. Would you like this one or the one behind the podium?
I'll give this a try.
Okay.
Yeah, thanks, James. Hi, everyone. That was really wonderful. Both, James, thank you for that introduction, and thank you to the Secretary for stealing all of my lines. Now you know a lot about how soil carbon is important, and water, and that nexus, and that's a lot of what I wanted to tell you about. As James said, I'm a senior scientist at Lawrence Livermore, but I also have adjunct positions at UC Merced and UC Berkeley, and that allows me to engage more directly with trainees and especially here in the Valley with folks who are really practicing the kinds of science that I have spent my career studying. So I'm a soil scientist, I'm a microbiologist, I've grown up digging soil pits. I now have a geoprobe, which does it a lot more easily than when we had to get out there with a shovel. And we study the organisms that live in soil and how they interact with plants and with the minerals to actually create the carbon, nitrogen, sulfur, phosphorus, water cycles. And so that's been most of my career. And you know, when you're at a national lab, you have the opportunity to move into new careers. And that's really what's happened in my life over the last 3 to 5 years, is that I'm starting to think about a bigger stage for our science and how it can be translated and used by individuals like yourselves. So I'm gonna give a talk here, but I want you to think of this as a conversation, and I really hope you'll come up to me afterwards and tell me what you think of what I say, and tell me your ideas, because that's really how to spin the wheel faster and better when we think about the engagement of research and academia and practitioners who are on the land. So, farming carbon, I'm sort of trying to set the stage for this morning's conversation, but I think about this as a way to start to value parts of our agricultural sphere that have been not thought of as strongly until we've reached the point where we're struggling with climate change, and that's both the increases of carbon dioxide in our atmosphere, but changes in our hydrologic cycle, which the Secretary just talked about, the changes in the water regime, both too little and too much sometimes. And there we go. Okay, so soil, and this is a passion obviously for me, but I think is accepted by probably all of you, really sits at the nexus of both carbon and energy and food and water security. There are so many things we gain from our soils, and it's not just a substrate that we walk on, right? We gain nutrients, that water holding capacity that the Secretary talked about. All of these things are so critical to our ability to produce food and fuel and fiber. And this is even more true here in the arid West. I love this map. I wish it was even bigger. I should have taken up the whole screen. It was drawn by John Wesley Powell in the 1890s. He was a Civil War hero, and he was sent by Congress with a team out to map the western US. And he looked at all of the climate factors that were extant in this part of the country before we had really started to dig up the plains and use it for agriculture. And he came back and he told Congress there is insufficient rainfall to support agriculture in the western US. And guess what Congress did? They ignored him. That's what they're great at doing. But what happened, we all know, is that our country developed through the agricultural intensification across the Midwest and then the western US. My family dug up the sod in Nebraska. My husband's family, his people were in Modesto and were some of the first to till that land and to support their families. And we wouldn't be here if we hadn't used the land in the ways that we have. But the ramifications, sorry, let's get this going in the right direction here. There we go. The ramifications of tilling that much of our land area, something like 1/3 of the planet, has been exposed to some form of agriculture intensification, is that we have lost something on the order of 500 billion tons of CO2 equivalents. Now, to put that in perspective, the carbon dioxide increase in the atmosphere in my lifetime, and I'll let you guess how old I am, is that's about 2/3 of the increase. It's 60 ppm, is simply from agriculture. As we till the land, we lose carbon. We also just lose soil. You're probably aware that in the Midwest, we have lost an enormous amount of topsoil. That is not the case in California. However, we still, in many places, are losing carbon. So we've got too much in our atmosphere. You know that story. And we'd rather be able to put it back in the ground. Can we do that? I will tell you that the science is diverse on that topic. There are many, many of us who think that, yes, we can return some of that carbon to the soil. The question is, how quickly and what will it cost? So that's what I'm here to talk to you a little bit about today. For some reason, the clicker keeps going backwards, and it's trying to go forward. I wonder if in the back, if you're just able to advance for me. Great, okay. The Secretary gave you the right numbers, but so some of the numbers here may be slightly off, but we have an enormous amount of acreage in our agricultural lands in the state. We have an enormous amount of, enormous amount of our economy is dependent on that land, and it's incredibly important to the entire country's food production. You all know that. If you could step ahead. But we're facing changes in climate which put that economic and ecological sustainability at risk. And I am aware of many, many pieces of legislation that you all and we all are facing. These are two key ones that the state has committed to being at what we call net zero CO2 emissions by 2045. I'll talk about that more in a minute. But also in 2014, the state passed the Sustainable Groundwater Management Act, which is likely going to take something on the order of 10 to 15% of our irrigated land out of production at current rates. So how do we think about a future where farmers are able to continue to manage land sustainably? We'd like to have some kind of cover on the land, even if it's not in active row crops, while managing carbon and managing water. If you could step forward. And actually, you can just kind of click through all these. We'll just look at them all at once. So I recognize that the font here may be a little too small for those who are in the back, but I wanted to just kind of lay out the landscape of different pieces of legislation which are part of this story. So first of all, SB 905 is telling us that we have an enormous opportunity to think about biomass and doing carbon capture in ways that we haven't in the past. And I think of that as actually being related to our municipal waste collection. We have an enormous amount of biomass that can be collected across the state from our forests, from our ag lands, from our municipalities, that could be valued as something other than waste, something other than garbage. And in a calculation that we've done, the amount that we spend trucking that to landfills, if that same amount of money were used to value that biomass for its carbon content, we could be capturing both a fuel source and capturing CO2 and storing that, and there's serious money to be made in that industry. We're also interested in this state in protecting both our below-ground biodiversity, if you've heard of the 30 by 30 initiative, and protecting our different ecosystems and the different organisms that live within them. Our Healthy Soils initiative, you heard from the Secretary about. We need to be sustainable as we're thinking about options in the future. And that's incredibly true at the federal level as well. The Justice 40 initiative is thinking about the individuals that are impacted by our changes in energy and agricultural policy. And then the Department of Energy recently just released many, many millions of dollars for research in becoming carbon negative. So there's an enormous amount of movement, really, in the legislative and research community because of this backdrop. If you could move to the next slide. So we have both an opportunity here in that agricultural systems both contribute to climate change and they are reacting climate effects, but we have the opportunity to really do climate mitigation in the way that we practice agriculture. And that's true across the country. It's very true here in the state. The next slide. So just in case we need a refresher, why do we need to do carbon dioxide removal? Why do we need to pull CO2 out of the atmosphere? You, I'm sure, already know the relationship between the concentration of CO2 and our climate and the greenhouse effect. But even if we were to completely stop releasing CO2 and all of the other greenhouse gases, methane, nitrous oxide, we still need to actually literally pull more out than we are when we're just at zero. So that's why we talk about net zero. So the area below zero on this graph, which I recognize again is probably too small a font, apologies, is what we call negative emissions. Those are technologies that are doing additional amounts of removal of carbon from our atmosphere. Next slide. At Lawrence Livermore Lab, we published a report that ended up being actually very influential a couple of years ago. We called it Getting to Neutral, how we value and where are the opportunities to have those negative emissions. Next slide. And what that report laid out is a whole series of different options, and they range from forestry, which, to be honest, in this state is probably not one of the best carbon dioxide removal approaches because we need to be honestly thinning our forests instead of growing additional trees. Agriculture, which I'll focus on today, and then a series of techniques that range from using biomass for making fuels and doing carbon capture to the most expensive, which is literally direct air capture, pulling CO2 using various technologies that involve electrochemistry, and liquefying that CO2 and storing it deep below ground in geologic reservoirs that are highly permanent. Next slide. So I just wanted to make a quick word here about, again, this is a topic that is near and dear to my heart, but how do soils store carbon? Where does that carbon come from? And as folks in the agricultural industry, you probably know this, that carbon comes pretty much half from roots, root material that is decomposed and becomes integrated in with minerals, becomes part of aggregate particles, and the other half is microbes. It's dead bodies of microbes. It's what we call necromass, but those organisms have interacted with roots in very positive ways. These are not necessarily pathogens, but organisms that grow and then die, and their food webs are expanding, and as they do so, as those organisms turn over, their biomolecules become part of what we call soil carbon, or soil organic matter. Next slide. In California, in our Getting to Neutral report, when we looked at the opportunity to increase that process of stuffing carbon in our soils, we found that it is by far the cheapest option is to do it both in forestry and more importantly, in agricultural soils. Something like $11 a ton of CO2. And I'll just tell you by comparison, to do direct air capture is upwards of $500 a ton. So this is something that is affordable, particularly now. The low carbon fuel standard is suggesting that we should be valuing carbon at something like $200 a ton. So this is a moneymaker here in the state. Next step ahead. When we've done the calculation for the whole country, we've looked at conversion of land that is currently in fairly marginal production of corn and soy, and it's literally hemorrhaging carbon still, and we're still getting a lot of erosion even in no-till areas. So if you switched from a corn, soy, even a no-till scenario in much of the Midwest, where we are losing carbon, and switched to a bioenergy crop, particularly a perennial crop with deep, deep roots and a huge root biomass like a switchgrass, that's a native grass in much of the Midwest, you actually can store on the order of 10 to 20 million tons of CO2 per year, while still making a crop, a biomass crop, that could be fed into a bioenergy and CO2 capture pathway. Next step. I want to talk a little bit about biomass. That's not the major focus of my talk today, but I just wanted to mention it, particularly because of where we are here today in Fresno and how the proximity to the many forests across the Sierra where we know we need to be extracting biomass, simply to mitigate fire risk. That is an enormous opportunity. I want to encourage us all across the state to be thinking of that, again, as not trash, not a waste product, but that carbon as being valuable as gold. And that's because when we take biomass and we convert it, we can convert it in many, many different ways through anaerobic digestion, through gasification. We can make many different biomolecules that can become then precursors for either fuels, sustainable airline fuel, plastics, many of the things that we need in our bioeconomy. But at the same time, we can capture the CO2 that is emitted from those plants as those processes are occurring. And again, we can store that in a deep geologic well, and we are then essentially in a win-win scenario. There are two economically viable attributes to those processes. Next slide. When we calculated the availability of biomass across the state, it is just enormous. Something on the order of 58 million bone-dry tons, distributed across the state, different types in different places, more municipal in some places, obviously, more forest waste in others, more ag waste in other places. But again, I want to just really hit home again the opportunity to think about this as not a garbage, but as a product that needs to be wisely used and financially benefited from. Next slide. Okay, so I want to take the last few minutes to tell you about opportunities that I see And this is really based mostly on my research, my group's research, and those that I work with. And you can step ahead. This happens to be my field site, so it brings me great joy to think about looking at this site. We had done, what you're looking at there is the Hopland Research and Extension Center. This is up north of the Bay Area. This is an actively managed sheep pasture, a sheep ranch. And those shelters you see there are what we call rainout shelters. We're doing a climate experiment here by preventing half of the rainfall from getting to the soil and looking to see how that affects the diversity of organisms and how they're interacting in the soil when we have much less water. But if you could step ahead one, what I'm going to talk to you about is everything that we have going on in my group right now, and that includes some studies of enhanced rock weathering, looking at different amendments that you can add to soil to try and increase the soil carbon, agrivoltaics, so growing a crop underneath solar panels, and then finally perennialization, so growing some more of those deep-rooted perennial grasses. Next slide. I want to say the first thing is that there's no one solution for the entire state, certainly not for the entire country. We really need to customize solutions to specific geolocations, to the soils, to what the infrastructure is, to what the human capital is of a particular place. So the answer is not just let's plant more trees. In California, our landscapes are designed to look like this, right? A mixture of low-density trees and grasslands. And in our agricultural landscapes, we need to be making food and fuel and fiber. We can't just plant trees. So you may have heard a lot of discussion about those initiatives, but I think we need to think a little bit more carefully, particularly here. Next slide. We've actually done some analysis to show as our climate, the concentration of CO2 in the atmosphere tends to increase, that actually is a fertilization for plants, right? Plants are photosynthesizing, and the more CO2 they have available, the more productive they can be. But we've actually shown that that carbon can be overall lost in forest systems because you're losing carbon from the soil. Whereas in grasslands, which is what a lot of our state originally was, we actually lock up that carbon in the soil more of the time. There's less in the above ground biomass and more below ground. And I don't know about you, but I think of it as being safer when it's in the soil than when we have it in above ground biomass that, as we know, can burn. Next slide. We've done a number of studies of different ways to use plants to pump more carbon in the ground. And most of those are based on perennials. The grasslands, a couple thousands of years ago in California, probably would have been perennial grasses, and they moved to invasive annuals. But perennial grasses, because those roots stay in the soil and they hold it better, we've shown that if you switch from an annual plot to a perennial plot, in just 10 years you can double the amount of carbon in the ground. And not just at the surface, but all the way, we stopped measuring at 3 meters because that was tough. But we found an incredible increase over a relatively short amount of time in the ground. We also saw increase of EPS, which is a microbiological term for extracellular polymeric substances. These are biofilms. Sticky goo is what I tend to think of it as. And these molecules are binding soil particles together so that they are more well aggregated and they hold water better. They also hold carbon better. So we think that's the mechanism of why this carbon is increasing in these soils. Next slide. Even further into the future, but I'm pretty excited about it, is if we start to manipulate the genomes and do gene editing of some of our crop plants so that they're even better pumps. We can do that through improving photosynthetic efficiency. The CRISPR editing is a technique that you may have heard of. Jennifer Doudna, who I work with at UC Berkeley, got a Nobel Prize for developing that technology. But what it's using is the genes that are already within the genome of a particular cultivar and rearranging them. And what I like about that is it's not GMO, and it's not classified as GMO by the USDA. So these changes that we can make in crops where they are more photosynthetically efficient or they're pumping more carbon out of their roots, the regulatory process is a lot smoother to getting them into the hands of practitioners and getting them out in the field simply to do research on. So it can be more accepted. So that's one project we're working on with folks at UC Berkeley. Next slide. The other is simply thinking about the microorganisms that plants naturally engage with in the soil. Arbuscular mycorrhizal fungi, different kinds of bacteria, nitrogen fixers. There are an enormous number of organisms that plants are already partnering with, and if we focus on those partnerships to make them even more efficient, that might be a way to provide nitrogen to a plant without having to fertilize as much, to provide more access to water because the fungi are able to explore a larger volume of the soil. So that's another area I'm really excited about. Next slide. And why don't you just step through this one? This one is animated. Enhanced rock weathering, I don't know if you've heard of it, is a relatively new concept in the ag sphere, but has been discussed for many, many years amongst those, the geologists like my sister, who's an expert in rock weathering. But when we add crushed silicate rocks to soil, that increases the surface area and increases the natural geologic process of weathering of those materials. That naturally draws CO2 from the atmosphere. It produces alkalinity, which can either create carbonates, depending on the pH of the soil, or that alkalinity is simply washed out into the ocean. But regardless, it can be an enormous net sink of carbon in our soils. We are still just doing research on this. There are initial test plots across the country. We are working with the Working Lands Innovation Center at UC Davis to characterize both the geochemistry and the microbiology of this technique. Next slide. Actually, you can just go ahead and step ahead to the next one. I want to also talk to you about agrovoltaics. This is another area that, again, is very nascent. There are just a few test sites in the state and some in Colorado and in Arizona. But I really love the idea of using land in a win-win scenario where we're getting two kinds of economic benefits at the same time. So the idea of having solar panels over a certain percentage of the ground area and growing a high-value crop underneath reduces evapotranspiration. It can shield our farm workers and expose them to less direct sunlight. And we think that actually you can have a more consistent revenue stream in areas which are sunlight rich and land rich, like this part of the Central Valley. Again, it's an area which is still, there's a lot of research needed, but in Germany and across Europe, this is a technique that's, an approach that's really taking off. Next slide. So I could go on. I could talk to you about polyculture and managed aquifer recharge, and we could keep going. There are a lot of opportunities. And I really, again, I want to encourage you to come talk to me about your ideas. But the clear thing I want to make clear at the end of this conversation is I'm focused on sustainability, I'm focused on climate impacts, but I recognize at the end of the day, a producer needs, their pocketbook needs to come out ahead. And I want to make it clear that there is a marketplace for soil carbon. And that's partly because in California of the low carbon fuel standard, but across the country, there is investment in practices that are contributing soil carbon, whether that's cover cropping or no-till or some of these amendments. I also want to tell you the science is not completely robust enough to support those markets. And we're working our as fast as we can to try and help fix that. But we need to have better measurement and reporting and verification of how these different technologies are actually affecting soil carbon so that the dollars that are invested in that space are real and are supported. Next slide. So I'll just end with, what's the solution? Well, like they say in the movie that just won the Oscar, it's everything everywhere all at once. We all hands on deck. There are many different techniques that are going to need to be applied. Some of the things I've talked to you about can be overlaid on the same piece of land. It's not a one or done kind of scenario. But I think we really need to focus on producers and what's sustainable for them, their livelihoods, their workers. We need to be thinking about incentives that are fostering just outcomes for everyone who's in the agricultural sector. And lastly, I think that the science needs to be part of the conversation. We need, the research needs to be rigorous and defensible. We need to be making sure that anything we do that's changing is making things better than the counterfactual, the business as usual scenario. And then I think there's one more slide at the end here, which is to simply, you can step to the end, which is to simply say, why is a national lab involved in this? I work at Lawrence Livermore National Lab. We're better known as being part of the National Nuclear Security Administration. But we have made climate mitigation and resilience at the top level of our mission space. And the laboratory and many of the national laboratories across the country are all in on supporting your industry and others in creating the technology and the scientific understanding that's needed to really change our energy, our carbon marketplace. Thank you.
Thank you, Dr. Petridge. We'll take that.
Yeah. Do you want to do questions?
Oh, I have to get this. How much? We should do some.
One?
Yeah.
One or two? Two?
To use this one.
Okay.
Yeah. One. Should be on.
Okay. Yeah, it's working. Okay. I think we have time for one or two questions. Hi.
Hi. Yeah. Two questions. One is, I wondered about the carbon emissions created when you crush the rock that's then used for your management, and also whether the Growing Climate Solutions Act is a good idea for the carbon change.
Yeah. So enhanced rock weathering, we're doing an assessment right now. We call it a life cycle assessment, where we go back and look at the energy that's put into crushing rock. In a lot of cases, we're sourcing rock very close by where it would be applied to a field. And it's also, again, seen as a tailing or a waste product in a lot of cases. So I think that we're going to come out ahead, at least in our current calculations. But these are slow processes, so that unfortunately that's the reality of a lot of the science we do. We kind of got to wait 5 or 10 years for the processes to kind of work their way out. We can use isotopes and different techniques to try and get there a little more quickly, but I think it's going to take a little time to fully know the answer on that one. And your second question?
About the Growing Climate Solutions Act, and whether that's helped the carbon market.
So the question is about whether the Growing Climate Solutions Act has helped the carbon marketplace. I just want to be really straight to say the soil carbon marketplace is edging towards almost $1 billion. It's kind of crazy to think that there's that much being invested in a marketplace that has not a good verification system, that has measurement is non-trivial. For me to make a soil carbon measurement is pretty straightforward, but I'm an academic and I have a lab that's set up to do that. But for producers to do that in a large scale way is still, we're quite a ways away. I want to be excited and positive about the possibilities in that space, but I think I want to also just be really measured and say we've seen in the forestry sector that there are offsets that are being purchased for forests that then burn. Well, that's no good. We really don't want the same kind of thing to happen in soil carbon, that we find out 20 years from now that a site that were valuing for its practices in increasing water holding or soil carbon, it turns out to be ephemeral or just wasn't true to begin with because we just weren't measuring or counting correctly. So that's my caution there. But I am bullish on that space in general. Yeah.
I have a
in the back.
Yes, thank you. Say a company develops a way to take care of the forestry products or the ag products or food waste, all the above. On carbon credits, would a company like this, in your opinion, be eligible for carbon credits?
I believe so, and it's not my area of expertise, but I have a good colleague who actually started a company down near Bakersfield called Moat, and that is their business model, is to both be selling an actual project in that they're producing hydrogen gas, but they're also getting the carbon credits out of what they're harvesting. Yeah. One more quick one. Yeah. Yeah. Oh, God. Okay, so the question is about the microbiota in soil and how do we divide the good ones from the bad ones? Oh my goodness, I could spend hours on talking about this. Many, many organisms have a Jekyll and Hyde phenotype. They are killing other organisms, but we see that as a good thing because every time a bacteriivore or a protist is eating another organism, that's carbon turnover, and we like that. But many of these organisms also can be pests to our crops that we're growing. In general, the more biodiversity that we have in our soil, the better we do at holding down those pests. And that's just basic ecology, because when you start to have one winner and no other organisms around to kind of kill the winner, then that's when you get into these out of control scenarios where you have different crop diseases. You know better than I do, though, that we only have so much ability to manage our below ground biodiversity, and there are places where you simply need to use either chemical or organic approaches to manage crop pests. But in general, I think that the more complexity, the better, and there's lots of research to support that. Yeah. Thank you.
Thanks, Dr. Petridge. So I'd like to introduce our next panel. If you guys could please come up. So this panel is a producer and farmer-led conversation. So what's so exciting about today is we get to hear from scientific perspectives and also the perspectives of people who are actually trying to do this stuff, actually trying to create the produce that we need. So today we're joined by Louis Howe, who will be our moderator from the firm KSC, Consors and Conway in Sacramento, and our panelist Daniel Hartwig from Wolf Farming and Processing, and Hector Lujan, the CEO of Writer Affiliated Companies. So welcome everyone, and Louis, take it away.
Thank you, James. Well, good morning, everyone. Obviously, I'm not the farmer on the panel, but I am a partner in the law firm of Consors and Conway. We are a law firm and government relations firm that for the last 40 years has focused most of our practice on agriculture, natural resources, and we represent a broad array of interests all throughout the food chain on policy issues in Sacramento, from production organizations here based in the Valley to those who service the agricultural industry all the way to the other end of the chain, the grocery industry. So our firm has been actively engaged in food, fiber, and farm policy, regulations, and politics for quite some time. So James, when he called me, he was just asking about going over the issue and looking through the agenda, and we were talking, and I said, wow, that all sounds great. Are you going to have any farmers involved to actually talk about what it's like on the farm today and what they're dealing with? And we started going through some of this, and next thing I know, he was saying, well, would you be the moderator for the panel? So I guess it's back to what my mom always told me, that I just didn't stop talking early enough. So so it is a pleasure to be here with you today and with my panel members to really kind of go through and talk through some of the issues impacting agriculture. So we'll start with some introductions. Daniel, you want to give an introduction?
I'm Daniel Hartwig. I am sometimes I forget my title. I have to look real quick. I'm the Director of Sustainability at Wolf Farming, where I manage our water, which has been taking up most of my time the last few weeks here, obviously. All of our sustainability initiatives and our regulatory affairs. I'm also a farmer on a much, much, much smaller scale as well. Hartwig Brothers Farms, where my brother and I partner on about 20 acres of almonds just outside of town here in Easton. And I guess the last thing I want to say is I'm a proud Bulldog. Hey, thank. I knew that'd get the applause, so.
Hector.
Yes, I'm Hector Lujan. I am the president and CEO of Right Affiliated Companies. We are the largest multi-berry producer in California and the world. We produce throughout the state of California, North America, and 7 other countries around the world. We do this on our own farming. We also partner with small growers and medium-sized growers as well. We are an exclusive producer for Driscoll berries.
Excellent. Well, we are going to focus on some of the issues that these two individuals and others like them in agriculture face on a regular basis every day as agriculture in general moves toward more climate-friendly practices and the like. And Daniel, I want to start with you because you actually have sustainability in your title.
Yeah.
And I think, especially in Sacramento, among policymakers, that probably surprises a lot of people because all we hear about is the importance of sustainable agriculture. But I think it's something you probably do every day.
Yeah, I mean, the great thing about wolf farming is, I mean, it's a family-owned company, right? I think, the misnomer of agriculture, and everybody likes to throw around the concept of big ag and, corporate ag. I mean, I farm 20 acres and I'm a corporation, right? My brother and I incorporated for, because it makes sense for our business. Wolf farming, cares about the soil and they really they're looking at it from a generational standpoint. So when you talk about sustainability, it's making sure the business is there for that next generation, and then making sure we're leaving the soil in better condition, right? So we take a lot of, we do a lot of practices, and I'm sure we'll get into those later here, but take a lot of practices to make sure that we're leaving that soil in the best possible condition for that next generation of farming.
And Hector, when we were talking, kind of preparing for this panel discussion, you connected profitability with sustainability.
Well, yes. I think when you look at producing and looking at what we do, is sustainability comes with efficiency more than just profitability. Is what drives really driving the markup is efficiency and productivity. And in order to be, moving the mark in our business, that comes with profitability as well, but it gives us the opportunity to reinvest in our fields, reinvest in the infrastructure that's needed. And as we look at sustainability, and we're used to, more of an annual crops or multi-annual crops, our investments weren't that long-term. As we're looking now at sustainability, you're looking at very long-term investments that now have to get figured into the equation of our farming operations. And that's a new thing for us, and that takes capital and a little bit of innovation as well.
Well, that's fascinating because the element of capital, I think, is absolutely important in these discussions. And we've had this discussion quite a bit within Sacramento among policymakers who just don't understand how capital intensive agriculture is, and especially as we work on regulations that either move towards the changing of equipment, changing of practices. So Daniel, can you talk about that just a little bit?
Yeah, so I mean, I think I heard mention of the Air District earlier here and some of the programs there, and NRCS and some of these programs. Gosh, I think they've done over 10,000 tractors here in the last few years with some of these programs that are available. At the same time, I mean those are tremendous numbers, and that's doing a great job of helping clean our air. But at the same time, that's covering about 30 to 35% of the cost of a new tractor. You're talking about still having to come up with maybe as a small farmer, maybe $60,000, $70,000. That's a couple years worth of profits for us as a small farmer. And on a larger scale, I mean, if we're replacing multiple pieces of equipment, it's still a really, really large chunk of what you're doing here and trying to make that that turnover. Even if you're looking at investing in cleaner equipment. I mean, that costs even more because now you're talking about a new technology, and there's more and more money that you're having to invest for a new technology rather than something that's a mature technology.
Hector?
Yes, no, I think you're looking at investments that, all of a sudden you weren't planning on. And, I just recently, we talked a little bit about our EV vehicles and trying to get into EV vehicles. And now you're saying, oh, well, now you're looking at ranges. How much of the range can I get? And so the price starts going up again. I look at it, hopefully it's like plasma TVs, right? That they started very expensive and now they're very affordable. But then you look at the equipment to charge the EVs. And if we're going to go into tractors in the future, well, what is it going to take? What kind of facilities to charge? And so a lot of investment and capital into the future needs to be worked into what we need to do and factor into that equation. And when it's too fast for us and for a lot of our small growers is very cost prohibitive at a time. As Daniel mentioned, just new regulations like when we had to update older vehicles, trucks that due to the emissions, that was when we were looking at trucks that were being used on farms just to move fruit around or different things. That all of a sudden, even for a very small grower, was very costly to reinvest 100% back into their business. So we need to be able to look at that more and plan for that better into the future.
Can I piggyback on just, so I mean, and as Hector brought up here, I mean, the EV technology that's out there, and especially the BEV battery, battering that's out there, if I have a tractor driver and I'm trying to work a double shift or I've got to get across a bunch of ground, I mean right now it's super wet outside, right? I mean we're struggling all we can just to try to get tomatoes in the ground, and I think everybody up and down in the valley, in Sacramento and San Joaquin Valley can say the same thing. You're trying to run a double shift, and now it's like, well, you've got to charge this thing for 10 or 12 hours, just to try to get maybe 6 hours of use on it. That's just not practicable for a lot of the things we're trying to do on a farm. So, I mean, there really needs to be a focus on developing either interim technologies until some of the battery technologies are there, like maybe hydrogen or some of these other things that are maybe much lower emissions. But we have to find solutions because right now they just aren't practicable for farming.
Well, you're taking me there. So we're gonna I think there's one word definitely in California that we can use to talk about a variety of issues that impact not only agriculture but business, education, that's infrastructure. We heard the Secretary talk earlier about the needs of some of the bond money to continue to be spent to help with the water infrastructure. We have this goal and carbon neutrality goal of 2045 set by the state, and part of that is moving to zero emission. And I think what happens oftentimes is that, especially the policymakers, they focus on the goal, and then they walk away and not necessarily focus on what it takes to get there. What I'm hearing from a number of clients, especially as we start talking about zero emission technology, is just the lack of infrastructure when it comes to electricity, as an example, and the amount of electricity your farm would need, Daniel, as an example, to actually charge those batteries, and what it might take to actually get there, not only cost but time frame.
Yeah, I mean, from our standpoint, I mean, I think we have, on the worst day or the best day, however you want to look at it, I guess, but we might have 40 tractors running in the course of a day. I don't even know how you would begin to charge something like that on any sort of scale, right? I mean, I don't have an electric truck. I'd like to get one if it ever, if the Rivian would ever start building them in a faster manner. I'd love to get mine, sooner than later. But if you're trying to do home charging on something like that, you're looking at, I think, I think it's 20 hours, 20 miles per every hour, charged. And if you're looking at that from the scale of how hard a tractor works, I mean, it's just not practical. There's not enough infrastructure out there. There's just not enough, transformers, not enough, you're going to crash the grid essentially on farm, and you'd be so scattered all over the place because you'd have such a concentration of, electrical charging in one space, it just wouldn't work. one of the other issues we see, I mean, as more and more solar has gone in, we keep, I don't know that the energy companies, like to admit any of this ever, but we keep seeing more and more, quote unquote, not quote unquote, dirty power essentially that, is causing either low voltage or voltage issues and things shutting off on the ranch. And magically enough, a lot of that's in proximity to some of the solar that's been built. When that solar, kicks off in the middle of the night, sometimes our pumps shut off, and that's, and that's not even, our own solar, it's a neighbor solar, but magically enough, those couple, those pumps, shut off. So, this is all still being figured out, Louis. I mean, it's just not there at the moment to be able to do a lot of these things on a grand scale.
No, I agree. I think that we're farming in more rural areas. We farm more in coastal California, but even in coastal California, a lot of the areas where we're farming, they're not as equipped as you go into more urban areas as well. So we're kind of at the back end maybe of the investment of the infrastructure. So we're a little bit further away, and it does pose challenges to, how fast you can go or what speed, but so there's challenges around it. I think the infrastructure around water, for example, we've done a lot around water for the last 20 years, 15 years, or even more, because as Secretary Ross mentioned, California, we've been on how do we save water. And I was on the trip up here with Luis Calderon, who works with us as well, and he was referencing how in the last, I think 2007 to 2015, we reduced 30% of our water usage, just in that time frame, and by implementing new technologies. And then I looked up a little bit in California on specialty crops. We've been farming since 2020 the same acreage, 3.8 to 3.9 million acres. And we're using about 12% less water. And our value of our crops went up more than 50%. So that means productivity and efficiency. So I think in the farmer in California has been, especially in the specialty crops, really nailing down at investing on the farm on creating efficiencies. Now, the future, the next phase is even harder maybe from an infrastructure standpoint, because I think we've invested a lot in how we farm and utilize our resources that were available to us. Now it comes into even greater infrastructure build-outs as you look into energy becoming a bigger component of the equation. And also, if we're looking at carbon sequestration or other issues that we've talked about in terms of biologicals.
Well, so for both of you, and I think, I do think that the data shows that on a statewide basis over the last few decades.
Yes.
California agriculture has become much more efficient, much more innovative. We're producing more on either the same or amount or less land with less water. And so our productivity has gone up. How does that equate to profitability?
If you look at, and probably people here, previous to the inflation that happened probably in these last 2 years, which hit us as well very hard, you're paying probably very similar for a pound of produce as you were in 2020. So I would say we have gotten a little bit of some of that, some money into, but most of the efficiency gains that we've had have gone back to maintaining low cost of food, affordable food to the consumer. And not enough has been coming back maybe to the farmer to keep investing in a stronger way. Our businesses are alive, but it's actually harder every time for a small grower to keep a strong business or viable business. Our business model where we partner with small growers brings kind of larger company resources and effectiveness to a small grower so that the combination can thrive. But I think a lot of that, you know, I'm not saying business isn't good. It's been good, but it's always been a challenge in agriculture, and it's a sustained challenge over, you know, very volatile periods. I mean, and pricing and weather. You know, productivity gains have gone, but you got to measure our business more over a 3 to 5 year cycle, because it's very hard on a year-to-year basis with all the variables happening around us.
I mean, I think from a profitability standpoint, I mean, if anybody in the room's a nut grower, I mean, you can talk about what's happened there, and a lot of that's not related to our efficiencies. I mean, because we haven't had a whole lot of surface water on the west side, for instance. We've had to put groundwater on, which is not as great for your trees. It's you're going to have soil health or soil health impacts doing those kind of practices, which again kind of drives down some of your productivity. But I mean, if you do look on the longer term scale, if you look at like the innovation of drip irrigation and then burying some of your drip irrigation on processing tomatoes, for instance, I think in 20 years we've doubled basically the production per acre. So I mean, you can make investments and really drive your productivity, and that's good, but it costs a lot of money. And as Hector mentioned, I mean, for a smaller grower. I look at what on a scale perspective. If I had to put drip on for Wolf, it cost me $1, or let's say it costs $1, I guess. On the same scale on my 20-acre farm, if I try to put drip in, it's $2. It's more than twice as expensive on a scaling basis to invest in drip technology. So you as a business, you're really trying to make those hard decisions of whether or not it's worth it, and you're going to see that return.
So no doubt about it, California is a leader globally when it talks about sustainability practices, climate change practices, policies, et cetera. But both of your operations work globally. And so let's just talk just a little bit about some of the global impacts, the global prices, the competition that you face, and how your businesses deal with that.
Go ahead.
I mean, we're impacted. No doubt. Whatever happens. I mean, I forget the number off the top of my head here, so forgive me. But I mean, it's a large percentage of our almond crop gets exported here. So when we have shipping, issues in the ports and things like that, I mean, you end up with a huge backlog of nuts that are being carried forward from the carry-in from the previous year. That impacts price significantly. And you're talking about our cost of production on so many of our crops is twice as expensive. I mean, it's really expensive to do business in California, and it's really expensive to do business in the United States when you compare it to a lot of other places in the world. A lot of that's related to the regulatory environment. There are a lot of, I've been sounding kind of negative up here, so I guess I'll put a little positive spin on it. Some of the more global companies we're working with, are making an effort, and they are pushing. I've been working with some sustainability folks at, whether it's Kraft Heinz or Danone or some of those kind of companies. They are really starting to put more pressure and more emphasis with some of their worldwide growers to focus on sustainability practices, making sure that worker health and worker welfare is important. But those are things we've been doing in California for many, many years, and so that's one of those things where we've had to bear the brunt of those costs and be the leaders there, and it impacts our profitability.
Well, I think looking at the global scale in our industry, that the berries normally you're probably more North America because it's Mexico, the U.S., and Canada on most berries. The only blueberry that really moves throughout the world is the blueberry. And that has a wide impact. In California, for many, many years, or was the founder of the berries, basically, of the market in strawberries, and then I think Driscoll led with the blackberries, and the raspberries really created a boom worldwide. But those were generally produced in California. Blueberries were more of kind of northern hemisphere, southern hemisphere, high chill environment that as new technologies came with southern high bush with lower chill requirements came into California and at the same time went into other regions of the world where now, and that product travels better. But California from that essence is more, used to be covered more months out of the year. It's migrated to a smaller time period, especially in the caneberries and raspberries and blueberries and blackberries. Strawberries still, California is by far, from a quality standpoint and supply standpoint, the leader. Although in California we have two things that in my mind are resources that are diminishing, which is water and people. We have abundant land, and you could say we can have even more land because the water is becoming more of an issue and the land and the people are becoming less abundant. We have to solve and be able to bring people that want to work in agriculture. I think automation in the future, and we hopefully will bring automation that elevates the work for people and also reduces the burden, but it's still far away. So you can get to a point where you don't have enough people and I think in many places today in California, you make choices of what you can actually plant or do based on the people that you will have. And the other is water, right? And we talk a lot about water, but I think we talked a lot about quantity of water, but the quality of water is also dictating the quantity of water. And what we're seeing, especially on the coast, is the quality of water diminishing, and that puts more pressure on using more water to dissolve the salts. So we need quality of water. And when we see California, what I see California as a competitor, in the caneberries, for example, because of people primarily, one, the cost of doing business in California, we had, a big impact to us was a 40-hour work week in agriculture. And where should it have landed? We have our opinion, and probably in the middle would have been really good, but it really dropped our workforce hours by 33%. And so it reduced the amount of people that we can have, and now it's elevating also our cost if we have to do overtime. And so, and the guest worker program is continuing to grow, but it's costly, and regulations in California to get people here and pay for coastal living in California becomes very expensive. So what I see from a competitor standpoint in California, it's a great place to produce berries. I mean, it's probably premier in the world. But competitively against other locations who are figuring out the way to do it and really in good places and delivering a very good product, they're moving away. I believe we're now the last, or one of the last companies that are farming raspberries and blackberries in California, in coastal California. If not, we're probably farming over 95%, 90% of the offering in California, when we used to be maybe more like 60%. And our competition is coming from Mexico, primarily, a little bit in Canada, but primarily in Mexico, and that's booming and it's growing. Because the resources are there, right? They have abundance of water, and they have good climatic conditions, and they have the people. So we have to figure it out. We have to be innovative, and we have to be productive and efficient, and that's what we're trying to do, right? We have operations in Mexico as well, but we believe that in California we can make it work, and it's very hard once you leave California to come back. And we want to make sure that we have a history here. We're a fifth-generation family farming berries in California, and we're committed to making that happen. But we recognize the challenges, and there's some big challenges, especially when you're competing in a very competitive, dynamic environment in the marketplace.
So we've talked a little bit, or we're hitting quite a bit on the cost of doing business, and let's just look at that just a little bit broader. And so we hear oftentimes in Sacramento, the Air Resources Board is responsible for implementing carbon neutrality by 2045, and they want to deal with the transition of trucks and tractors. And they'll come back and they'll tell you, Daniel, well, that's going to cost you, and this is all just numbers, $10 an acre, over time when you do this. And then our friends at the Water Board are going to come and talk to you about salts in the groundwater and how we have to deal with that, and that's going to cost you $3 an acre. Sacramento and a lot of policymakers like to work in silos and believe that their policies are the only ones that are ever going to cost you any money. Talk a little bit about just the, well, you've been hired by Wolf Farms to deal with environmental compliance and all the regulatory agencies that impact or you work with on the farm. Talk a little bit about the breadth of that.
Well, I mean, it's a full-time job essentially, right? I'm sure you probably have a staff of people just trying to keep your rear end out of jail or something.
Yeah, because in some areas, the coast makes the San Joaquin Valley look easy.
Yeah. But no, it is literally a full-time job just trying to keep up on this stuff. And I'll go back and forth with my big grower hat and my little grower hat. But as a 20-acre grower, I can't even fathom how you could begin to start to deal with this. I have to deal with it on a daily basis, so I kind of know the ins and outs and how to do it quickly. But if you're a 300-acre grower or something like that, and it's basically a full-time job to have somebody to manage your food security issues, your water quality issues. There's just no money in it at some point. So it doesn't make sense in a lot of ways to want to do business in California, because they keep stacking a lot of these regulations and the costs, on growers from that perspective. I think I saw a slide earlier. It might have been Secretary Ross's, slide, or maybe the Dr. Petridge after that. I think it was $11 an acre was maybe the value for carbon sequestration. We need water, to be able to do a lot of these practices, right? If we're going to plant cover crop, you can try to rely and pray to God that it does rain. And this year that worked out really well for us. But you could try to, plant cover crop, but your seed cost alone is going to be $50 to $60 an acre, and you're going to sequester, $11 worth of carbon. The economics on some of that stuff just don't really pan out. So yeah, there are definitely economic costs when you look at a lot of this stuff. Again, like I said, if you have to go in and replace an entire fleet of tractors or entire fleet of yard trucks and things like that, those incentive dollars are helpful, and they're very, very useful, and they really do drive a lot of that initiation forward, and you do the practices much more quickly. But it's still dollars out of your pocket that you otherwise might not spend. A truck, I think, gosh, now I sound like my grandfather here, but a truck used to run, a million miles or something like that, and if you're using it to haul raisins to the processor, and you're going to put on, 3,000, miles a year. Well, heck, you can run that thing for years and years and years, but now, you're being forced to implement that a lot faster.
Yeah, I think that also is from dealing with regulations and reporting, is that the state in California is not very coordinated, or at least in unison with the counties and the local governments, agencies, where we're reporting similar information in very different ways. So the burden to report and what they want is very different and creates a lot of burden. So everybody, instead of having one only database or one reporting that serves multiple agencies or multiple levels of government, or should be one that reduces the bureaucracy, reduces the burden on the farm. It used to be only a farmer and a guy, that, a small grower, and then I have a lot of empathy for them, because we're a larger company, and said, oh, well, you need a ranch assistant, you need a ranch this, you need a, and you go to a small grower, he says, that's not what I have. It's very hard for them. So the simpler we can make it in terms of the reporting, the better. The other piece, I think, is that there's a lot of times reporting for reporting, and you go to Ag Water 4.0 right now, where we're at, and we're having to test every well every year. And there's, a lot of money associated with that. Instead of creating, if you have a trend over 3 years, well, start reporting every 3 years. That you see that there's no change in the water quality, okay, let's report it over a longer term period and create efficiencies that allow you to invest in areas where you can draw advancement and not just more restrictions or just reporting for reporting. And then I think that if we allow that the regulatory process to be more flexible to work with the grower, to really foster innovation and not become more restrictive as to how you can create really advancement rather than just more, we feel sometimes that is more tying people's hands. So how do you work in that in a much more dynamic environment? And there are agencies that do it, but I think that that's something that we strive for in the future, and we should be looking at it as to how we can foster solutions. And a lot of times what it seems to is how do we create more restrictions?
I think you bring up a really good point. I mean, I think the agencies, some of the agencies I work with, we've developed a level of trust, right? And so when you have that trust working with an agency, that means a lot. I mean, you can work and talk and try to figure out solutions, right? Because if all you ever have is the stick, in a lot of senses, that doesn't help drive anything. You're going to do the bare minimum to not get hit with the stick, essentially. Instead of actually trying to foster innovation. Mm-hmm. So, I mean, I think from a regulatory standpoint, agencies, I have a great relationship with the Air District, for instance. I see some of them here. They've made the effort to go out and learn about growers and learn about, and growers' practices. We had a field day here, when the ARB, was going to, ban burning of grapevines because it's really, really difficult to chip, grapevines with, wire embedded in them. The Air District and ARB to some degree made the effort to come out and actually learn about our practices and try to figure out how can we make a workable regulation. And I want to applaud things like that, but you have to be solution oriented and you have to be willing to build trust with the folks you're regulating.
Yeah, and I think that's probably the key message out of our discussion today is that there's ways to move forward. And I think without a doubt, agriculture has the record of being innovative, being sustainable. But when it's goal-focused, it happens a lot easier and actually achieves the success. And I'll do the same as a shout out to the San Joaquin Air District for their willingness under extreme circumstances and difficult situations of trying to learn and work with an industry. The Central Valley Water Board has done the same when it's come to salts and water in the valley. We've seen that. We've seen those incentive-based programs. Secretary Ross talked about the dairy industry earlier, and SB 1383 was set up with a goal in mind that if they achieve a certain level of emission reductions, no need for regulations, and they're well on their way. The industry has a way of adapting, investing, and adjusting to make those, achieve those challenges. And so, one other area I want to talk about, and then we'll open it up for some questions. One of the issues that we often hear, especially out of Sacramento, it was discussed earlier by Secretary Ross about the Sustainable Pest Management Plan and other elements, is the shift to organic production. Now, I can say that when the Department of Pesticide Regulation and their Sustainable Pest Management Group was talking about the shift to organics, I'd asked if anyone at the department had ever spoken to a banker because of the oversight that lending and banking has over agriculture, and that the transition to organics doesn't take place just because someone necessarily wants them to. At some point, especially if you're a small grower, it frankly has to take place with permission from the banker. To make sure that you're going to continue to be able to pay those operating loans and others. And both of you have some level of organic production, and so just talk about the realities of producing in an organic environment today.
Okay. So we are a big believer in organic, and about 25% to 30% of our total production is organic. We started going down an avenue of farming organically and then into a place where we started developing our own products. And you can visit Fernando Garcia today here. We have our biofarming solutions that we've started internally in generating products that would complement our organic production in terms of soil amendments and incorporation of biologicals. We're doing our own bees as well in terms of pollinators. What we started seeing in our organic production was a great opportunity to enhance the soil, sequester, have better protection through trichodermas to our root systems, have better use of our water, and enhance basically work in developing a stronger plant. It doesn't necessarily yield us more volume of product per se when you compare to non-organic product. But it gave us also what I believe has transferred that knowledge to our non-organic practices. Our organic isn't much more affordable, it's higher cost in many cases because the yield on just organic isn't there. When we've combined the organic practices into our non-organic production, we've seen also great gains in productivity and more efficient reward, actually a lot of times than just organic. Where organic, you're not as productive in many cases, but normally the market rewards you more for organic. If we didn't get the premium in organic, our business model would not be thriving, and it's more pressured actually because it's a much more limited product in the marketplace. Once you go over a certain threshold, the organic price drops because there's, the demand doesn't go up as much. There is a point, we've had times where organic product has been at the same price point as a non-organic because just the sheer volume in the marketplace, and it's, it puts a lot of pressure on the viability of organic in terms of an economic standpoint. I do believe that, our organic is a great product. We strive to continue to do better. If you look at where we were probably as an industry 20 years ago and the product that is offered today as organic and the efficiencies that have come with it are enormous. But it's when people talk a little bit about sustainability in itself, I think there's great things that are going on in organic, but it's not necessarily a more sustainable product because it's not a more efficient. I relate sustainability with the viability of being able to feed the population in a sustainable way and in an affordable way within the environment as well. And when you're looking at measurements today, right, as you're looking at quantifiable data, what really drives the sustainability opportunity a lot of times is the productivity in itself. And it's been very hard, and I think we can get better with biologicals as we make nutrients more available to the product, to the soil and to the plant itself. But it's not at the point where we're getting those efficiencies yet. So I think there's a false sense in many cases that organic would be, in my mind, more sustainable. I think we can work towards those areas, but productivity and efficiency we need to get there. And there might be a combination where, like we're working now in a combination where you're using both technologies in terms of the best thing for the soil and for the plant that drives efficiency, and I think that there's sustainability there. There's no marketplace right now to say this is a combined product that did all these practices, but that rewards you. But I think that, looking at our practices, we're incorporating that into our whole business model to be more efficient and productive.
I think you bring up, you pretty much said everything there, so that was really good. Thank you for that. I agree. I mean, I think we've taken we actually stumbled into organic because of the drought, starting in 2014, because we couldn't farm a good chunk of our land, so it sat idle for 3 years, and voila, it's organic all of a sudden. But it's worked because of that price premium that we're talking about here. I think I've seen, that the state is looking at, 30% or something like that of an organic target. organic works because of that price premium. So if you get to 30%, I'm pretty confident that the marketplace will drive down that price of organic at that point. And at some point, then any profitability there goes away. So, but you're absolutely right in terms of taking some of the practices, composting and doing a lot of the practices like that, and bringing that back into our conventional practices. They've actually helped quite a bit in terms of improving our soil health. And just improving the quality of the product that we're putting out there. A lot of those organic practices have been really beneficial there. And you're right in terms of that in-between level of not quite organic and not quite conventional. If you're talking about just sustainable practices, those sustainable practices cost additional money. If you're gonna do cover cropping, or if you're gonna commit to not using synthetics or reducing your pesticide usage, those practices are going to cost you additional dollars. So there needs to be some sort of premium if you are trying to drive sustainability. There does need to be a premium in there for that to actually make sense economically to do.
Yeah. And we are trying to create, like our BFS department, a balance that is good for the company and good for sustainability, a balance that drives economic opportunity, that delivers reinvestment. And I think that's the ultimate goal. I think that when you look at organics and what you mentioned about the land, and I think the coast and the valley are different places, because value in the coast is very different on the land than it is here. And when you talk about transitioning land in the coast at rental structures that range from $3,000 to $4,500 an acre, and you're looking at, well, how I have to farm it organically and sell it conventionally or non-organic for 3 years, I lose more than the rent. So the commitment in many cases is do a cover crop. Now, if we can get carbon credits for a cover crop for 3 years, but we have to then sit idle and eat the rent for 3 years. And we were talking, 50, 100 acres, and the amount of acres, for example, that if the state wants to get to 30% of the organic, let's say, and I believe in, in Oxnard or Watson, you're farming, 10, 15,000 acres, and you're saying, okay, I'm going to transfer 3,000 acres. We'll do the math and multiply it by 3 years of that rent, and that's what it's going to cost just to move that ground into organic. So it's very hard right now. We don't see much more ground transferring over because the cost to get there is too high.
Excellent points. And I think this conversation really does highlight something that we need to be focusing on as we move forward. And I do hope that James does this again and we start to see this as more of an annual conversation. But I think it also shows that this was a great place to start it. Fresno State, fantastic college of agriculture, and heart of the Central Valley. But the issues in Fresno and even this part of the valley are very different than the Sacramento Valley, very different than the Central Coast, the Imperial Valley and its issues. And so, and that's another part of the problem that comes out of Sacramento, generally speaking, when we're talking about policies, and it's a one-size-fits-all. And then even though we've got the geographical issues in the San Joaquin Valley, we've got the crop issues. And the issues facing the almond industry are different than the dairy industry versus the cotton industry, et cetera. So it's definitely a complex situation that we're dealing with. And the idea of bringing in more opinions, learning more about the differences in the geographies and the crops, I think is absolutely critical. And then to all the academia in the crowd that's continuing to study these issues and continuing to look at different ways of doing it, inviting production agriculture to the table to test some of the concepts, to throw ideas up on the wall on what can work and what can't work, or how we best get in that direction is something that I implore upon all of you, because I think the record shows that the producers, and this is just a couple of them, but the producers in California want to make those advances and will make those advances. And if they're at the table helping you develop those papers and those concepts, then you'll see the adaptability of those practices happen in a much quicker fashion that'll benefit agriculture, benefit our communities, and the state. So do we want to take some questions? Okay. Any questions? Front row.
Yes, sir.
Thank you, Mr. Brown. I'll talk about it so people can hear me. I appreciate the speaker's conversation about infrastructure and also talking about the gaps between smaller farmers and larger farmers being able to adopt new technologies. So from your experience, what investments or policy changes would you like to see California adopt to close the gaps in access to this infrastructure and also make these adoptions, these technologies more practical?
Did everyone hear the question?
No.
Yeah, he did a nice job.
I liked the way you projected. That was good. I guess I'll address it, and there is no easy answer. So the question was related to, how do you close the gap between large farms and small farms in terms of, implementing new technologies? And a lot of it does come down to incentive dollars. I mean, I wish there was like a free market. I'm a capitalist at heart, right? So I wish there was a free market solution to this. But I mean, a lot of it does come back to incentive dollars, or to I mean, one great example I thought, I'll keep picking on their district here, but I mean, they had a program where where a grower that had a moderate, that a tractor before a larger grower or any grower was really ready to take to the to the junk heap or whatever. They took that tractor that was still good, and then they could pass that newer technology, maybe a Tier 3 engine or something like that, pass it down to a tractor driver that's maybe only putting on a couple hundred hours a year, and wasn't ready, would never probably be ready to trade that tractor in, but for a very nominal fee would be able to get a tractor with low hours, still good quality, and the other grower would get a new tractor out of that. And so things like that, I mean, it's just a slower climb, I think, for small growers. I mean, I think we just have to recognize that. I don't know that there is a great solution other than, incentives and inducements, but even then you still have to come up with usually a large chunk of dough, so.
Yeah, I think for new technologies to come in, I hope that there's more grants to innovators that can work with farmers to get those to come to the farm, to those technologies to be accessible at the farm. Once they're accessible, I think that then there's, how are you going to monetize that new technology, right? And I think there's people coming up with different ideas as, on a per unit basis or different things. But, and I think large companies have, more access to financing and different things that could implement and execute. I'm looking for technology that I can execute over the next 3 years, right? Hopefully the innovators are working with grants and other stuff to get it there. And once it's there, I think for the smaller farmers, how do you create the affordable financing or zero cost financing, or that allows them to incorporate those technologies into their farm in an affordable way, because it's harder for them to do a large capital input, right? Just to talk to you about harvest technology in berries, right now we have harvest states, we don't have any mechanized, but I would think that any mechanized 100% harvesting technology might be, to replace a crew of 10 or 15 people might be like $200,000, right? So I don't think a small grower would be able to do it, but maybe if they had, through some grants or financing that allows them to pay on a per unit basis on some sort of, then that makes sense. And how does you combine the innovators, the financial people, and government to make that accessible to them is important.
Yeah, I think it's important that policy makers need to put money where their mouth is, right? And if we're going to put the goals out there, put the investments in there to actually make it happen. I mean, the issue with electrification right now is that there are operations all throughout the state that want to electrify. We don't have the infrastructure to get it there. And if we did, the cost is going to be borne by that entity to actually make it happen. Or some of the sectors we're moving in one area, and then the commercial sector covers the costs of others. And so that's why when agriculture especially starts talking about energy costs, we start to see those disproportionate costs. The other thing I would say is don't change the rules once the game has started. and that's one of the issues that we see happen quite a bit, is that we get a goal out there and we set down the path, and then that's not good enough at some point. So then we change it all over again. And in a business like agriculture, where you're talking about capital intensive and significant investment, you know, if it's an orchard, 7 years, or, you know, if it's transitioning other commodities, it takes time. And so if you built your business plan on the goal that the policymakers have set, and then they change the goal, it really throws a wrench into all of that's been set. So give us the goal, let the industry do it without changing the rules. Yes, sir.
I've heard that Wolf Farms is putting in quite a significant acreage of cover crops out there. Cover crops have been a really hard sell on the west side because of the water constraints that you guys are under.
Yeah.
So what's the payback on that? And what does your GSA think about that practice?
It's a good question. Thank you, Mr. Willie, for the question here. We actually have 7,000 acres of cover crops this year, and you know, one of the challenging things is, you know, when you're making a decision whether or not to plant cover crops is, you know, there's incentive dollars out there potentially. You know, we've inquired a lot of folks about, you know, finding incentive dollars, trying to get carbon credits for doing some of these things. And, you know, now we've established we have a practice, and now you have the idea, you know, the concept of additionality comes in, right? Next year, we're not taking additional steps to store carbon. So you know, there's a possibility we've lost the opportunity to actually earn any of these credits that folks are out there. Two, you know, even if there were carbon credits available, I think the carbon credit, you know, well, let me back up a second. Two, I've actually inquired quite a few places about trying to get carbon credits here in California, and most of the times, you know, the response I've got is, you know, we're just not ready. You know, people are really hot to trot when you tell them you're doing cover crops, and they want to, you know, finance the you know, the carbon, you know, side of it, and then you say, oh yeah, well, I'm from California, and they say, well, we're just not set up to do that in California. That it's a Midwest-focused model, so there's no that I've been able to find, and maybe I haven't turned over enough rocks yet, but there is no dollars that I've been able to see to finance the cover crop side of it. To answer your question about the GSA, I don't think the GSA has an opinion one way or the other. You know, in Westlands, for instance, which is the water district where we planted them, we actually just went into our SGMA restrictions, so we're restricted to 1.3 acres of pumping per acre, 1.3 acre feet per acre of pumping. We were really relying on or praying that we'd get a wet winter. We usually only get about 4 to 5 inches of rain out there, just enough usually to hopefully get that cover crop up. But one, we were hoping to maybe be able to harvest it as feed, because feed prices have been really high. So that was the economic, you know, one of the economic rationales. Two, you know, as I talked about earlier, we're really focused on soil health and improving our soil health. And we think that, you know, our water penetration will improve, our water, you know, the water stored within the soil will improve by taking these practices, and that we would also be able to reduce the amount of disc passes that we have to do throughout the year because of, you know, for weed control and things like that. We were really encouraged, you know, by some of the smaller results we saw the previous year, that we'd be able to make fewer disc passes, so we'd actually, you know, reduce, you know, the diesel that we have to burn, and our spend essentially by running the discs. So that's kind of the methodology of why we did that.
Oh, we have a question over here.
Thank you. Knowing that we've been going through such a dry time, and now all of a sudden we have a pretty nice looking water situation for the time being, how will you gentlemen be investing in water, or will you be investing in water specifically? And what investments are you looking to make right now? And how much of the grants are actually, I don't see many grants, at least on the state level, available to farmers. It usually goes to districts and nonprofits. Is there, how does all that figure into your purchases coming up?
Well, it's interesting. Our investments, we're looking to invest a lot in water, and one of the strategic places is quality of water. Now, California, you know, we had abundance of water, but I was glad to hear Secretary Ross saying they were incrementing the storage capacity, because we will get into a drought as long if next year we have just a lower than average rainfall. We're back very fast to where we were. So hopefully we get rain year to year. If not, we're trapped, right? So we are already seeing, for example, in areas where farming, where we've imposed restrictions and base restrictions or bases of how much water we can use based on historicals, which if you look at historicals on our side, when we worked, and I said over the last 10 years, or reducing by 30% our water, we're getting penalized on the amount of water that we have allocated, because we saved there was no carrot at the end of the day. So we're looking to invest in quality of water to reduce the quantity of water into the future in our systems. In areas where hopefully we will get state collaboration is when you start treating water and cleaning water is now what are you doing with the brine, and how do you treat the brine, or how do you work together to make that happen, to reduce the total flow of water? Or can we clean, or for example, right now in Oxnard, we're tapped into the Great Water Project, which is water that the city's reclaiming, and I wish every city should be reclaiming and making that water available to agriculture. That would be a huge opportunity. It happened because of different circumstances, but it's a good thing. Right now we're trying to deal with the city to how to really manage it in a good way. But we would be looking to invest in projects like that either we can store water even in reservoirs within our own facilities, where we can treat water, or where we can make more efficient use of water. We are deploying every time more, for example, into substrate growing in some of our caneberries, where we're managing water, and we will probably invest in the future. We're starting to look into recycling our own irrigated water. And so those are the areas from a water infrastructure, from hopefully where we would get support is on reclaimed water around, the coast. We were farming around a lot of urban areas. If we could have more access to the kind of water we're getting out of the Great Water Project, and make it even available to the water districts. And that project was led more by 3 individual growers, including ourselves, in getting it going. Now it's also inclusive of the water district. But that types of projects and commitments are really good. And the other one is driving efficiency. But I want to stress water quality. And that is great water quality, which is great to be utilizing, and we want more of that. So I think those are a little bit of where we're going.
Great question, Don. I mean, with the wet year, we're trying to bank as much as we can. As I mentioned, we are into Sigma, so we're going to try. Basically, we had planned on it being a dry year, and so we knew we were going to be restricted on what we could plant. So there's not a lot of extra plants out there. I mean, now that we've found out how much water we're going to get, so we can't just go drop a bunch of seed in the ground and farm a bunch of extra acreage of anything like that, because it's too late essentially. So we're going to bank as much water as we can. But it does bring up an interesting point in that I think the banks need to also get ready for water to find a way, because I mean, right now, for instance, if you were going to bank 10,000 acre feet of water and it cost you, 100 acre, or $100 an acre foot or something like that, I mean, that's $1 million, right? And so now you have to find a way to finance that. Otherwise, you're basically eating that cost of banking that water. So there needs to be ways to, financial tools to be able to try to figure out how to actually pay for that water in these good years when we've been blessed with so much water, because right now there really isn't a model set up for that. And it's really expensive, and it kind of comes out of your bottom line. And right now it's not great times for farms to be coming up with a lot of extra dough.
All righty. Well, thank you very much, everyone, for your time this morning. We hope it was valuable, and enjoy the rest of the day.
Thank you so much. Louis, Daniel, Hector, thank you so much for that. That was really fantastic. Yeah, thank you guys. Thanks. Also, just want to acknowledge Don Cameron, who you were looking at his photo the entire time. He was supposed to be on the panel. Unfortunately, he was ill today, but Terra Nova Ranch is one of our supporters today, so I do want to just thank Don. If you're watching online, thank you. I'm sorry you couldn't make it today. So I'd like to introduce our next panel, and actually, guys, if you could come up onto the stage and take a seat. This conversation is going to be about profitable repurposing of agricultural lands. So Chantalise Pels is here from Stanislaus State. Welcome. And Chantalise is joined by Jose Rodriguez Flores from UC Merced, Susan Long from Tool Trust, Vicky Espinosa from the Nature Conservancy, and Angel Santiago Fernandez-Bu from Union of Concerned Scientists. So welcome all. And I just want to say that, you know, for those students who are here in the audience or entrepreneurs who are listening, the conversation so far should be ringing bells, because with each challenge, there are, you know, so many fascinating opportunities that the world needs and that are, you know, demanded in real time by you know, our producers here. But anyway, over to you, Chantalise. Thanks so much.
Thank you. Good morning, everyone. My name is Chantalise Pels, and I teach sustainable ag at Stanislaus State, and very happy to be moderating this panel, incredible panelists. Before I introduce them, I wanted to give a little background on what cropland repurposing is and some of the rationale for this, these types of plans and programs. So as many as you know, the Sustainable Groundwater Management Act will impose groundwater use restrictions. These restrictions will result in some estimates, 500,000 to 1 million acres of cropland being taken out of production. This is a daunting challenge for Central Valley agricultural economy, not just for farmers and farm profits, but also for farm worker employment and the local and state economy as a whole. In addition, there are environmental impacts with increased fallow land, such as dust pollution, worsening air quality in the Central Valley, a region with some of the poorest air quality in the nation. Cropland repurposing is an attempt to take the bull by the horns, in a sense. Through strategic planning and through programs such as the multi-stakeholder, multi-benefit land repurposing program, but we'll hear more on from this panel, this can potentially offset some of the negative outcomes. Cropland idling is not a new initiative and has manifested in different formats, such as the USDA Conservation Reserve Program that has over the years supported soil conservation in regions prone to soil erosion. The temporary land retirement programs are underutilized in California. These programs pay landowners to take the land out of production, particularly lands that are not profitable, to implement conservation practices such as planting cover crops to improve soil quality, and these programs account for just 3% of the USDA resource stewardship funding in California from 2012 to 2017 versus a much higher percentage in the nation of 32%. Low enrollment in these programs in California reflects a variety of factors, including low payments and high value for irrigated cropland in the state. In order for land repurposing to benefit multiple interests, program objectives and incentives must align with the socio-environmental and economic realities on the ground. Collaboratives of diverse stakeholders is a novel approach to achieve this. The panel in front of you today are doing this work by working directly with communities and other stakeholders on these strategies and are here today to share their work and insights. Please welcome Vicki Espinoza. She works as a project manager with the Nature Conservancy on strategic restoration. She develops and implements strategies to ensure equitable land repurposing and to achieve water sustainability and habitat restoration. Next, we have Angel Fernandez-Bu, senior climate scientist with the Union of Concerned Scientists and co-founder of the nonprofit Socio-Environmental and Education Network, or SEEN. He focuses on sustainability and land use in the inclusion of vulnerable communities, including affordable technology and overcoming language barriers. And next we have Susan Long. She's the program director of the Tule Basin Land and Water Conservation Trust. Susan manages efforts related to conservation, water, and agriculture, sustainability, and farmer outreach. Jose Rodriguez is a UC Merced PhD candidate with the Environmental Systems Program. His research focuses on groundwater sustainability, climate change adaptation, economic analysis of drought, and is working currently on the multi-benefit land repurposing program in the Tule Subbasin. He does economic analysis of aquifer recharge, among other types of economic analyses. That's a lot, Jose. Each panelist will give a short presentation of their work, and if there is time at the end, we hope to take some questions. And now, go ahead, Vicki.
Hi, everyone. Thanks so much for being here today. I'm going to start off with the multi-benefit land repurposing program and just giving you a very general overview of what it is. How many of you, can I get a show of hands, have heard about this multi-benefit land repurposing program? Okay. All right, so we got a few of you, and then we have a few others to introduce this work to. Alrighty, so over the next few years, there is going to be a need to transition into more sustainable groundwater use in the Central Valley and most of California, specifically in the agricultural regions. And this is in part due because of extended drought that is part of the California climate and weather here. So, and also in part due to the over-reliance and over-pumping of groundwater, specifically in the San Joaquin Valley, which has led to what are called the 6 sins of SGMA. How many of you have heard of SGMA, or the Sustainable Groundwater Management Act? Okay, a lot more hands. That's good to see. And so so a combination of drought and overpumping of groundwater has led to these 6 undesirable results. So the Sustainable Groundwater Management Act aims to address groundwater overdraft by 2040. And in the map behind me, you can see some orange polygons in the region, and those are the critically overdrafted basins, and those are the ones that have severe groundwater overdraft. And so, as Chantalise had mentioned, studies have projected that more than 10 to 20% of agricultural land may need to go out of production or transition into other uses that require less water use. And so this needs to be a coordinated effort and managed properly and strategically so that we're able to protect communities, agricultural communities, as well as farmers and agriculture that the region and the nation rely on. So this managed and coordinated effort is is in part addressed by the Multi-Benefit Land Repurposing Program, which really emphasizes that regional, coordinated, and diverse stakeholder engagement and collaboration. Alrighty, so as part of the Multi-Benefit Land Repurposing Program, a lot of the projects that are funded are to emphasize the reduction of groundwater use. So it does play in part with the Sustainable Groundwater Management Act, but it helps facilitate that transition of irrigated agricultural land. We don't want agricultural land to stay fallowed or without any use, so the alternatives are to have land uses that provide benefits to communities, to ecosystems, as well as agriculture. And some of those uses are low-impact solar, habitat restoration, less water-intensive agriculture, floodplain restoration, and these are only a few. We're working with community members and with farmers and other stakeholders in the subbasin, specifically the Tule subbasin, to make sure that we're encompassing the visions of what the community needs. So the multi-benefit land repurposing really encompasses community health, environmental well-being, economic well-being, and really aiming at that, getting that water supply rebalanced. So reimagining the landscape in order to address groundwater overdraft and using surface water in a way that can recharge those aquifers that are essential for water supply, especially during drought. And I do want to briefly mention that these multi-benefit land repurposing alternatives, land use alternatives, could provide some benefit to flood control. Right now, in the Tule subbasin, we're dealing with a lot of floods. So having that conversation related to drought has been expanded to how can we reimagine this landscape in order to also include flood control for communities as well as agriculture. And so what are some key features of this multi-benefit land repurposing program? Well, it's an up to $10 million grant. Tribes, GSAs, as well as nonprofits can apply to this program. And the key here is it's inclusive planning, diverse partnerships. And in round one of this program, a lot of the grantees did show that diverse stakeholder. So for the Tule subbasin specifically, we have about 11 partners working together, and they encompass community, environmental justice, conservation groups, the GSAs and irrigation districts, as well as farmers, and direct engagement with communities. And so behind me is a diagram of what it looks like. So the multi-benefit land repurposing program is managed by the Department of Conservation. And you can see in the lighter blue, a step below that larger block, are the who can apply to this MLRP program. And so you've got regional blocks, which include these GSAs and irrigation districts and nonprofits to be able to apply, as well as tribal groups. And then we have the statewide support entity, which consists of Environmental Defense Fund and self-help enterprises with support from environmental incentives. And their role is to help these block grantees with making sure that they have the tools that they need to conduct inclusive, collaborative work with communities and diverse stakeholders, as well as providing educational resources that may be needed. This is just a quick recap of what multi-benefit land repurposing is. I am working with the statewide support entity to develop a multi-benefit land repurposing program video series, and it's going to be a series of 5 videos with a lot more detail and a couple examples of what does land repurposing look like, what is it looking like for the Tule subbasin, so stay tuned. And you can check out that YouTube at Cali Water Ag. And if you have any questions, feel free to email me.
Can I go? I think I'm going to stand up.
Yeah.
Is it okay if I stand up? Okay, thank you. Hello, my name is Angel. I see a lot of familiar faces and friends. Thank you for coming. I've been working with, if this is going to happen, I think I will stay here then. Okay, sorry. I've been working with land repurposing, cropland repurposing for maybe the last 4 years. And what we have tried, not me only, but all our team has tried to incorporate the lens of justice into all the studies, all the analysis that we have been conducting Well, Chantelis asked me today to talk a little bit more about the perspectives from rural disadvantaged communities. And I'm going to say that, no, I'm going to talk about it. Before, I would like to say to the farmers here in the audience, I feel your pain. I know it's very, very difficult being a farmer. We know that we don't have enough water in California to sustain our current practices, and we will have to cut some agriculture somewhere. And we are trying to figure out how to do it, minimizing the negative aspects of that, no? And the multi-benefit land repurposing program is trying to do that. It's trying to save water while doing other positive side effects. But anyway, it's going to be very hard, no? Because we are talking about repurposing 10–15% of the agriculture in California based on an estimate of 1.8 million acre-feet of overdraft in the San Joaquin Valley. And a few days ago, I learned that in 2021, the overdraft was 7 million acre-feet. No, it's 4 times more than what we are working with. So maybe we will have to rethink agriculture and how we use the water. And that's going to be difficult. So today I'm going to try to show the perspective from the rural disadvantaged communities, no? And what is, in my opinion, what should be, in our opinion, or in my opinion, the priorities on where and how to repurpose agricultural land in California. And by no means I'm trying to say you have to do that or you have to do the other thing. So this is an aggregated point of view, no? So it's aggregating what we have done in the whole Central Valley. Today I'm going to talk about the San Joaquin Valley, but we're going to talk about 123 communities, no? It's not saying in this community do this or do that, no? It's just thinking about the systems level, right? So first of all, I would like to give you my personal my personal opinion in what a strategic cropland repurposing is. So for me, it consists in changing an economic activity that is producing negative side effects to a new land use that produces positive side effects that benefits everyone. No? And 1 second, almost there. Okay, I want you to think about a rural disadvantaged community, no? We know a lot of communities here, so it's a community that has some agriculture inside and some agriculture around the community, no? And there are 123 communities like this in the San Joaquin Valley. Look, I live in Merced, I live in between Bear Creek and Winton. And these communities are the house for 500,000 residents, right? So if you think about these communities, I would like right now for this first priority that is, again, in my opinion, and again I'm saying that is for the whole San Joaquin Valley or the whole California in general, right? I want you to focus only in the agriculture inside these communities. Agriculture inside these communities represents about 54,000 acres. And it uses about 40 million pounds of synthetic fertilizers, of which about half of it goes directly to the aquifers under the feet of the community residents. That's about 40 pounds of nitrate per person and year, and nitrate is a very toxic component. Okay. Synthetic fertilizers are very inefficient, and about 10% of it becomes greenhouse gas emissions. No? Nitrous oxide is a very potent greenhouse gas, and the emissions equivalent inside these communities from synthetic fertilizers are equivalent to 40,000 fossil fuel cars. And there's only an application of more than 1 million pounds of pesticides. And again, this is between children's house and their school, when they are lucky enough to have a school, or between neighbor houses. No? So this is, like, people get sprayed, you know. The agricultural production inside these communities is about 170 million per year, so this is the revenue. So the profit is probably like a small fraction on that, right? And just imagine about the costs of it for the local communities. In an exercise, you can think about how much it costs to provide 1 gallon of water per person per day in these communities. That costs, oh man, how does it work? Okay, that costs $190 million to provide clean water. And we are talking only about water. We are not talking about healthcare, or we are talking about clean air. You know, from here to Bakersfield, this is the worst air quality in the United States. Fresno, Madera, Kings, Visalia, and Bakersfield have the top 3 worst air quality in the United States. Then, in my opinion, repurposing agriculture inside disadvantaged communities, rural disadvantaged communities, should be a priority for policymakers to incentivize. Again, this is not to take up people, it's like to transition into something that is better for everyone. Now, the second exercise, I would like you to think about agriculture around communities, right? And, you know, there is farms surrounding these communities, and these farms have wells. And the recharge in the San Joaquin Valley, in the Central Valley, is relatively low. No? It's maybe a foot per year an acre. So if this well withdraws maybe 3 acre-feet per acre of farm being there, that well is going to take water from underneath the community. This is more or less how the footprint of that well would look like if it takes 3 acres per acre, right? 3 acre-feet per acre. Now imagine that a community is surrounded by agriculture. This is why wells go dry inside communities, right? And this is not illegal. I mean, the question is, it's not illegal, so farmers are not doing something illegal, but it should be incentivized to repurpose the land around those communities to prevent from this kind of thing to happen. And you may think, oh, but the wells don't always dry. Yeah, sometimes nothing happens, and sometimes happens something like this, no? This is the city of San Joaquin. It's not far away from here. It's in Fresno, Westland. So the most incredible thing with this water is that it meets the standards of the California EPA. So they don't have to do anything to solve this, because this is legally drinkable. Then we have been working in monetizing the cost and benefits, the trade-offs or the opportunities of repurposing agricultural land inside and around communities. And again, I want to say, this is not to tell people what to do. We are talking about aggregated numbers, no? If we create a buffer around communities, a physical separation area that shields people from the exposure to, for example, fertilizers or drying their wells or a pesticide spray, then we can create more resilient communities. No? And what MLRP programs that are trying to incentivize saving water and doing is something like this. No, it's okay. We can create wildlife corridors. We can do aquifer recharge. We can do, this kind of amazing thing, no? Habitat restoration. This is good for society. This is good for agriculture. It's saving water for agriculture, so it's going to meet, the GSAs are going to meet the SIGMA requirements. However, this doesn't bring new opportunities for the communities to become, to develop economically, right? At the end of the day, what brings development is money. What takes out of the disadvantaged label is money. So what we propose, what we have been studying for the last 4 years, is doing something like this, is bringing environmental protection at the same time that we bring socioeconomic opportunities. No? So we need to think at the systems level. For example, we can create wildlife corridors, or we can create even more wildlife corridors, but those wildlife corridors can do something else, like holding some solar panels, maybe also can do part of aquifer recharge, so they do more than one thing. They are economically more feasible, so we can repurpose more land in a way that benefits everyone and no one is harmed. Same for clean industries. So sometimes clean industries use a lot of water, but they don't evaporate the water, so they can reuse it, so they can create their own wastewater facilities, they can dig deeper wells, and they can share them with the communities in a public-private partnership, for example, so they can help each other, and they can help the communities be resilient. They can provide jobs for the communities, but they also can provide other benefits. No? And they can benefit from the government. Obviously, this is up to the policymakers, but they could be incentives to foster this kind of transition. So, what can we do to transform this into this, right? So this is where the money comes, no? Our study, and again, this is aggregating all 123 communities in the San Joaquin Valley. Investing $27 million per year for 10 years. And then the cost of retiring agriculture is about 27, 28 millions in average. This is, of course, in average. Some communities are big, some are smaller. But in average, it's something like this. And jobs is 167 per community. With this kind of investment, we can obtain revenues up to $101 million per year. And we can create more than 400 jobs for this community. And those jobs pay more and are normally more stable than agricultural jobs, okay? And maybe now I can say that I know that the Department of Conservation, the DWR, the new programs are set to save water, and we need to save water, but I also think that the most important is to transform negative side effects into positive side effects. That should be our priority. No, and water is one of the positive, saving water is one of the positive side effects. But I wouldn't repurpose small farmers. I wouldn't repurpose organic agriculture because they are already producing positive side effects. They are good for the community, for the circular economy of the community. They are good for protecting their environment. So there are some things that we should think very well. So my opinion, and with this I will pass it to Susan. My opinion is that we should prioritize repurposing agricultural land, conventional agriculture, inside disadvantaged communities, then around disadvantaged communities. And then whatever is more feasible or is better for everyone, no? Because we will need to retire a lot of agriculture. And that's sad, but it's kind of the truth. So, well, thank you.
So the Tule Basin Land and Water Conservation Trust was founded about 3 years ago to work with primarily the southern Tule Subbasin GSAs, farmers and landowners, to come together and determine what the best practices will be going forward to gain groundwater sustainability, recognizing that there's need for natural habitat restoration, the variety of impacts that our farmers have been faced with for a number of years. And the trust has partnered with a variety of agencies, as Vicki previously mentioned, one being on the multi-land repurposing program. But we also are have sought other funding and are pursuing other avenues simultaneously that will help us help farmers and landowners and our environment, our communities, sustain our way of life. For those of you that are from the Valley here and have maybe grown up around agriculture, that is our way of life. That is what has brought this valley to what it is today, and it is what has sustained us ongoing. And I think our goal is that we recognize, although we may not be able to do it exactly the same, we want to continue that legacy. So one of the programs that the Land Trust the Thule Trust is undergoing is a pilot program for land fallowing, and we did hear about land fallowing earlier today. We currently have about 1,500 acres that are participating in a land fallowing program with cover crop. Of course, with all of our much needed rain, but not necessarily flooding, all of that is pretty much underwater at this point in time, so we're not really sure how that's going to look on the other end as it would have if we would not have experienced the flooding that we are now. But it was a well-recepted program, and we did have several applications that came in. This being our first year in that process, we're eager to learn. We may not learn the same things that we would have learned without the flooding, but we are eager to learn from our landowners what their experiences were, how we can make this better, how we might present this in the future, and make this something that is useful for groundwater sustainability, natural resources, and our environment and the farmer itself. The multi-benefit land repurposing program, we're looking at a variety of different activities and the goal here is to bring together not only the disadvantaged communities, but to also have representation on the farmer and landowner side, and that's really my job, is to reach out, create a farmer advisory board, and make sure that they have a voice and that they have input into what is directly impacting them, and how we can move forward in a manner that's going to benefit everyone. We're looking at restoration projects, recharge projects, fallowing projects, open space. I know Vicki mentioned solar is one project. There's a variety of different opportunities, but identifying not only what those projects could be, but where the best places for those are as well in relationship to access to surface water, access to groundwater recharge aquifers, so where we can actually do some recharge. Those are the areas that we're looking for, and we're seeking that input back from the farmers, the landowners, as well as the communities, so that we could develop a plan of the programs that will be most beneficial, and at the same time identify areas where these programs would also be most beneficial for all. The Trust has also obtained funding for sustainable agricultural land conservation. And this is so that we can do agriculture easements to secure highly productive agricultural land from being converted into usually urban purposes. As we just seen in the maps, our communities tend to grow outward and they grow into the agricultural space, and then that keeps pushing us out now. And sometimes that space is maybe our most productive, has the best resources associated with groundwater, surface water access, things of that nature. So we are also looking at it from a perspective of not taking land always out of production, but really making sure we're preserving that land that is also very important to us and the production of our agriculture here in the valley. Vicki also spoke a little bit about flooding and our need to do some planning there, and the opportunities that this year has provided us with the multi-benefit land repurposing program. The Trust is also working with a watershed coordinator to identify watershed planning so that we can have better things in place when we occur situations such as this year. I think this year has given us a really good view of where we need to put some emphasis. If you don't know, if you're not familiar with the South Valley, much of it's underwater, and there is a number of farms that have lost their crops, lost their dairies, and will likely not see that land dry for 12 to 24 months. And I should say that water is all going on to, most of it, I should say, is going on to ground that will not seep back into our aquifer because it's going over clay, which does not lend itself to recharge our aquifers. So with a watershed coordinator, one of our goals will be to also look at how can we plan for retention of the water as it comes in areas where we can take the most advantage of it by recharging the ground, what conveyance systems maybe need to be put in place, or how that might come about. It's not an overnight fix, obviously. It's a long-term process, but it is something that we will be working on, and we are excited to undergo. Oh, well, I did it. Oh,
Right.
yeah, it's tricky. There we go. So just a quick kind of what our objectives have been and what they are. I think I've kind of covered most of this, but my goal or my job at the trust is really to coordinate with landowners, farmers, and communities to ensure everyone has a voice and that we can brainstorm together what the best solutions are, recognizing that, there's always going to have to be some give and take in every area, but trying to see the perspective of the larger picture and how these programs will benefit all in the long run. In this process, we will also be looking at evaluation of existing terrain, hydrology, conservation corridors, production yields, economic impacts, and recharge capacity, all of which will lead to are valuable in our planning stages in developing these groundwater sustainability plans, and ensuring that projects are placed in the most appropriate areas where we can get the most from them, as well as leaving the land that is most productive and maybe less water intensive for less water-intensive crops available for farming. Vicki is very much involved in helping to develop the core plan for the GSAs in the Tule Basin, and each GSA also has their individual plan as well. So they're all working together to ensure that there is a collaboration and that these plans will not just be set within a boundary, that they will mesh together and have good flow to really provide the best benefits. Obviously, our goal is groundwater sustainability, flood management, and natural habitat restoration. And we want to retain the valuable agricultural land from urban development. We want to minimize the economic impacts and reduce the negative environmental impacts that come from whether it be fallowing land and leaving it bare, or the use of pesticides, whatever that may be. We want to reduce those. And I want to just make one comment on the economic impact. It's not just the economic impact to the farmer. We recognize that there's also economic impact to the community and the people that work on the farms, or maybe even the retail store owner that the farmers or the workers all visit on a daily basis. They're all impacted by all of these changes. So we are trying our best to obtain input from all of them, because we want to ensure that there is still an economic balance that remains along with the balancing of land uses. Thank you. And I'll turn it over to you.
Yeah.
All right. Well, everyone gave a great explanation about the MLRP program, and I hope I have something else to say. Following off what Susan was mentioning about balance, those impacts and those benefits is what I'm going to expand more on my talk. So, okay. So our team, well, I represent a team at UC Merced with Professor Thomas Harmon, who will give a talk later as well, Humberto Flores, Angel, and so our main goal is to do the assessment of this balance of economic losses and economic benefits. And our main goal is to just develop a clear assessment that the Tule Sub-Basin MLRP program can use, but also can inform other land repurposing programs across the state. And our particular goals is to assess those direct impacts, spillover effects from retiring upland, and also characterize those benefits that may rise from repurposing agricultural land and who will get benefits from that. As Susan was saying, there will be trade-offs because agricultural land, of course, has revenue, has jobs that I will talk more about later. But we want to have a clear methodology that farmers and all the partners who are in the program can understand and can trust. Well, everyone said this many times, but the goal of the MLRP program is to balance social, environmental, and agricultural needs while reducing groundwater use. And well, as has been mentioned, agricultural land will be removed. But what we want to do is, as Susan was mentioning, is identify those places where we'll have the minimum economic impact from retired agricultural land and the maximum benefit to society or to the environment. So in order to do this assessment, we are trying to first understand how the agricultural landscape looks like in the Tule Basin currently. So you can see on the map the land IQ crop mapping. So we see that the Tule Basin mostly produces deciduous crops, mostly on the east side, some grain and corn on the west side. And these commodities have revenues. So these revenues were calculated using just the Commissioner report, price and yield. So what we want to understand is, okay, how does this agricultural land, the production, the economics, and also the jobs. So we're just using county scale job data from the state. So we want to understand how the commodities, the revenues, and also jobs are linked to identify just hotspots where land repurposing or just retired land will have the largest impact or the least impact. As one of the main questions is how are we going to assess or how we're going to make comparable something that was agricultural land to something else in terms of revenue, for example. So some of the impact to agriculture is clear. There are revenues that will be lost. There will be jobs. There are spillover effects in the community, in the county. But how does those benefits may compare to that loss? So our team is trying to identify methodologies that allow us to monetize those benefits. And some of them are easy to monetize, but some of them not. And I will talk more about that later. But if we talk about society needs, well, Angel did a great job explaining the problems around disadvantaged communities. So, for example, if we want to maximize the benefit to society, we will prioritize retiring land, as Angel mentioned, closer to the community. So these communities have cost because they have healthcare expenses. These communities wells are vulnerable to go dry, and when they go dry, communities have a cost to fix the well or drill a deeper well. So those are kind of the economics that we want to include in this assessment. So how much reducing the vulnerabilities to face dry wells will compare to retired agricultural land. Well, in the map on your right, I'm showing the location of dry wells in the Tule Subbasin reported from 2014 to earlier this year. And well, we can see like that hotspot that is Porterville, and East Porterville was one of the main communities impacted in the 2012-2016 drought, and one of the communities with the largest number of dry wells. Well, as has been mentioned, there are environmental needs, and some of these are harder to capture their economic value, but there are methodologies that we're trying to include to monetize some of the ecosystem services that they may bring. Yeah, like as has been mentioned, corridors or projects that can benefit groundwater-dependent ecosystems or other wildlife in the area. And to identify, as Susan was mentioning, we need to identify what are the best locations to develop various projects. So we're developing a tool that partners can use, where anyone can use and put the weights on what they prioritize. So it might be maximize or just have the higher preference for agricultural revenues, or a higher preference for beneficial, a project that can be beneficial to society or the ecosystem, or identify hotspots for groundwater recharge. And so this, again, is only at the basin scale, and we're using state-level data that sometimes can be far from very local context. So what I want to say is that this, of course, needs a partnership with farmers that can help us to improve our assessment and help us to characterize the best way local conditions. I would like to expand a little on this, on managed aquifer recharge. Our team is also trying to identify what are the economic benefits of recharge. So as you can see on the on your left-hand side is the index for best groundwater banking. And well, DWR has now new spatial tools that can help us to identify the best place to do this recharge. Well, I will. And what we want to do is compare within for each potential recharge project was the balance of economic benefits and cost. So what we're trying to do is create scenarios with and without recharge within the basin to see how recharge can buffer economic losses and also other variables like jobs, but also how they can reduce the vulnerability of domestic wells to go dry. And with this assessment, we want to help the GSA or water authorities to better sell these kind of projects to farmers or to anyone who is interested to do them. Yeah, well, I think that's it. But I would like just to mention that, as I was mentioning, this kind of work that we're doing is just to have a clear picture of the basin. But further steps are once we identify projects, the assessment needs to be done given the context of the project and what's around them. So in order to do this, we need a lot of communication and trust between the partners, between farmers, communities, and ourselves that are on the academia side. And yeah, I think that's it. Thank you.
I don't know if we have time for any questions. Maybe we could squeeze in one or two. No? Okay. You want to wait for the mic? Is there a mic we could bring?
My question is, the land, we are going to repurpose. I mean, most of them are owned by private owners, right? So if we want to repurpose that land, we should know what the landowners are thinking. So what is the willingness of those landowners toward these repurposing? And I don't know whether you have done that survey or not, but I think that is important. Another thing is, where will you get the money to incentivize those landowners? Are you getting it from the community or from market or from government? Okay, that is important to know before you do these like experimental things or these scientific things. And yeah, the money you are trying to envision for this repurposing thing, what are the sources, and are those sources enough, or what are the other options for generating the money for incentivizing those farmers, those landowners? That's it.
Yeah. Thank you so much for your question. Relating to the first part, private landowner, that's the purpose, at least for the Tule Basin. We're taking the strategy that Susan mentioned in developing a farmer advisory group. And so that farmer advisory group will engage with farmers in the Tule Subbasin to gather their input. Another part of the core plan is that it's a lot of engagement and a lot of collaboration with a lot of different stakeholders, so community members, farmers, tribal groups, and other key stakeholders in the Tule Subbasin, so that this core plan informs GSAs in what land repurposing could look like, and it also incorporates the needs and the visions that the Tule Subbasin community members and stakeholders envision. So it's multifaceted and multi-stakeholder, and it seems a little bit messy, but I think that's what we need to do. We need to have these conversations with so many different partners and so many different perspectives, so that it is an equitable and well-rounded plan in the end. The second question, I believe, was related to incentives. And that is, so part of the funding in implementation comes from the multi-benefit land repurposing grant. Our team for the Tule Subbasin is taking the approach to inform other incentives through other government programs, and even want to create recommendations for policy and financial programs at the state and regional level to help fund and incentivize farmers. There are other partners that are involved, like Audubon and the Nature Conservancy, that do provide incentives as well and have had many years of experience working with farmers and funding farmers to, for example, in Sacramento, it's a different scenario, to flood their field during migratory bird season and leave those their agricultural rice fields flooded so that it provides migratory bird habitat. So there are different ways that we're exploring in providing these recommendations in terms of policy and financial means.
Thank you very much. Thank you to our panel. And I'd just like to let everyone know that we will be publishing the video for all of the panels that you'll be hearing today through the Climate Now website. And this will probably go up in a few days. So it will be there, and slides that you're seeing and all of this information will be there for further review. Our next speaker today is George Paredes. George is the Director of Carbon Management Partnerships at the Lawrence Livermore National Lab, and he's going to be speaking today about the economics of carbon geologic storage on agricultural land. So I'd like to invite George to the stage. Thank you very much.
Okay, great. Well, thank you, James, and hi, everybody. It's a pleasure to be here. I'm George Paredes with the Lawrence Livermore Lab, and we're going to experience a distinct change of gears here, and we have a very short amount of time to cover a pretty deep topic, no pun intended, but let me try and plant some ideas with you. So first slide, please. Yeah. Keep the mic closer to your closer, okay. Is that better? Yeah. There we go. Okay. So we're going to talk about something that farmers could do with their land, particularly in the Central Valley, which is highly suitable for this, at the same time as any other activities which are ongoing and which could both help with climate efforts in the state, but also generate a parallel revenue stream. And this is called geologic sequestration of CO2. So we're going to be tapping into the third dimension. We're going to be going several thousand feet underground. And why are we talking about this to begin with? It's because of climate change. This is a snapshot of the last 800,000 years, CO2 levels in the atmosphere. You know, things have oscillated up and down with the glacial periods. Right now, we've experienced an extremely quick spike, and the Earth has seen levels of CO2 like this in the past, but it was also a very different place when we saw these concentrations in the atmosphere. So we've unleashed a whole bunch of carbon into the air very, very quickly, and it's having pretty profound effects. So governments around the world, including California, have said, well, let's do something about this. And in order to bring things back down to normal, this quiet, gentle climate that we've been used to and taken advantage of, we need to, first of all, stop increasing CO2. But then we also need to bring atmospheric levels of CO2 back down. So what this means is that we need to take CO2 from the atmosphere using a combination of means, and we need to put it back where it came from. So we need to put it on the ground. Next slide, please. This may sound wild or new, but nature did this well before we even thought of it. So when oil and gas deposits were being laid in the ground that we have dug up in a rush, dinosaurs were still roaming the earth, so this started a few 100 million years ago. Things in California are newer, our rocks are more recent, so we are somewhere, the rocks that we are targeting to put CO2 in date somewhere from the Cretaceous to the Eocene, typically. So a few tens of millions of thousands of years. So how does this work? If you sharpen knives, you may have gotten a hint of how this works. You'll see the whetstone bubbling up when you pre-soak it. So rocks, solid rocks like the one you see on the top right, sandstones, have space inside them. You pick them up, they feel and look solid, but inside them they have microscopic spaces. And that's where we're looking to put CO2 in. If you picked it up, it would feel like a normal rock. The vertical dimension, we are going a few thousands of feet underground. So this does not interfere with groundwater. It doesn't interfere with anything that's happening on the surface. And it turns out that you can't put CO2 in there. It's not that hard. What is hard is getting it back out. So the reason that we have oil and gas and brines and natural CO2 concentrations in the world's sedimentary basins is because nature can do this. You put that fluid in there, and then it's hard for it to come out. And there are several mechanisms that keep it down there. We could spend a whole day discussing this. I'm just going to flag it, and happy to answer questions on that in a minute. The middle graphic there is meant to show exactly how deep we're going. So we need to be at least 1 kilometer deep. Typically, that's going to be at least 3,000 feet. Here in California, the primary formations that we're targeting usually range from 5,500, 6,000 feet all the way down to 12,000 feet. So we are going at least a vertical mile down, if not more. Next slide, please. This is meant to convey just how special a place the Central Valley is for doing this sort of thing. You can see on the satellite photo on the left that there's a very clear stretch from Redding all the way down to Bakersfield, where you have very deep sediments. You know, the basement rock is 12,000 feet or even more in some places. And these are sediments that the rivers, the runoff from the Sierra have deposited over geologic time. And the map on the right shows what's called depth to basement. So you see that the Central Valley is a pretty unique place west of the Rockies. And if you look at Nevada, Idaho, Washington, Oregon, you don't see anything similar. So the Central Valley has been essentially gifted with a potential to do this. These are young rocks, they're deep rocks, and they can store a very large amount of CO2 safely and securely. Next slide, please. The structure of these rocks is what's typically known as layer cake geology. So you have this succession of the yellows, which are the sandstones, which have the pore space where you can put the CO2 in. And then you have the white layers, which are essentially the lids. They're the layers that impede and stop the movement of the CO2. So they would typically be shales. And because of how deposition works over geologic time, you get coarse sediments and you get fine sediments. So what we're trying to do here is pick one of the deeper porous layers, one of the yellows, and then you have several stages of impeding layers, they're known as cap rocks, above them, which limit and stop the movement of the CO2. So this stuff goes down a vertical mile. It's covered by hundreds, if not more, feet of really thick, impermeable cap rocks, and that's why it stays down. And this is a cross section here from the Sacramento Basin. I think things change somewhat as you move up and down the valley, but the concept is fundamentally the same. Next slide, please. We know that we have the potential at a high level. What we did about 3 years ago was to take a more detailed look to try and pin down with some more certainty how much CO2 could be stored in these rocks. So we need to simplify the task. We picked only 2 regions, so the Delta and the southern San Joaquin Basin in the Kern County vicinity. And we came up with 2 estimates here. We think that we have at least 17 billion tons of CO2 worth of space, and I'll put that in context in a second. And this number could be as large as 200, so there's some uncertainty, but it's a very large number. For comparison, California emits about 0.4 billion every year. This is the state's entire CO2 emissions. So it's about 400 million tons. We're talking about many, many times worth that. So we can stuff down the entire state's emissions for many decades to come. We're not proposing to do that. That's not the idea. Point is, there's a lot of space down there, and this can occupy the slice of the climate mitigation pie that depends on carbon capture and carbon removal. So that includes both large point sources like cement plants, power plants, refineries, but also you can use the power of nature to grab CO2 from the atmosphere in the form of waste biomass from agricultural operations, from forest fuel reduction efforts, and then you can strip the CO2 from that biomass and you can put it underground. So it is a very large number. Next slide, please. What does this look like? We're not talking about a large network of things that need to find themselves in agricultural lands. The surface footprint is very small. Some of you will be familiar with oil and gas wells, and you can see them in parts of the valley in the hundreds or even thousands. This is a much smaller scale operation. So a single well in good geology could inject about 1 million tons of CO2 underground. That's a sizable portion, a half emissions of a large petroleum refinery, just for a benchmark. So all we're looking at here is at most a handful of wells, per several thousand acres, or per several miles by several miles worth of land. And these would look pretty similar to what you may be used to from oil and gas, but they would look more modern and they would likely be in better shape. You need a small enclosure, and that's it. Farming and other operations can go on as before or undisturbed around them. What happens under the surface doesn't affect that in any way, and you don't need much more infrastructure. You need a way to get the CO2 there. It could be trucked, it could be railed, it could be pipelined, but this is a very small surface footprint kind of endeavor. And these are photos from the top right is a gas well in the Delta. As you can tell, it's seen better days. The bottom two photos are from actual CO2 injection projects. So you can see, similar concept, but more neat, more modern. There's a lot of scrutiny, regulatory scrutiny on these wells. Next slide. So, as we've been making farmers and landowners and mineral owners aware of this idea, the question has come up, what is this worth? And what could I be getting in addition to my traditional farming operations or other land uses? So, trying to address some of these questions, we got the generous funding of the Livermore Lab Foundation to write a small report on this, which I'm previewing right now. It should be out in the next 3 to 4 weeks, I hope. And we tried to answer the question, what does these cost? What does it cost to do one of these projects? And how much headroom remains if you compare costs and revenues that could go to local community benefits, that could go to landowner and mineral owner compensation. And we're also trying to inform policymakers in Sacramento. They look at hard to decarbonize sectors and say, okay, if I want to reduce emissions from, say, cement production, are these projects economical, or is there something additional that I need to provide that sector to make it viable? So that was the purpose of the report. Next and last slide. I'm giving you a preview here of the conclusions. So the biggest picture that emerged, the clearest picture that emerged, was that it's not easy to put your finger on a particular cost number, hence the fuzzy target there on the right. So you typically have pretty large cost ranges depending on your type of project and where your CO2 is coming from. California tends to be on the higher end, but nonetheless, a site near Fresno may be different to a site near Bakersfield, may be different to a site near Redding. The biggest cost is typically from the capture, so it's where you grab the CO2 before you compress it and you pipe it and you inject it on the ground. And the more concentrated, so the higher purity that CO2 stream is, the easier and cheaper it is to capture. Transportation, it could be done by rail, barge, truck, or pipeline. Distance plays a role, and piping is by far the cheapest. And then storage, it is a modest, I would say, overall, but not negligible cost. You need to drill the wells, you need to monitor. So major conclusions, and I'll wrap up. You need to look at the individual projects. So I unfortunately cannot sit here and tell you, there are so many million that remain for farmer revenue. These revenues can fluctuate, so some of them are based on federal tax credits, and we know the value of that, it's fixed, and you get it for 12 years. It's $85 a ton. The other revenue stream comes from a variable instrument, so it's the California Low Carbon Fuel Standard, and that is a traded credit value which can fluctuate. So we've seen in the recent years, we've seen it vary between 60 and just over $200 a ton. So you could see that as also as a large potential upside. If you can make a project work during the doldrum years, then you have a really big upside when the going gets good. Ultimately, I think what this points to, what this emerging picture points to, is that there needs to be a dialogue between landowners and project developers that probably hasn't seen precedent in the past. Oil and gas leases have been typically more boilerplate, indexed to the price of oil or gas. This is different. And in order to figure out what an equitable share of revenue is, you really need to look at that individual project and where the CO2 is coming from. So I think this is both a challenge, but also a promise. I think there are projects where there could be considerable headroom here for local benefits and landowner revenue. And we are at the very outset of this whole endeavor. Some of you may have received calls saying, hey, can we sign a lease for your pore space to put CO2 in? So our hope with this report, and my partner at the Clean Air Task Force and co-author, is to try and shed some light and to see some projects being developed that help not only the climate, but also landowners and farmers. So I'll stop here and see if there are any questions. Thank you.
Thank you for your time, Speaker. I had a quick question. Similar to what we see with fracking, are there any environmental risks to the injection wells? And are they prone to risk? Because I know you talked about we go deep underground to prevent it to get into the groundwater and other infrastructure, but risk with earthquakes and other natural disasters.
Yes, very good question and very reasonable. I think of this as the anti-fracking. So what fracking of shale gas and shale oil did was to target the cap rocks, the shales. So these are the dense rocks that keep the CO2 trapped down there. So they drilled into those, they injected pressurized fluids and other stuff to create a network of fractures. And that's how they essentially pulled together disparate sources of, or blobs, if you like, of oil and gas. With this, you take great care not to fracture anything. So you want those cap rocks to stay intact. Are there risks? Yes, there are risks involved in any engineering endeavor, but I firmly believe that these are manageable. This is, in my view, safer than routine, non-fracking oil and gas production. It's highly regulated. There are probably hundreds of thousands of oil and gas wells in the state. There are currently, I believe, 5 or 6 CO2 injection well permit applications. Each of these takes about 2 years to process, so they're highly scrutinized. There are two things there was one thing that typically people worry about, and that's leakage. I'm less worried about this as someone who spent about 15 years in it. The one that's worth more attention is the one that you just mentioned. It's induced seismicity. Can we cause earthquakes? Yes, you can, but it's also fairly easily avoided. The incidents that you've seen in Oklahoma, where they've started injecting at really high pressures and shaking the ground, they made a pretty predictable mistake. They injected very close to the crystalline basement rock. The fortune that we have here in California is that that rock is, in some places, 12,000 feet deep. So if you're injecting at 6,000 feet, you're well away from these things. So through a combination of screening your site carefully and by how you operate the project, these are risks that can readily be managed. Okay, we're out of time. Thank you for your attention, and happy to continue offline.
Hi, everyone. We're going to take a quick 10-minute break. There's lunch served in the back. So please grab your lunch, stretch your legs for a few, and then the program will start again in 10 minutes. Thank you.
They will tell you their name, they will tell you what they grow, and then a little bit about their family history as well, so that you see that it's all integrated into who they are and into the economy that they prosper for the valley as well. So, Bill, why don't we start with you, please?
Thank you, President. I'm Bill Smitkamp, President and CEO of Wawona Frozen Foods. We are a peach and strawberry processor. We grow peaches here in the Clovis area, and we're celebrating our 60th year in business. My father started in 1945 right out of the Marines, and then was just a good peach grower, and then we got into the frozen food business. Freezing peaches across the nation, there were 15 processors in 1963 when we got into the business. Today, we're the only one of those 16 left. So it's been a tough battle, but we're here. Thank you.
Thank you, Bill. Sarah, please.
Hi, I'm Sarah Wolf. I'm president of WaterWise, which is a consulting company on water supply for agricultural users. And I'm also a partner in my family's farming business, Clark Brothers Farming. We farm primarily on the west side in Westlands Water District, along with my husband's family farms on the west side in Huron, Wolf Farming Company, and then we have some land in Fresno Irrigation District as well, which is quite a drastic difference from Westlands Water District. So I get to work both in the extremes. But our family has been farming in the western part of the San Joaquin Valley since the early 70s, and my family's business actually started in land leveling, which was the original irrigation management system we all used here in the San Joaquin Valley. We leveled our fields so that the fall was precise and we never had too much water in any area of the field. It was slowly moving across to maximize the use of the water supply. So we were some of the early innovators, I don't know if innovators, but maybe implementers of water efficiency. So I'm very excited to talk with this panel.
Thank you very much, Sarah. Dennis Parnagian, please.
I'm Dennis Parnagian. I'm currently the chairman of Fowler Packing Company. It's a family operation. I have 3 younger brothers and 12 nieces and nephews who now run the company. My brothers and I kind of quit 5 years ago. And the next generation, 10 of the 12 manage different divisions of the company. We grow, pack, and market mandarins, table grapes, almonds, and pistachios. And we've been in business 73 years. Wow. And started by my father in 1950. Unfortunately, he passed away in 1980. And my brothers and I just kept going, and it's good. It's okay.
Thank you for being here, Dennis. Joe Del Bosque, please.
Thank you, President Saul. I'm Joe Del Bosque. I'm a melon farmer on the west side of Fresno and Merced counties. My family's been in melons for 3 generations now, going on the 4th. First as migrant workers picking melons in the Imperial Valley and San Joaquin Valley, and then my father is a ranch manager of a farm on the west side. And then I became a farmer in 1985. Today we grow, well, we've been growing melons all along, but we shifted to organic melons honeydews and cantaloupes and watermelons, but we also have done asparagus, tomatoes, and almonds and cherries. That's where we are today. Thank you.
Thank you, Joe. And the idea behind this panel is that you want to hear from people in the field. You want to hear from the farmers. And the first question really is, in what ways are current government policies supporting or undermining ag producers as they attempt to address the challenges of climate change? Let's go with that first. Why don't we start with you, Bill?
Thanks, Mr. President.
Sure.
Because I certainly don't want to throw anybody under the bus, but we in the ag business, I believe, are truly working for the sustainability of our industry, doing the right things, and it seems like as we do good things, we get turned around and policymakers give us 3 more hurdles that we have to climb. So whether it's water, we've been talking about doing something about water. In fact, we've all voted on bonds for water. And have anything happened in the since 1970? I really don't believe so. At least not for me, and I'm a little personal because I've got 60 acres out in Clovis area that are no more peach orchards because I didn't have enough water, and I had to take that 60-acre water so I could grow 300 acres of water. And so it's impacted me as a grower. And then as a frozen food processor, where we use a tremendous amount of water, the wonderful agencies of the state and the government do support us in things that we're trying to do. And that's the important thing about this university, is what can we do with our gray water, our wash water? There's not a damn thing wrong with it, except it has some sugar solids in it. And so we are a strong advocate for the purple pipe side, so that way we can reprocess some of that water. That's
great. Thank you for that. Sarah, on to you, please.
I think I completely agree with Bill. It's very challenging. There are a lot of, I think, challenges put on agriculture to solve a lot of the problems of our state that maybe we have participated in, but are without question not the sole causers of. But I think that, through SGMA, which is the Sustainable Groundwater Management Act, that requires for the first time in California regulation on how much groundwater we pump on our farms, that's probably a very necessary law. However, it's an extremely difficult law for all of us to adhere to. And there are a lot of things within that law that we have to add in as well. We're adding in the water quality, ensuring that wells don't go dry in domestic wells. These are all important components, but it is at the moment solely on the back of agriculture. So it's very challenging. But I would say it's something that is also very exciting because it's forcing us to do things a lot differently and be very creative. And one thing agriculture is extremely good at is adapting. And I think we're seeing that. And one positive example I'd like to put out there today that I think has been dramatically different than what we've been seeing in the past is one of the things is this groundwater management regulation is we're expecting to mitigate a lot of the problem through recharge, through flood flows like we're having right now, and that to capture those flood flows and allow them to percolate into the ground and rebuild our aquifers, which is exactly what we should be doing. It's naturally how the rivers and waterways would have worked in the past prior to dams, and so utilizing that is a great tool. However, since SGMA was passed in 2014 and plans put in place in 2020, we have not legally been able to take that activity and move it forward as farmers. For the first time, and there have been a lot of efforts to do so, the governor passed an executive order 2 weeks ago on March 10th that allows us to legally take those flood flows and put them to what is called a beneficial use through recharge. That is historical, and it's amazing at how quickly that has allowed farmers to change their practices overnight and manage that recharge to the benefit of the aquifer. So those types of actions are things I think we look to for our leadership to do.
Thank you for that. On to you, Dennis.
Thank you. Thank you. So I don't want to rehash. I thought Sarah did an excellent job in regards to Sigma, and she's quite right. I think in the long term, it's the right thing to do for California and for farming and for everybody in regards to water. It's going to have to come to that.
In the long term,
in the
right?
long term, for sure. It probably should have been done long ago, but it's challenging to get there, and it's just one additional burden on agriculture. I will focus on power, energy. It took us a while, but we're now about 80% solar. Our packing facilities use a tremendous amount of power. We have about 1.5 million square feet of cold storage, packing facilities, and they use an awful lot of power. 80% of that now, we have a little over 15 megawatts of solar. And if we didn't get the subsidies from the state and the federal government, I don't think we'd be able to do that. But we've converted, we're starting to convert our vehicles over to electric. So far, that's working out. We'll see how that goes. But I think within reason, the policies are, slowly but surely we're going to get there. It's just another burden and an initial cost, but I think in the long run it will be beneficial and it'll be cost effective.
Thank you, Dennis. Joe?
I've been involved with water for quite a while, and I echo many of the things that Sarah mentioned. We've engineered just an incredible water system here in California since the maybe 30s or 40s to the present, where we can move water from one end of the state to the other end of the state. And that was mentioned by President Kennedy when he did his dedication of San Luis Reservoir, how one part of the state can have an abundance and not the other part of the state. So things were done to try to get these resources from where they're in excess to where they're needed. And that's worked very good, but regulations have bogged these things down. And now that we're seeing some of the impacts of climate change, huge arc storms, floods, and so forth, our state is unable to react or adapt or move without an executive order from the governor. If he hadn't done that, places would have flooded, water would have gone out to the ocean, but thanks to him, we're able to get some of this water and move it. Sometimes it's difficult to just move water 20 miles away because of regulations. Sometimes it's difficult to prepare for floods. I spoke to a supervisor in Merced County after Planada was flooded, and he said, we've been trying to clear the brush in this waterway for 5 years, and the state won't give us permission. And here comes the flood, and not prepared. So I think that government has bogged down. They're failing to be able to react more nimbly, and we need to do that, right? Because we go from drought year one year to flood year the next. It's like that. We go from one day it's sunshine, the next day we're flooding. We need to be able to react, and government needs to, make take some new measures, some new protocols, so that we can do that and not wait for for these things to clear all the regulations and bureaucracy.
Joe, what would these measures or what would these protocols or what would they look like specifically?
I think they would look similar to what the governor's executive orders were. When there were huge flows of water going into the Delta, and there was an opportunity there to pick up some of these floodwaters and move them around the state. But there were regulations, in the operations of the Delta that didn't allow that to happen until he stepped in and he said, let's give ourselves some flexibility with these regulations so we can turn some pumps on and move these floodwaters out to places where we could use them or where we could store them, whether it was San Luis or down in Southern California or into some basin for recharge.
Let's talk a little bit more about water. I think that's a really important issue. And I want to turn to you, Sarah, about that. How do we deal with water when we have these atmospheric rivers coming to us, flooding us, and then we have dry years after that? What are some of your ideas that the state can implement? And specifically, I'm going for the state at this point, right? What do we need to do in order to secure our water for the coming years?
Well, I think Joe's exactly right. I mean, we have these regulatory hurdles that really, I should back up and say we have a water rights system in California that is not built around groundwater, it's built around surface water. And so we're now adapting an entirely different water supply to a set of laws that were built for surface supply. And so that's an immediate challenge, I think, to the regulators. They don't know how to deal with that. So I think that we need to address that first and foremost. But secondly, we have a lot of environmental laws in place for very good reasons. But when you're in an emergency and a flood situation like this, there's justification for waiving some of those. And the requirements of biological reviews and CEQA in a time of flood are just not feasible. The requirements for monitoring stations throughout flood channels that cannot be placed once the flood has occurred are not reasonable. So the governor's executive order was able to waive those, which was critical. But I think going forward, we have to build in the concept that this flood is going to happen maybe once every 5 years. Mm-hmm. And so yes, if you want a monitoring station in the middle of a floodplain, we should do it on an extremely dry year, and you should be supporting us in doing that rather than telling us 2 minutes before the flood starts. Right. So those types of things are where we really need to get more forward thinking. And I think it's challenging for the regulators because they're looking at projects to be implemented now, or what does this do to the environment now, today? Well, in a time of flood, it's not something that you can replicate in an annual activity. So you really have to take a different view of it. And I think this is just a completely different paradigm shift for regulators that they haven't figured out how to handle yet.
Yeah, there's no regular pattern that one can follow. Dennis, please.
I was just going to add that it's disappointing, Sarah, you're right. In the dry years, what disappoints me as well, the reliance on the surface water is one thing, but with all the dry years we've had, our infrastructure in the canals and the delivery systems is so bad, we lose so much water in transferring the water in these canals. Mm-hmm. We could save a lot if they just fixed what they've got, and they haven't done that. It's in such disrepair that what little water we do have, we lose a lot of it on its way to its destination. And so we could just start with that, and that would be quite a help.
As the basis, then, you're proposing, Dennis, is the dam and aquifer management, which goes along with what you're saying, right?
Absolutely.
Repairment of the canals. How do we fix deteriorating levees as well? So all of this infrastructure.
Ponding basins, the canals, levees, Also, there's been a lot of talk about raising the height of the dam.
Right.
10 feet of the existing dams. I mean, those would be cost-effective ways to gain quite a bit of water.
Right.
But I guess it takes situations like this to bring it to the forefront. We'll see.
Yeah, and this truly has been a year that is unique in terms of water. And I hear you, Bill, all the time that you want more water. But the issue is that we don't have the infrastructure in place to adapt to a very wet year.
Well, so I'm probably not going to be politically correct here, but if we spent just half the money that we've spent on rapid rail and dug the holes and used the concrete that we've used over the last 12 or however many years it's been, and dug some big ponds or whatever it takes to store the water when we have had short years, and not let that go out to the ocean, would be one thing. But I think what kind of irks me is in agriculture, we plan, we forecast, and it's never the same. There is never the same day, never the same year that we ever have. So we can plan and forecast, but then when things change, we in ag business have to change on a dime. And we're not doing that. We are not expressing our desires to the legislature, whether it's in Washington, D.C. or up in California, that we have immediate needs, and they kind of fall on deaf ears.
Yeah, and what I hear from this, this first question that is out there is, one, we have laws that tend to be very black and white. And what we need are laws that help us navigate, are more adaptable to what the situation in front of us is. That's one part. The other part that I'm hearing is that the energy aspect that you brought up, Dennis, is really important. The state has a very high threshold and high goal for where we'll be in terms of gas-consuming vehicles, for example.
Correct.
That means that we need to take care of that infrastructure for the transportation part of the state, but then what about the agricultural part of the state and its use of energy?
Right, and the grid, I don't think the grid can take it all. I mean, as we move to more electric-powered vehicles and tractors and everything else, I frankly don't think the grid can handle it.
Right.
I mean, that's part of the problem right now as we get further to the west side. I don't think the infrastructure's there.
Right.
I mean, there's a lot of issues, just a lot of issues.
Yeah.
But I think it results in a lot of need for state investment in infrastructure, both on water and on power, and a concerted effort on getting that here, because I mean, we are kind of the central hub of all of this. We're going to be the creators of the power. We are the conveyors of the water, and if we're storing it in the underground on behalf of agriculture and everybody else, there's going to be a time that Los Angeles needs us to export it out to them or to other areas, and if we don't have that infrastructure now, it's not going to happen.
Yeah, let me move on to the second question. People at my community at Fresno State has often heard me say this before. By the year 2050, which is not too far off from now, we will be 9 billion people in the world, and we'll have to produce 60% more food to feed everyone. This food has to be produced here because we are the agricultural powerhouse of the world and of history, essentially. I'll give you just some brief highlights of what California agriculture represents. We produce more than 400 commodities. Most of the fruit, vegetables, and nuts of the U.S. are produced here. Effectively, within 100 miles of Fresno, 25% of all the food of the U.S. is produced. This is really how critical we are to food security in the U.S. 100%, we produce 100% of commercial almonds in the US, 100% of commercial almonds in North America, 80% of commercial almonds worldwide. I'm not going to highlight, the other areas, but I want to talk about dairy, grapes. 98% of the grapes in the U.S. that are consumed are from California. Cannabis is an very upcoming industry as well. Strawberries, very important. 98% of all the broccoli in the U.S. is produced in California as well. And of course, peaches, 70% of the peaches of the U.S. come from California, primarily from Bill's farm. So I wanted to give you that one, Bill.
We need more, too.
Exactly. So I want to talk about, within this context then, I want to talk about this notion that people have been using recently that say, an almond, prohibitive, right? For every almond grown, we produce we have to use 1 gallon. 1 gallon of water has to be used for every almond. We don't ever talk about how much is being used in terms of water, in terms of laptops, or in terms of tables, or in terms of anything else that you can think of, right? When in reality, this is food that we need for the everyday. So within that context, then, the question deals with the Farm Bill. The Farm Bill is this bill that is renewed every 5 years, and it's up for renewal this year. So the question for the panel, and I'm going to start with you, Joe, on the other side, what do you and others in the ag sector want to see in the upcoming Farm Bill at the national level that is going to impact you on the local level so that we can keep producing that 25% of the food for the nation?
Well, first of all, for a lot of you who are not familiar with the Farm Bill, and I'm certainly not an expert in the Farm Bill, but you need to know that 80% of the Farm Bill is about nutrition, and only 20% of it is for agriculture. And in that 20%, really a small portion, you might say, is beneficial to California agriculture. The reason being is what Dr. Saul said. California produces fruits and vegetables and nuts, which are considered specialty crops. And most of the Farm Bill is kind of aimed at, the grains and so forth. So we in California that produce all these specialty crops, and I do want to say this, I want to thank the doctor from Lawrence Livermore. We are in a very special place, this Central Valley, to be able to grow all these things. But being a specialty crop grower, we need to have more government help in things like innovation to help us to be able to handle these special crops mechanically or whatever. We need to, more help with things like food safety of all these, fresh fruits and vegetables that we eat. We need to have more help with, or I should say, a more updated and modern set of crop insurance that covers more of these crops, and also more of these disasters, right? Like flood, right? Things like that maybe we don't have right now. So those are just some of the few things that I see that are beneficial for California agriculture.
Thank you, Joe. Dennis, on to you, please, in terms of the Farm Bill.
Yeah. Joe hit the nail on the head. That's exactly right. We are not big ag. We think we are here, but we're not. It's corn, wheat, soybeans. It's everything in the Midwest. Not us. We might think we are, but we're not. We're specialty ag, and we get short shrift in Washington. We don't really amount to too much. But on the national level, as President Jimenez Sandoval said, without us, our quality of life wouldn't be that good.
Yeah, that's exactly it.
It just wouldn't be. And the people in Washington would sorely miss it if California wasn't here. The world would miss us terribly. So we may only get 20% of the Farm Bill, but this goes beyond the Farm Bill. We need money. We need more water storage. We need more conveyance systems. We need more, if not dams, we need more reservoir. We need temperance flats. Temperance flats, they tell me, can hold 1.3 million acre feet of water. Well, Milton Lake holds 500,000. Temperance flats is a slam dunk. How come we're not doing it? I mean, come on. This is not rocket science. This should be a simple slam dunk kind of a deal. And you get recreation with it, and you get everything else. I mean, we've got to wake up here, or we're going to lose it. This valley is so unique, it's so special, and we don't treat it that way. It is a very unique place in the world, and you can't manufacture this. It just happened to be, and we're right in the middle of it. And if we don't take it seriously, we're going to lose it. We're going to lose it, and I don't want to do that. And again, Joe brought up financing. You know, when I went to high school, gosh, this valley was dotted with 20 and 40 acre farms, and you know, parents could, some of them had side jobs, but you could farm and you could live a kind of a middle-class life and buy a car maybe every 7 years and put your children through school. Those days are gone. I mean, today it's maybe 160 or 300 acres that you have to just survive. It's a different time. I'm sad to see that go. I think it's bad. I think farming and agriculture is a very important part of the fabric of any society. And when you lose it, something is lost for the country. And Fresno State is a unique school in that regard because it's training agricultural leaders for the future. And this country needs that. Anyway, I don't.
Yeah, thank you, Dennis.
Getting off topic here.
No, you're not actually. You know, I'm hearing from you two really powerful insights. One, we are in a unique place in the world, and two, you cannot manufacture this elsewhere in the world. If we don't grow it, no one else will grow it. And three, I'm going to put a third one there. The specialty ag brings joy to our lives. I don't know that I would be able to be happy with just corn, wheat, and soybeans. I want those berries and that wine, you know. On to you, Sarah, please, to the Farm Bill.
I don't know that I can add a lot on the Farm Bill. I think the ones I would mention are very similar to what Joe brought up. You know, we're a unique growing region, and so the Farm Bill historically written for much more basic crops than the specialty crops we grow. And so I think the insurance program is critically important to us here in California, especially with this changing climate, and how you adapt that insurance program to those needs are necessary as well. But I think Bill probably with the school lunch program could say a lot more on the Farm Bill.
Well, Farm Bill's really, really important when it comes to research and dollars coming out of that. On the nutrition side, Wawona's producing over 100 million fruit cups a year that goes to all the school lunch programs across the nation, and that's funded all out of the Farm Bill. But the thing about California, and we are the specialty crop king. We need to make sure that we have the research that fits with the water and fits with the sustainability that y'all have been talking about and listening to today, collectively moving the ball forward rather than backwards. Water's key. Water, we use, I'm not even going to tell you how much water we use during the summer on our processing line, but it's all about food safety. And the Farm Bill has, again, not their focus on specialty crops. They've got them on the commodity side. So when we use so much water for food safety, because frozen fruit, I'll give you a little note, frozen fruit is ready to eat. Frozen vegetables are not. So those of you that go home and buy your frozen beans and put them in a summer salad and put them out, you should be blanching those one more time, just for notice. But we in the fruit program, the second that we process it, no heat's touching that fruit, whether it's a strawberry from Ryder Farms or peaches from Dennis used to grow peaches for us, but from one or 60 of our other 65 outside growers. It's key that we have the highest standard of GMPs and sanitation in all of our facilities. Now, if we don't support what we're doing here in the United States and we let the product come in from China or Greece when it comes to peaches, or even Chile, there's a food security there, right? So we need to make sure, and that's in the Farm Bill, to make sure that we do the right things. I was back there last June talking to them, and one of our plights in the Farm Bill is all this money goes towards fresh produce. Fresh produce. Now, any of you can go down to the grocery store and try to buy a fresh peach, and you won't find one. You'll find some fresh strawberries. You'll find different things. But we advocate for all forms, frozen, canned, dried, and fresh. And so that's really what we're trying to do on our side.
Yeah, and I will say
we
that
should move to a Q&A.
Okay. All right, really quick, I will say that that food security, if we import from other countries into the U.S., also dovetails into a very real flavor security. Because when you eat those peaches from other countries, they just don't have the taste that your peaches have. So
there you go.
Thanks, Al.
All right, a Q&A for the group, please. Please give them a round of applause for their answers. They're just phenomenal.
We have a question from our online audience, which I'll read off here really quick. They ask, is it feasible to install above the California aqueduct solar panels to generate massive amounts of electricity and reduce water evaporation? Thank you. What do you guys think?
I'll try to answer that. You know, I don't know really how much evaporation that would save, but I think I can say this, and I'm not an engineer, but I think it's a lot cheaper to put those solar panels on the canal bank than try to put them across the water. And in addition to that, you know, solar panels have to be somewhere near, you know, what do you call them, substations or someplace you can connect there. So it sounds like a great idea, but I'm not sold on it yet.
I would just add that Turlock Irrigation District has received a grant to do this on some of their canals. And, you know, I think it is challenging, just as Joe said, there's a lot of engineering hurdles that need to be accomplished to get this done. There's maintenance of the canal and maintenance of the solar panels, but they're working on it. I think it's a great pilot. We'll see how it works, and we'll see if it actually is able to generate some savings in the water supply.
I have a question back here.
I'm curious how many of you are familiar with the water blueprint to the San Joaquin Valley. Our fish screens up at the pumping plants at both the federal and the state are 60 years old. They were designed when those guys were supplying a maximum of 16 million people in this state. Just upgrading the fish screens alone could ensure that San Luis Reservoir starts off full every year. And I'm surprised we're not hearing more about that, and I'd like your thoughts.
Yes, I am familiar with the blueprint. The blueprint is a organization that was formed, I think about 4 or 5 years ago, to bring all the various water agencies and water users together to try to have a joint message on what infrastructure and policy needs are needed here for in the valley to promote with respect to water supply. And they do have ongoing lists that they have put together on behalf of all agencies as to infrastructure projects that need to be accomplished to get a lot of these water supply enhancements done. And I think to your point on the fish screens, it's similar whether it's a canal or it's a dam. All of these facilities need upgrade and maintenance, and we have woefully ignored this issue in the state of California. We have dams that cannot hold their historical capacity due to subsidence or degradation of the dams that just need to be maintained and brought up to standards so that they can hold what they historically did hold. As some would benefit from just small raises, like Dennis mentioned, a 10-foot raise, we'd have a tremendous amount of water supply added to the top of those dams. So we have a major maintenance and infrastructure hole that we need to dig out of in California.
Yes, please, right here, right in front. Yeah, and I'll repeat the question. Or third, he's coming to you. James is coming.
Thank you. I was interested to hear you mention interest in expanding crop insurance to specialty crops. So I'm wondering if you could speak a little more specifically about exactly what you would like that to look like. For example, would you want ARC expanded to include specialty crops? And an argument that I've heard against this is that it would make it easier to produce specialty crops and expand, increase access into being in that market, so that growers, I've heard an argument is that growers don't want it to be easier to get into the market, to have more competition, and they want the high premium. Well, I don't know about all the exact economic cascades, but anyway, is there any water to that you actually would want? You wouldn't want those supports in order to not expand access to growing?
No, I don't have those feelings. I think I don't want to put words in Joe's mouth, but my concern would be the crops that we grow, we can get crop insurance, but we can't get it for a disaster. I saw some orchards that were 3 feet underwater, and I don't think there's any insurance for that. Disaster, fire, flood, earthquake, things like that. This particular farmer had 300 acres underwater. I don't think that's going to survive it.
Yeah.
And
those trees take a long time to produce.
Yeah. Right. So these were, I think, 3 or 4 year old trees.
Yeah.
So that's all gone. And I don't know how you're going to have to recover from that. Sorry. Crop insurance shouldn't make you whole. It should just help you cover your expenses. Right. And that's how we treat it. Anyway.
Joe, any thoughts from you?
Well, crop insurance is pretty expensive, and but it is an important thing for a lot of different crops. And for instance, but it's not available to all crops. It's not available to melons. It is available to tomatoes. They define what factors they're insured for, and it's not everything. So I'm not an expert on crop insurance, but I think that there could be some improvements to help farmers to survive some of these challenges that we face. It could be anything. It could be, sometimes we have damage to heat, and that may not be covered by crop insurance, because you've seen, we've had these high temperatures where we've actually lost some of our crop, or at least it doesn't become marketable. So there's things that can be improved in the crop insurance programs.
We have time for one more question, I believe.
Right back there, please.
Jill has the microphone.
Yeah.
I want to get the panel's take on subsidies. So in the United States, the big subsidized crops are corn, soy, and despite the subsidies, the family farms slowly, because of competition with the big industrial companies, it just couldn't stay in business. And so the big industrial companies make these bigger and bigger mega farms. The food products, food ingredients that we get from corn and soy are hydrogenated oils, high fructose corn syrup, really cheap ingredients. that make processed foods that are low in nutrition. These products are killing Americans. We have a diabetes epidemic. That means we have so many people that are obese with diabetes that soon we will have more people on disability than we do working because of malnutrition and disease associated with obesity. And it just kills me that in the United States, especially California, we're growing all these beautiful foods that lead to wellness and life and joy, like Mr. President said. I would like to contrast it with Italy. What are the subsidized crops in Italy? The foods that bring us joy: olives, olive oil, fruits and vegetables. And in fact, California olive oil producers have a very difficult time meeting the price point of the Italian oils because they are being made from subsidized crops. So what is your take, and how can California specialty crops, how can we raise up these companies that have benefited so much from subsidies just get bigger and more powerful? They have lobbyists in Washington. How can we rise up and change how we're handling food policy in the United States?
Dennis, why don't you go first? You were the one who said that they bring us joy, so.
Well, unfortunately, corn syrup is very addictive, and it's like a cocaine, I guess. I mean, and these processors and manufacturers, food manufacturers, just are, they just love it, and it hooks everybody. And this is a fast food nation, unlike Italy and some of the European countries where they go grocery shopping almost daily. And so they're more apt to buy fresh fruits on a daily or twice or 3 times a week, where American shoppers just don't act that way. And I don't know, it's a cultural situation. I try as we might to promote our fresh products. It's hard to compete against candies and processed foods. It just is. I mean, we spend a lot of money trying to market and promote fresh fruits and vegetables and nuts.
If I might say something.
Yeah, sure.
You know, I think if you looked at the history of the Farm Bill, it was basically designed to prevent food shortages, right? Probably in the 1930s when there could have been food shortages. And so they subsidized the very basic, most staple foods, which were grains. But we're in a different time today. And as you say, it's not about having enough calories anymore. It's about having the right nutrition. And you know, my daughter's sitting over there, and she's watching what I eat, and she's telling me that what things I shouldn't be eating, and so forth. And that's what my doctor says too. And that's what we grow. And that's what we grow in California. That's what people need to understand. Why do we need agriculture in California? This is what I told the President Obama when he came to my farm. I said, we in California grow the things that Mrs. Obama would like to see our children eating to have a healthier diet. That's what we grow. And so what we need to do is not necessarily subsidize our crops, but we need to ensure that California farmers have what they need to grow these crops. And that, number one, is water, okay? And other resources like possibly a reliable labor supply and so on. So that's my 2 cents.
Yeah. Bill, what about you? Any thoughts from this?
Well, my immediate thought is it starts with all of us. First off, we should be buying only United States produce. But it goes much deeper than that because we're comfort food people, although comfort food is really kind of going out to the side. But I think it's really, it needs to start with all of us. We need to be educating the kids better, but you know, it's going to be a long draw. That's my take.
Sarah, you'll end this one, and then I'll end the session with brief comments.
Well, I think it's been said very well here. I think in the United States, we need to value our agricultural production. And by valuing it, we invest in infrastructure that supports it, and we value the producers that produce it, and we value the people that work it. And so all of those factors have to be supported by our communities and our country. And at the moment, I don't believe that's the state we're in. And so promoting that is what I think needs to be the goal for all of us.
Yeah, and I'm going to end with that. Again, my university community has heard me say this before. In California, we have three top products that the world over knows us very clearly. Is Hollywood, number one. Number two is Silicon Valley. And number three is us. Number three is agriculture, California agriculture. However, there's no value added to agriculture for the most part, and we are just left as the middle space that nobody wants to go to. So that's number one. Number two, whenever legislature is passed, they should ask the experts. They should ask this panel what they think of what these laws are going to do and how the impact of these laws what the impact will be, not only on the farm, but also on the economy and on the community itself as well. Number three, what I'm hearing from all the panel experts, farmers, is that the state needs to invest in infrastructure. The state needs to invest in infrastructure dealing with water and dealing with energy specifically as well. And with that, I want to thank the panel, Bill Smitkamp, Sarah Wolf, Dennis Parnagan, and Joe Del Bosque. Please give them a hand.
Thank you so much. Terrific. Terrific panel. Thank you. Thank you all. I'd like to introduce our next panel. And this is our one of our favorite topics today on water preservation. So if we could come on up. Oh, terrific, yes. So leading this panel is Charles Hillier from the California Water Institute. And this panel will be a little bit of a different format, so we'll be interactive with the audience throughout. And we have panelists Benjamin Francis from the Wet Center at Fresno State, Richard Restuccia from Jane Irrigation, Caitlin Peterson from PPIC, Aaron Fukuda from Tulare Irrigation District, and Claude Corcos from Netafilm. Welcome.
Okay. Thank you. Oh, so well, these guys. That's what they told us. Is that better? Okay. So while everybody's finding their seats, I want to take a moment to say that Hella Peterson is unwell, and so she sent Assistant Director Benjamin Francis. He's the Assistant Director of the Water for Energy Technology Center. Are we running out of chairs here? We're out of chairs. Oh. No, actually, that's your chair. I'm going to stand over here in case a fight breaks out so that I'm not in the middle of it. Okay, so the idea here is that we've got a cross-section of industry, academia, and public policy and administration. And we are here to talk about enhancing and preserving water in the San Joaquin Valley. So we're hoping that this is a very interactive discussion. So we have some set questions that I'm going to be asking the panelists. But we'd also like to invite all of you to ask questions as well. So let's start with some quick introductions from this end of the table to that end. Just take 2 or 3 minutes to tell us who you are and what you do.
Hello, my name is Benjamin Francis. As Charles said, I'm replacing Helle Peterson, Director of the Wet Center. I am the Assistant Director. The Wet Center stands for Water Energy Technology Center. For those of you who don't know, that's right down here on campus. It's an incubator with plenty of office space for startups in the water, energy, and ag technology space. In addition, we have programs on helping startups from the Valley, the country, and around the world come here in the Valley and commercialize and grow their business and create jobs in the area. So we've been doing that for about 5 years. To date, the companies that have been a part of our program have gone on and raised over $200 million in capital and have continued to do significant sales in the Valley. So we've been very happy with those results here, and glad to speak more, at least from the startup side and things we're seeing.
Richard?
Yeah, thank you. I'm Richard Restuccia. I'm Vice President of Water Management Solutions at Jane Irrigation. I've been involved in the irrigation industry for over 20 years now. I've served on the Irrigation Association Board of Directors. I've been writing about conservation and sustainability in water for over 10 years now. I currently manage the Jane blog on water conservation, and I also have the Jane Irrigation Training Series that is a weekly webinar that brings water management education to people all over the world. Thank you.
Caitlin?
Good afternoon, everyone. I'm Katie Peterson. I'm the Associate Director and a Research Fellow at the Water Policy Center at the Public Policy Institute of California. If you don't know us at PPIC, our mission is basically to take the 10,000-foot view on everything water, land, and air in the state of California. Particularly in the last 5 or 6 years, we've taken a deeper focus on the San Joaquin Valley and how the changing water situation impacts agriculture, the economy, communities, and the environment in the valley. So we've basically been crunching the numbers on what the transition to groundwater sustainability would mean, what it would cost, and what are the different agricultural management and land management approaches and water management approaches we can take to sort of mitigate those costs. So happy to discuss that more in this conversation.
Good afternoon, everybody. My name's Aaron Fukuda. I'm the General Manager of the Tulare Irrigation District and the Interim General Manager of the Mid-Cahuilla Groundwater Sustainability Agency. So I have a suicide mission, is what everybody said, as we looked at what happened. We've transitioned from severe drought to severe flooding, all within a period of months. And I guess I'm here to talk about how our district has kind of bridged that transition with some technology, a lot of hard decisions and policies that were put in place during the drought and are netting us benefits now during this wet period. So look forward to the questions, and thank you very much.
Hi, good afternoon. My name is Claude Corcos. I'm Vice President of Business Strategy and New Business Development at Netafim Irrigation. If you don't know Netafim, Netafim invented drip irrigation in 1965 in Israel, and then has taken that and commercialized that around the world to become the largest irrigation company in the world. We operate in 140 countries around the world. Anywhere where they grow food, we're present. So our businesses are located here in California for the United States. That's where our headquarters is, right by the airport here in Fresno. I live just right up the road here. We deal, because we're a global company and we've been around a long time, we deal with virtually every crop. So the specialty crops that we just talked about, they're here in California. That is the primary part of our business, but we also are pretty active in the commodity groups as well. So doing some irrigation in those corn, soybean, and wheat crops and rice that we heard about. They're kind of bigger on the Farm Bill. That's it.
Thank you. So again, this is meant to be an interactive session. So I have some questions that I'm going to ask the panel members, and these are meant to hopefully prompt more questions from you guys. So there are people with microphones who can move throughout the audience. If you'd like to ask a question, just raise your hand. I'll hopefully see you even though with the lights, but wave your hand at me and we'll get somebody to bring the microphone over to you. So again, this panel is about enhancing and preserving water in the San Joaquin Valley. And one of the things that people often look to help with enhance and preserve is technology. So drip irrigation is pretty well known as being a technological advancement over sprinkler and surface irrigation. But flood irrigations come up a bit in terms of another way to get water back into the aquifer. So question to Aaron, flood also had a reputation for being very inefficient. Is flood still considered bad?
In our district, it was never bad. We actually incentivized it, or that was part of the return cycle of surface water to our groundwater system. So from a broader scale, if you look at our irrigation district, we were, our earth and canal systems, we weren't lining to get that percolation. So what we promote in our irrigation district is the most efficient farmers that can drip in drought and flood in wet. Again, looking at last year and getting prepared for drought conditions, we established a groundwater cutback allocation system, a tracking system, an online tool to track that, and then we turn over into this year and we have excessive flood flows coming our way. Traditionally, when we would open up our orders in January, we would have 6 orders the day we open, and about 300 CFS running through our system for recharge. When we opened the phones on, I think it was January 15th, we had 80 irrigation turnout orders by about 11 o'clock in the morning, and by the next day we were up to about 125 orders. Our system was taking in about 750 CFS, so we had basically essentially doubled that. And I know everybody's asking me, well, that's on-farm recharge, Agmar, those sort of things. It's not, it's winter irrigation. It went through the same canal, through the same turnout, to the same field. And if you were to walk out there, it just looks like they had it furrowed up and they were irrigating down furrows or just flood irrigating checks. Or we did even have growers shove it through their drip systems because they had ripped out their flood systems. So the only way they could get it on the field was through the drip. Those folks are now putting their flood systems back in. So in our flood irrigation district has a place in the water cycle. I think it's a healthy practice where it can be done. There are some areas and some reasons why you wouldn't want to do it, but in our district, it's a benefit.
Thank you. Again, anyone has questions, just raise your hand. Yes, sir.
Thank you to our panel for being here today. I wanted to get your thoughts on desalination plants. There have been some controversy around them, with some projects being rejected, others being accepted. What are your thoughts on the future of desalination, how it can help improve water access in the state and help improve water access in the Central Valley as well with distribution?
Anybody like to take a stab at that?
Well, I can say a few words about that. I think it's definitely going to play a role in sort of our water supply portfolio as a state. Given how expensive water from desalination plants is, I think the most likely role is as an urban, a source of urban supply and a way to diversify urban portfolios, which can in turn relieve some pressure on pressure of demand from the valley and our State Water Project, Central Valley Project. So that's sort of where it fits into the puzzle for me.
Again, I'm in the Central Valley, but, dealing in water and trying to look at statewide issues, the only way I've looked at it or seen it and thought about it was for the urban centers that have this extreme cost, agriculture can actually subsidize that cost for urbans in that the supply that they were getting from like the coastal aqueduct can be reallocated back into the Central Valley for agriculture. We pay a fee for that water, and then it subsidizes the desalinated water potentially. But again, I don't envision that water making it back up and over the hill, but if you're able to get the coastal communities on desal, that could free up, because there is quite a bit of water that does go from the system out towards the coastal areas.
I think it's interesting, too, if you look in places like Saudi Arabia, where they do a lot of desal. They might pump it 300 miles, but they have the energy to do that. We find that they use the desal for people and the fresh water for plants. And I think that would be another challenge we would have to deal with and face.
Thank you for that question. So coming back to technology for a second, we heard about how surface irrigation is now becoming more viable for groundwater recharge. But for Claude, what do you see as the future of high-efficiency irrigation technologies in preventing usage of water in areas that will not cause impacts?
So I think the first part of that, I want to kind of answer that in maybe two different ways, right? So the first thing you have to look at is separating the macro use of water or macro water from micro water, or you can look at it as basin level water and on-farm water. And so, that's, the question is, what role does micro irrigation technology have in the macro basin is really what your question is. And honestly, it has a part, but a relatively little part. Right, what we do is we work with growers to execute what they want to do, what they need to accomplish. They're regulated. They have, through the state, they have water rights issues that they're dealing with, and we have to react to all of that. So, now that said, it's not like we don't care. I mean, like I said, I live up the road. I care. I live here, and so this is so we do care and we pay attention to it. But we're working with the individual producers to execute what they need to do, and they are the ones that are combining kind of that macro water need and the micro water need.
Thank you. So sticking again with the technology theme, this question's for Ben. You guys at the Wet Center deal with a lot of startup companies producing lots of different technologies. So from your perspective, what role do the startups play to ensure equitable access to new technologies across farming communities?
Well, I think first and foremost, the responsibility falls on the startups to make sure that their technologies are easy to understand and use and implement. It seems that a lot of times you have innovators coming in with great ideas, great concepts, but whether it be from a pricing standpoint or a usability standpoint, whether it be too technical in nature, it can be difficult for a small farmer with a relatively small team to actually implement this technology and find value in it. So sometimes the ROI isn't necessarily there. So I think it's key for the founders, first and foremost, to understand that and the challenges they face with implementing technology, especially if you don't have the team members and expertise to do so. Secondly, just one of the challenges on top of that, I'll speak more to the challenges first, but one of the other challenges is for startups, typically backed by venture capital funding, they're looking for growers that have the ability to scale the solution. So you start with the pilot and then hopefully it scales from there. The small farmers are not necessarily, they don't pan out as well economically for the amount of work it takes to acquire that customer. So it becomes difficult in those early stages to bring those new innovations forward. And a company has to be pretty developed to justify, I'd say, going after some of these small growers. So that's part of the challenges. I think one of the things that's been beneficial is when a new company is in the space and they really take interest in the community, when they show up to different commodity group events or different events throughout the valley, for example, one thing we encourage them to do, they're meeting growers of all shapes and sizes. And that helps kind of bring about more of an equitable distribution of the technology. And then in addition to that, if they're in those early stages of commercialization, I think it's important for founders to recognize that you need some champions for your system. And sometimes larger growers are looking to see what other people are doing first before they want to get involved. So changing the mentality from just kind of the numbers and cents to being a little bit more about building reputation, building credibility in the valley will go a long way for founders. So that's what we're doing to kind of help with that.
Thank you. Again, if anybody would like to ask questions, not just about what I just asked, but anything else, please go ahead.
Thank you. Another technology question. Are you seeing value in some of the advanced geophysical techniques that go deeper, looking for sweet spots for recharge, such as the DWR's flights for electromagnetic scans and more localized approaches, or is it too early to tell on that sort of stuff?
As one of the early adopters of that SkyTEM, I think we flew it in 2000. Our first flight was in 2017 time period. We came back in 2020, and then we loved it so much we bought our own unit at this point in time. So you can tell we've adopted it wholeheartedly. And what are the values that we are seeing out of that system is, we were making multi-million-dollar decisions on recharge projects based upon literally if there's a for sale sign in front of the property. We've turned that into more of a what's below us. That SkyTEM system sees down as deep as 1,500 feet. So you're going to see some pretty interesting things deep down below. The granularity of that reading is very rough. That's why we bought a TOTEM unit to really get small, discrete packages at the surface, because if you can't get it through the surface, there's no need to know what's below you. So it's that tailored look. We appreciate DWR's coarse look, so you're going to see what the state looks like, and then we can go back in and drill down into deeper detail. What you're seeing is, for us, we saw lithography that we thought the location of it was incorrect. So our Corcoran clay was further west than we had thought. So what does that do for you? That opens up a whole swath of ground now available for recharge underneath the clay that wasn't thought of before. On our western side, we had deeper, thicker aquifers than we had thought, so there's more storage there than we thought. On the east side, sadly, it was shallower than we thought, so we have more of a problem. So you change your management actions and projects in order to accommodate those changes in lithography, which we had no clue because we had just a bunch of boreholes and driller's logs, and sometimes the driller's logs weren't even legible at that point. I will say the TEM data does not, it's not the end-all be-all. What it is the very first good indication of what you got. We followed up with more borings to verify those images. So, but it's a great technology. It's, again, talking about scaling up, I mean, that was done in 2017. It took us 5 years, I think, to get DWR to understand that that's one of the most valuable tools they could deliver to the state. So these things take time, but it's interesting that the growers on the ground, like my growers, were willing to do it and be a part of that on day one. So growers are more innovative than most people give them credit for. So.
Yes, sir.
Mine is a two-part question. The first one deals with, we've had basically a triple La Nina, and it looks like this next year we're going to be going into an El Nino potentially. So identifying, obviously we had torrential rainfall and lots of snowpack this year, and what the potential is for a back-to-back torrential rainfall. That's the first one. Second one is, we talk about with all this potential rain and what's coming in and snowpack, but also everyone says, well, the drought's over, but everyone always forgets, and you kind of answered my question in part with regards to the aquifer and potential areas of collapsing of the aquifer and the potential lack of storage that would result as thereof. So those are the two questions there.
Okay, so with regard to the first question, what's the probability of back-to-back torrential years? Like the year that we've had, I don't have a great answer for that, unfortunately. I think the only thing we can say for sure in California is that one year is never quite like the next. And the further you go out on the forecast, the less certain they become. So that's really hard to say. But on average, I think we tend to see years like this maybe once every 5 to 10 years. So the dry years in between, they're probably going to be more common and more likely. Hard to say that with a lot of certainty. And then the next question was regard to, well, is the drought over, but what about kind of our reduced capacity for storing a drought reserve due to the subsidence in the valley? I think that's a really good point and important to keep in mind. With regard to our surface storage, I mean, compared to where we were last year, we're in fantastic shape. The snowpack's unlike what we've ever seen, so that's a really good place to be in. But the drought's not over if you get your water from Trinity Dam. It's not over if you get your water from the Colorado River, and it's definitely not over if you get your water from the ground. So I think that's important to keep in mind going forward. And these conversations about recharge and what do we need to do to scale this up are really important to be having now, but also in advance of another year like this.
I think I definitely personally learned, I was on, in conferences, panels, a lot of discussion in November of 2022, going into December, La Nina, 50% greater chance of dry all the way through February. Man, did we get, I'm not a forecaster, so I didn't get that part wrong. But I advocate that we are always preparing for acting as if it's drought. If it turns wet, we're ready, that prepares you for the drought. So all the actions we've been taking in our irrigation district for our growers is to prepare for drought. That allocation cutback and tracking system, basically you all have, bank accounts at home. You put money in savings, rainy day funds. We're doing the same exact concept underground. And instead of building up the groundwater levels and just hammering it hard on the drought years, we're going to have to meter it out. And our growers understand that metering that out means cutting back. And if you're going to have to cut back, the technology that these gentlemen provide helps us irrigate a lot more efficiently during that drought period. So there's technology to do it. And even technology in the tracking, the SkyTem, our online dashboard systems that we're doing, we're using evapotranspiration. So now our farmers are literally farming from a cell phone to get the basics done. And I think that's an interesting dynamic in the world of one that most people believe that's not common, but it is very common today.
Yeah, and since it's opening day of baseball, I'd like to use a baseball analogy. And right, if anybody who knows baseball knows hitters are always going into a slump or coming out of a slump, right? And I feel like that's the way we are in California now. We're either going into a drought or coming out of a drought, but it's just the way it is today.
So I'd like to change gears a little bit and talk about education. We're here at Fresno State, one of the best, if not the best, ag college in the country. And I also work at the, yes, please do applaud that. I also work at the Center for Irrigation Technology, and part of our mission is to educate growers about new technology. So my question to you, Claude, is how does the industry train growers to operate their systems in the most efficient method possible?
Well, well, it starts with where you just said, right, at the educational institutions. And you know, California has some of the best in the country, if not the world, for irrigation education. California is, depending on how you look at it, is either the #1 or #2 irrigated state in the country. Nebraska has more acres, California applies more water, and we get more value out of that water. And it starts with the educational institutions, because they're the ones that are training the young people and doing the research. So the UC system does a tremendous amount of research, and then you have, and you know, my apologies to the Fresno State here. I'm going to mention additional educational institutions, but Fresno State, Cal Poly, and then you know some of the junior colleges too. So College of Sequoias has a great program, as well as some of the other junior colleges as well. It's always going to start there, because that's where all of the rest of us get a lot of our curriculum to educate growers, right? And so it starts there, and it also goes to county extension. So there, you know, that's an important part of it as well. The specific to the industry, you know, we have, I think, 10 agronomists around the country, and their sole purpose is to work with growers to diagnose problems and implement solutions that they need to be more efficient on farm. And that, by the way, it extends not just to the water. You know, the irrigation system, particularly a drip irrigation system, is a method to apply other, you know, fertilizers and other compounds to a farm. So, you know, that's at least 50% of the benefit of a drip irrigation system. So, so we'll work with growers to help them get the most out of that system as well. But you know, 80% of our calls are diagnosing problems because something isn't working the way they expect it to.
So troubleshooting, in other words, would be an educational opportunity. So Richard, you've been doing a webinar that provides a lot of educational content. What sorts of topics do you see your audience is hungry for in terms of education?
Yeah, it's interesting, right? Because we look at who comes and why and which webinars get better attendance, and a lot of time it's the practical. They want to learn something practical that they can use to apply to their what they're growing or what they're doing on a day-to-day basis. And it also suggests to me a little bit that you know, I'm all for college education. I've got an advanced degree in it, agriculture. So yes, I support that, but I think it's the steps beyond that are important too, this lifelong learning. So I think people are looking for places to be lifelong learners. And I think that, you know, COVID, this is why we started our irrigation training series, was the, started us to start thinking out of the box of how other ways can we educate other than straight one-on-one in the field with growers. So that was a little bit of it as well. And then lastly, one thing we started to do as well was our water management services or water management consulting services for growers. And part of this was the concept of you can learn so much by reading or listening, but actually doing or working side by side with somebody who acts as a coach that can coach you and help you interpret the technology. Right, one of the growers who was up here before, he said it so well, no day is the same, right? There's a lot of variables, there's a lot of science to it and a lot of variables, and having someone there to kind of help you through that learning curve at the beginning really has helped a lot of growers. And our hope is that they take the consulting services for a year or two and then are able to completely work on their own, and we've seen that.
Thank you. So pause for a moment. Are there any questions from the audience?
We have some online audience questions that I'll read out here really quick. One of them is, what is the best known way to recharge the aquifers, given that there is clay under the valley? So maybe in some places or other places there aren't. What is the best way to recharge them?
Yeah, so we have that condition in our irrigation district. We have the Corcoran clay and a bunch of other clay lenses that are, patchy on the above the Corcoran clay and below the Corcoran clay. However, if you look at our upstream system that is east of the Corcoran clay, it's mainly sandy alluvial deposits that came down from the Quia River system. So you target your recharge in areas east of or out of the clay, but I'll tell you right now, given the conditions of water supply and managing the extremes, you recharge above, below, around, everything. So it's just having that, you're gonna put we put all our high performing basins on the east side, and we use all of our other basins, as secondary, tertiary recharge. So there's ways around it. We are investigating, and I know Westlands has done some great work on injection wells. We're looking at a system that is not injection, but vado zone injection, which is basically shallow. It's basically a vertical septic tank that goes very shallow. You can get around clay layers, and you have enough filtration packed between the bottom of your percolating unit to the top of the groundwater system to guarantee that there's no contaminants. But yeah, first step one is know where those clays are at.
And I see one more question in the audience there.
Yes, I wanted to ask, I guess, a technological question. In regards to freshwater, being, I guess, less accessible or decreasing the amount of freshwater that we have, what technological advances are you guys coming up with in order to better use, like saline waters? I understand that, excuse me, using the use of saline waters can damage pumps or disrupt pipes. So I'm curious as to what things you guys are doing in order to, I guess, mitigate or work around that.
Claude?
Yeah, sure. So I think everybody in the industry has been, working on this. It's kind of an evolution over many years, right? In, decades. And right now, I think what we're seeing is an adoption of technology, of control and monitoring technology that has, California's been a little bit behind, and the U.S. has been a little bit behind other markets. But, a drip irrigation system can be super efficient, but if you run it twice as long as it's supposed to, you're only at 50% efficiency, right? So, the automation is probably the biggest thing that the industry can do to help improve, to manage the water application. And then everything else from there is probably fine tuning. There are a number of different technologies that different companies are working on that kind of break large zones into smaller management units so that you can address smaller problems. So if you need a little bit more water, you need a little bit less in a very specific area. There are different ways to approach that. And so trying to break it down into more micro zones is probably another step that comes to mind.
Yeah, and I just wanted to add to that too, some of the things that we're doing in addition or along with that include things like satellite imaging, giving growers an opportunity to look at their fields first thing in the morning, see if they've got any hot spots or see where the trouble issues might be, soil moisture monitoring so they can water appropriately and actually watch the water percolate through the fields. And then finally, we use a lot of ET data as well, and we're even using future ET, looking 7 days forward now to say, gee, should I be watering today if I'm going to have rain that's going to be make an impact in 1 day, 2 day. So this is taking into consideration with our irrigation schedules as well.
So also to Ben, the salinity question brings up some of the water treatment options. And I've seen at the Wet Center, you've dealt with quite a few startup companies that deal with water treatment. Do you comment on that?
Yeah, so one of the things that's nice about the Water Energy specifically Technology Center is we're focusing on addressing some of the energy challenges with treating water or recycling or reusing, whatever it might be. And that seems to be a big factor in the cost of making that viable, especially on a micro scale. So I still think that we are a ways off from having that be viable at the moment. I mean, not too far out, but there's progress being made, and eventually when that is resolved on the energy side, I think we could see more projects on the desal side specifically come more into play throughout the valley.
Okay, thank you. So Secretary Ross mentioned in part of the governor's plan that water reuse is a large factor in their plan moving forward, and that's going to change the demand structure. So my question for Caitlin is to tell us a little bit more about the demand side of the equation. I know the PPIC studies quite a bit of that in a very broad sense.
Mm-hmm. Yes, of course. So we've been talking a lot about recharge, and that makes sense given the sort of situation that we're in and the rain that we've been getting the last couple of months. But I think it's also important to recognize the demand side of the equation, and there's no free lunch as when it comes to that demand side of the equation. So from the research we've been doing, the modeling we've been doing over the past couple of years, we've concluded that we may do a really good job of finding new sources of supply for the valley of water supply. We may also do a good job of implementing some flexible rules for moving water around and being able to trade and account for that. Even if we do all of that, on a very conservative estimate, we're likely to see something like 500,000 acres of irrigated land come out of production. And that needs to happen that's the demand side of the equation that's going to need to happen to have sigma balance out, right? So that's best case scenario. Worst case scenario, it could be all the way up to nearly 1 million acres. So that's a significant chunk of our ag land. It's a significant chunk of our ag revenues as well. But on the other side of the coin, not to be all doom and gloom, we've also found that there are a number of approaches that can be taken to really reduce those costs of the transition. One of them is water trading. Another is finding new sources of supply. And there's also a lot that can be done, as we heard in the previous panel, to kind of optimally figure out a way to use those transitioning lands to bring about multiple benefits, whether they be to mitigate air quality concerns, improve habitat, create areas that are kind of more flexible, that can be used for recharge when they need to be, that can produce crops that are more suited for water-limited style production systems and that type of thing. So there are lots of opportunities as well to repurpose that land and soften the blow a little bit of the demand management side of things.
Thank you.
Charles, I'd like to add to that just a second.
Go ahead.
So we've had, Secretary Ross mentioned the dairy effluent project that we've been working on for a number of years, and there are 3 pilots that we worked on starting about 8 years ago. I think there are now 27 that are being installed in up and down the state of California. And prior to that system being developed, or that solution being developed, growers would flood their fields with dairy lagoon effluent, and the water piece of that was one part of it, but of course then you also have the nutrient loading part of that as well. And so in all of the systems that we've put in so far, they've instead of having nitrates leach down into the groundwater, say in the first third of the field, we're able to put that through the drip irrigation system, and growers have eliminated the use of artificial nitrogen. So there's a cost savings, there's also a groundwater quality benefit, and then there's also not necessarily measurable, but a greenhouse gas emission benefit as well, because we're not applying artificial N for nitrous oxide emissions. So anyway, that is kind of a beneficial use of maybe not residential or urban wastewater, but just kind of agricultural wastewater, and we're expanding that now into swine operations. We don't have too much of that here in California, but doing that in other states, and then also processed water as well. So for food processing plants.
Thank you. I want to add one thing too. Just really quickly, because you were talking demand management, there's options, but I think one of the conversations that's not happening out in the real world, I encourage all of you to have it. I just had it yesterday with a reporter, is Sigma never really had an economic analysis. Everything we do has an economic analysis except Sigma. So if you look at this regulations, and my understanding is that there was thoughts of doing it, but they just couldn't get it in at the last minute. But had we done an economic analysis on the impacts of Sigma, the fear was that legislature might not have done it, because yesterday the conversation I had with a reporter was, well, ag is only, a small fraction of the state's GDP. And I said, that's fine if you look at the state level, but in my community of Hanford where I live, ag is like 85% of my community. So it's relative, it's very important to us. The previous panel hit it home. I mean, the things we grow in our area are not the things that, they're the quality products that we all enjoy. Interestingly enough, my board vice president grows corn nuts. I have to have a conversation with everybody to explain that the corn nut is a real thing, right? And there's just a handful of growers in the state of California that grow corn nuts. Luckily, I've got one. So I've got an endless supply of corn nuts to break my teeth on. So, but that conversation I encourage you to have with people, look at it. If we're gonna do demand management, which is really what's coming up to play right now, I have to admit our groundwater allocation cap and program is all about demand management. You're gonna have to cut back your ag production. In our industry, in our area, that's milk. Go out in the real world and look how much of your products that you eat have a milk product in it. And we saw during COVID what it's like to go to the grocery store and not find yogurt on your. My wife flipped out. She couldn't get the yogurt. Well, I know that's a supply chain issue, but we are soon to see that might be not a supply in that the product won't be hitting the market. In Tulare, we have some of the largest producers and processors, and they, Sigma's coming, they see it. We already lost one plant. The idea was, oh, we're not, we're just moving because of economies of scales. We know what's happening, right? But if California scares away agriculture, it's gonna be left to other states to pick up that slack, and you just don't have the soils, the temperature, or the water in the other states. So we will go abroad to get our fresh fruits.
Thank you. So economics is obviously really important, and technology costs money. So a question for you, Richard, is the cost of new irrigation technology going up or down?
Yeah, I think as I think about this, I think maybe over the last 3 or 4 years, I found it to be very steady. When you think about irrigated acres in the United States as a whole, we're looking at about 19%. And of that 19%, less than 5% are using any type of technology. We think that as the technology is adopted more, pricing is going to come down. But again, if we think of drip tape as technology, it's not very expensive to start with. But then if you get into things like soil moisture sensing or satellite imaging, for really $3 or $4 an acre, this is what a lot of the advanced technology will cost you. It's really, I think, very affordable at this point, and potentially coming down as the economies of scale kick in when more producers use it.
So the economics of technology is really important for startup companies because it limits their market size. What are the obstacles that you're seeing that startup companies are dealing with relating to the economics of water and agriculture?
Well, again, kind of going down to some of the technologies that were mentioned there is these are companies that have been more established. They've figured out some of those early level challenges to where they can bring these solutions to market, and it can be affordable. A few dollars an acre is not something that will necessarily need to be highly looked over before a decision can be made. So with new technologies going forward, you can't do that until you achieve a certain level of scale or development or back-end development. And that upfront cost tends to be so expensive, and expectations for investors are so high as a result that a lot of times startups have to justify a very high price of their services and their technology in order to basically prove to their boards that there is significant market demand for what they have. If they reach a certain point of scale, they're able to reduce their price and become more competitive and focus more on market share compared to just unit economics. But that early stage I guess crossing the chasm kind of type area for these startups becomes very difficult because a lot of growers, especially in the mainstream, are just not willing to pay money for technology that is very expensive, very new, and on top of that, in cases, they have to learn how to actually use what they're getting. So that's a challenge.
I think the other challenge there too, Charles, is that when growers are very good business people, and I respect the heck out of them for that. When water is $22 an acre foot, it doesn't make sense necessarily to pay for technology. But then when it moves to $2,200 an acre foot, all of a sudden there might be the demand, but that gap in pricing really takes them out of the game. I'm in the game at $22 an acre foot. When you put the price up so high that I can't be in business, then I'm not looking at technology either.
Yeah.
Thank you. So, Caitlin, same question to you. Where do you see the economics going in relation to the Central Valley?
Well, I think that depends to a large degree on the approaches we decide to take now, both in terms of the innovations we can apply and also the way we manage policies for land and water. So, as I mentioned before, if we add some flexibility, for example, in how we can trade water, and we have good accounting systems for how to do that, in the ways that people like Aaron are starting to do, that can actually mitigate a lot of the costs of transitioning to our new water reality and transitioning to sustainable groundwater, as can finding new sources of supply. And then we're talking about technology and ways to increase productivity. If you add in that flexibility to move water around, if you add some new supplies, and then you also add even half the amount of gains in agricultural productivity that we've seen over the last 40 years or so, we can even start to see not losses to the regional economy, but actually some small gains to the regional economy. And that's with a significantly smaller agricultural footprint, and that's with 1.5 million acre feet less water per year for agriculture. So that's actually kind of a positive outlook in a manner of speaking. So for the valley, for agriculture going forward, I'm sort of seeing something definitely very different. And our growers, as we've been talking about, have a history of being good innovators and making big changes and that type of thing. So we're going to see different agriculture, probably a smaller footprint of agriculture. But I'm fairly optimistic that the regional economy and ag being a big part of that can still continue to thrive.
So I've just got the 5-minute warning that, oh, a question, I'm sorry.
I know, yeah, it's on. I guess this might be a question for Aaron. If we're looking to increase supply, and I'll focus on Tulare because you obviously have groundwater overdraft, you've got issues with stormwater right now, and you have many disadvantaged communities. Like where in the short term might we prioritize, can we do more recharge in those areas near the DACs, the disadvantaged communities, and maybe improve their situation there? Are there, in the short term, like on the irrigation district level, actions that we can take to capture more stormwater? Obviously, we need a lot of statewide infrastructure to do that. Municipal wastewater, from the cities that are close to you, is that realistic to then take that, say for agriculture, maybe the municipal wastewater can be used either in ag or somehow incorporated into the supply side. How do you see some of those options maybe being useful in your district?
I'll start with the disadvantaged community one because that's an important role that our irrigation district is actually playing in our sub-basin. And what our board of directors has said is the communities that are within our boundaries are our landowners. Regardless of whether you farm or not, you're still part of our community. So we've identified the communities that have the issues, and we're beginning to work with them. So I'm happy to report that we just awarded a contract for the construction of a recharge basin upstream of the community of Okieville. And we have a basin nearby them, and that basin anecdotally has provided benefits to that community, we believe. On the upstream side, they have a lot of water quality and quantity impacts. So the idea is put a recharge basin nearby them. We'll have monitoring stations between the basin and the community on the downstream side, and we'll monitor whether or not there are water quality impacts headed their way. If there are, we'll set up mitigation strategies. One of them is we might have to outfit the community with RO systems as a temporary measure until we can get enough water supply backed in underneath the community, because generally speaking, the Sierra snowmelt it's the cleanest water you can get. So our area has accepted or acknowledged that sometimes it's going to have to get worse before it can get better. And we need to look at that, address it, and be ahead of it. For our disadvantaged communities, we're moving to that operation, or we're going to consolidations. We attach them to a larger city like City of Tulare. On the wastewater side, we are partnered with the two cities as our GSA partners. So that was an outcome of water arrangements and agreements with them. So we take all the tertiary treated water from the City of Visalia. The City of Visalia borne the cost of going to tertiary treatment, covered all the costs to get the water supply to our boundary, and at this point, that's an 11,000 acre foot per year new supply to our growers. I'll tell you right now, we have a grower that just sold a block of pistachios in our district, and I think the sales price was somewhere in the $56,000 to $57,000 per acre, unheard of. And so everybody was asking, well, how did that happen? I said, because it's the unicorn of all properties in the state of California. It has 3 water supplies. It has groundwater, TID water, and tertiary treated water. So it really was a unicorn, and now everybody's poaching out those properties right now that get that tertiary treated water. Our growers also take secondary treated water from the City of Tulare's wastewater treatment plant. That cannot be used on edible crops, but it can be used on forage crops. So if you look around the City of Tulare's wastewater treatment plant, a lot of cotton, corn, cotton, corn, and silage, milo, maize, that sort of thing. So every molecule within the Mid-Cahuilla GSA is being repurposed and used and recharged at one point or another. Stormwater, the irrigation district takes almost all the stormwater from the City of Tulare and the City of Visalia. In a period like this, it's very hard to discriminate between flood flows and storm flows. They're all one mess coming our way. So, however, during a normal year, we will take those storm flows, shepherd them through the city and into our recharge basins throughout the district.
So I just got the 2-minute warning. So I want to take a moment to see if there are any other quick questions from the audience. And I see one. Yes, ma'am.
And could you repeat the question, please?
Sure. So you're asking what's going on with the Delta Tunnel project and the discussion relating to that. So anybody at the panel would like to take a stab at that one?
Everybody's looking at me. I'm not authorized to speak about the Delta Tunnel project. No. I don't have a great answer for that.
I would say the only thing I could add is when you look at the larger projects, I know there was discussions of Temperance Flat in the previous section. There's Sites Reservoir, the tunnel projects. These are long legacy projects. They've been on the books. We have a problem today. And I just wish previous administrations had the foresight to do these things, but I just don't think we have enough ability to move those large projects forward fast enough to be utilized under this new Sigma world we live. Everything we do in the water world, it's Aaron Fukuda Sigma. All of our world is targeted at 2040. That's our goal. And the tunnels, I don't think, come into play until much later. I was the executive director at the Temperance Flat Reservoir Authority. We were going to have to build that project with a $171 million initial investment. I hate to say this because if there was any, but that was going to be AG's high-speed rail. They were going to put us under the gun and underwater to pay for that project, and we would have been focused on that $3.8 billion project, and it would have been done in 2035 if we're lucky. very lucky. So Sigma, we had to come into compliance by 2040. So you look at these larger scale projects, they have to be done by the state or the federal government, while us locals are working on the innovation, the conservation, the technology, the allocation programs, because that's going to be what counts between now and 2040.
Thank you, Aaron. So, and thank you all very much for listening. I appreciate your attention, and also thanks to all the panel members. I appreciate your time and your knowledge and inspiration. Thank you very much.
And we are going to take a 10-minute coffee break. Please stretch your legs. We've got two fantastic panels coming up. One on the business of agriculture and on the smart farms. So please stretch your legs and come back in about 10 minutes. We'll get started again. Thank you. Also, please do check out the student posters on the wall here on the right. Some fascinating work being displayed. According to the International Energy Agency, bioenergy provides around 10% of the world's total primary energy supply. In 2018 alone, 154 billion liters of biofuel were produced worldwide. Additionally, production of biofuels is expected to increase 25% by 2024 as it becomes more competitive in energy markets in Brazil, the US, and China. But what is bioenergy? How helpful can it be in the global effort to decarbonize? And how much will it cost to scale up production to help accelerate the transition away from fossil fuels? We spoke with Jerry Tuskin, CEO for the Center for Bioenergy Innovation, and Matt Langholtz, natural resource economist from the Bioenergy Group at Oak Ridge National Laboratory. So, what is a biofuel and where does it come from?
A biofuel is a liquid fuel derived from biomass. And biomass is just dried plant matter. So imagine taking wood chips or chopped up grass and converting it using bacteria into a liquid transportation fuel. And that becomes a biofuel. By using biofuels, we can displace that petroleum and reduce the amount of carbon dioxide emissions in the transportation sector here in the U.S. So it's a means of reducing the amount of carbon through capture of growing biomass, poplar or switchgrass, or other forms of plant biomass, harvesting the above ground portion and converting that into fuel, and leaving the perennial root systems intact in the soil so that that carbon remains fixed in the soil.
This is the difference between CO2 emitted from fossil fuels and CO2 emitted from bioenergy. When burning fossil fuels, carbon is released into the atmosphere after being locked underground for millions of years, thus increasing the total amount of carbon in the biosphere and atmosphere. Biofuels, on the other hand, are part of a closed-loop system in the carbon cycle and are thus considered to be net neutral in terms of carbon dioxide emissions. Carbon is captured by bioenergy feedstocks, which are turned into fuels, combusted, and the cycle repeats. And if you add carbon capture and storage technology, which captures the carbon at the point of combustion and then stores it underground, biofuels become net negative. Before diving into what we know about feedstocks and their economic availability, let's break down one of the processes used to create biofuels. Here in this diagram, we see that from non-edible plants, there are three components that make up this type of lignocellulosic plant matter: cellulose, hemicellulose, and lignin. These structures are what make a plant strong and durable. Once plant matter is grown and collected, it's taken to a conversion facility, where bioreactors containing bacteria begin to break it down. Plants typically have varying degrees of recalcitrance, meaning how resistant they are to being metabolized by bacteria in the reactor. However, the bacteria used in these bioreactors have been specifically engineered in labs to recognize the polymers that make up plant cell walls, and to be able to deconstruct them accordingly. Plant feedstocks such as switchgrass and poplar have also been engineered to have polymers that best suit the digestive microbes. Once in the bioreactor, the bacteria first strips away the lignin, followed by the hemicellulose, until you get to the core of the cell wall, where the cellulose can then be broken down into sugars like glucose. The glucose is then fermented to produce ethanol vapors. These vapors are then passed through a catalyst that converts the ethanol into a hydrocarbon. This hybrid hydrocarbon has properties similar to diesel fuel, making it suitable to replace petroleum-based fuel. This process is well established and is how we get to commercially available ethanol used in vehicles today.
Biodiesel has made significant gains in recent years. Brazil powers a lot of their transportation with ethanol from sugarcane. Germany and other countries power a lot of their vehicle fleet with biodiesel. So biofuels are here. In terms of what we're talking about in this conversation, a main constraint is it's hard to compete with $2 or $3 gasoline at the pump. Cellulosic ethanol is modeled to be, it's probably looking at about $4 per gallon of gasoline equivalent.
So when domestic supply of gasoline increases due to new technology like fracking, biofuels can be priced out. But with the advancement of feedstock production and technologies, biofuels have the potential to become much more competitive. Let's take a look at some of these feedstocks, their availability, and the cost of production. Feedstocks for biofuels are categorized into 4 generations. In this graphic, we see first-generation biofuels, which include bioethanol and biodiesel. These are produced from plants that are mostly edible, such as sugarcane and corn. Then we have second-generation biofuels, also known as advanced biofuels, which are manufactured from various types of non-edible biomass, such as lignocellulosic plants and waste. Among third-generation biofuels, aquatic biomasses, such as seaweed, kelp, and algae, are used as renewable sources. And lastly, we have fourth-generation biofuels, which are made synthetically from cyanobacteria and algae. When looking at forests and their feedstock potential, it's important to take into account the fact that currently half of U.S. forest land is considered timberland, meaning it's ideal for forest products like pulp, paper, and lumber. Therefore, the competition is high for sustainable forest land.
After we exclude protected forests or sensitive forests and inaccessible forests, we find that at $60 a ton roadside, there's about 100 million tons per year of wood that could be derived from forest thinnings and logging residues. So those are forest thinnings, trees that are less than 5 or 6 inches diameter, and logging residues, tops and limbs that are left in the forest after trees are cut down. By the way, that's less than 1% of the 15 to 20 billion tons of wood that's standing on timberland. So it's a tiny fraction of the total. It's a significant potential cumulatively.
So where we lack in acquiring sustainable forest land dedicated to producing biofuels, we can turn to forest byproducts from other forestry operations. Economically, that's about 100 million tons of feedstock that could be added into our current bioenergy supply. But what about waste as fuel? What is considered good waste for biofuel production?
There's urban wood waste. So that's like power line trimmings and storm debris from urban areas. Municipal solid waste, which is basically your garbage. There's secondary wastes, which is mill processing residues, scraps from any kind of agricultural process, manures from confined animal feeding operations, industrial fat byproducts or grease byproducts or restaurant grease traps and things like this. A lot of it already used on the fats, oils, and greases already goes a lot to biodiesel production. So the market works already where it can. In our billion ton report, we had about 100 million tons of forest land resources. That's at $60 a ton roadside. On the wastes, if we also could afford about $60 a ton, we'd get another 100 million tons from this big mix of waste resources.
And that's not all. Agricultural residues like corn stover, wheat straw, and other byproducts left on the field can be used to supply another 100 million tons of biofuels. From these 3 feedstocks alone, we see there's enormous amounts of material that are just sitting there waiting to be used. What's currently lacking in making this a reality is the support of public policy, an adequate price on carbon, and sufficient investment from public and private sectors. If these hurdles can be overcome, biofuels have a strong potential to displace global dependence on fossil fuels. And this doesn't take into account the potential of algae feedstock. One of the most important things to note about algae is that it requires no agricultural land. So there's no conflict between food and fuel. However, it does require new infrastructure to be built, which can be expensive. In regards to CO2 sequestration, algae is a powerful tool that can be used near CO2-emitting facilities such as coal, natural gas, and electricity generation plants in order to offset emissions. According to the Department of Energy's Bioenergy Research Center's 2020 update, advancements in each phase of biofuel production line will help to spur future growth in the bioenergy sector and lower overall costs. From improving methods to sustainably sourcing biomass feedstock to genetically engineering plants and bacteria to improve deconstruction of plant matter to the final conversion of biofuels, biofuels stand a chance to eliminate global dependence on petroleum. For a deeper dive into this topic, check out our full-length podcast with Jerry Tuskin and Matt Langholtz, where we went into detail about biofuel technology and its role in decarbonizing the economy. Or check out our newsletter. For more video and podcast episodes, to sign up for our new releases and more, visit climatenow.com. I think we are. Emma, are we good to go? All right. We're going to get started, folks. If you could come in, take a seat. We'll get started with the next panel. And to introduce the panel, I'm going to welcome to the stage President Lynette Zelezny of CSUB. And I'll turn the microphone over to you.
Thank you very much. We'll have our panel, please. Yeah. Well, good afternoon. It is a true pleasure to be back at Fresno State today. I'm Lynette Zelezny, the president of Cal State Bakersfield, and we're very happy to be here with a panel from Cal State Bakersfield for this critical discussion of the future of agriculture. I want to thank the Maddy Institute, the Livermore Lab Foundation, Climate Now, and my sister institutions of higher education in the Great Valley for working with Cal State Bakersfield to coordinate this summit. When visitors to our region travel up and down Highway 99, the main street of our beloved valley, they look and see row after row of almonds, grapes, citrus, cotton, I saw Mr. Smitkamp here, peaches, pistachios, and so much more. But what they're really seeing in the heartland of California is the life and the history of a region planted here in the fertile soil. Our people have come to the Central Valley from everywhere in the world to grow food. And in doing so, they have grown entire cities, industries, and economies based on the agricultural heritage that fills us with such pride. Kern, Fresno, Tulare are the top 3 crop-producing counties in the nation. In 2021, each of these powerhouse counties reported over $8 billion in crop production, a stunning testament to the effort of our farm workers and the ingenuity of our growers. But with opportunities come challenges, especially around the economies of scale for agriculture. And that is the topic of our next panel, composed of my brilliant colleagues from Cal State Bakersfield. And now it's my honor to introduce the moderator who will lead the discussion, Dr. Aaron Hegde. Dr. Hegde is a friend and a colleague, the professor and chair of the Department of Economics at Cal State Bakersfield. The department oversees programs in agricultural business, economics, and environmental resource management. Dr. Hegde also oversees the endowed Grimm Family Ag Business Center at Cal State Bakersfield. Dr. Hegde's research focuses on agriculture and trade, a vital area of interest to the growers in Kern County especially, and we're eager to explore new markets for those crops. So please join me in welcoming Dr. Hegde and our panel from Cal State Bakersfield.
Thank you, President Zelezny, for that wonderful introduction and for being here. And thank you all for being here, and thank you to the organizers for putting this panel together, and especially to Emma. I saw her there. Thank you for coordinating with us, and oh, there you are, working with us, and so really appreciate the hospitality and things, and very glad to be here at Fresno State. Before I have the panel introduce themselves, I wanted to say one thing. When we were talking about education in the previous panel, you may not all know, but we have a thriving ag business program 100 miles south on 99. We're small, but we're mighty, so that's another option in creating agriculture leaders. So I'll go down the panel here, and I'll have my colleagues introduce themselves. I'll start with, to my left, Mr. Cayetano Urias.
Hi, my name is Cayetano Urias. I'm the co-director of the Grimm Family Center at CSUB. I'm also the director of food safety and quality for Ag Reserves. I've been in the food industry for about now 17 years. So, you know, I've had permanent crops, I've had row crops, and manufacturing under my belt. So I'll pass it on.
Hello, my name is Juliana Laxina. I am the controller with crop management. Crop management is located in Delano, and we manage our own farms as well as other family farms throughout the Central Valley. So I'll pass it on to John.
Thank you. Yes, hello. My name's John Deal. I am an economist, and I am the director of the Ag Business Program at CSUB.
Good afternoon. My name is A. Padilla. I am a faculty at Cal State Bakersfield, but I'm also a 23-year veteran. I always tell people I feel like I've worked in the nut business 1 year, 23 times. It's been like Groundhog Day, you know. Teach agribusiness management, agribusiness finance, and analytics. I also teach analytics at Loyola Marymount University, as well as having my own consulting firm in agribusiness consulting and owning 2 companies in nut processing and nut exporting.
Thank you. So I'll start with John first. And this question I'll ask everybody on the panel. And after a few minutes, then we'll open it up to any questions from the audience. So John, would you mind sharing with us what you think the future of agriculture in California is, especially as it relates to climate change and things?
It's very bright, by the way. No, as a lot of the other panelists have said, or alluded to, there's a really complex interactions between climate change and agriculture, and specifically for us, the economic outcomes of agriculture. There's some costs that are going to be imposed on agriculture, particularly related to water, but there's some opportunities that are going to be available. Some crops that could be grown in some areas now may not be able to be grown in those areas, but then other areas they'll be able to be grown. So I think it's kind of a bunch of interrelated issues. One, the impact of climate change on things like temperature variability, water access. It hasn't been mentioned too much today, but pest infestation, and the projections of how significant those changes are going to be. And then the impact on crop yields and the choices that farmers face and what they can plant. And a lot of that has to do with things that are also uncertain, like technology changes, policy responses, and then finally, the crop yields and the changes in crop mix are going to have an effect on the outcomes. So prices, for example, profits. A lot of our crops are exported. So that's going to have an impact on the export market. I think the one thing from what I believe about from reading the literature and talking to people in the industry, that the impacts are going to be crop specific and they're going to be location specific. A couple of people mentioned that today, that it's not going to be all bad news, it's not going to be all good news. It really depends on where your specific location is and what type of crops that you're growing.
Okay, thanks, John. Juliana, did you want to share your thoughts on that?
Sure, I agree with John. I feel like the future does look bright in ag, and it's going to vary, again, with each commodity. As it relates to citrus, we are focused in working towards staying innovative, working with the technologies that's out there to learn what the tree really needs. Of course, water is going to affect it. But the great thing about citrus is that all it needs is great irrigation and sunlight. So as far as the citrus goes, I think there's a lot of opportunities there, and that's all I have to say.
Okay, come back. Caetano, so as you heard, he also does food safety. So in addition to your thoughts about the future of ag, what about food safety?
It's going to depend a lot on the challenges we have and where we're getting our food from. So here in the United States, we have a very rigorous food safety system. You look abroad in Europe, they have a similar system. Down in Chile, they have a very similar system. But where it starts getting much more difficult is now that people want things fresh and want it, from farm to fork, people tend to forget that there is times that you have to thermal process some of the food. People are selling raw milk, and it's not necessarily, our bodies are not used to that anymore. I mean, maybe 60, 80 years ago we were, but not now. Our biology has changed a little bit. So some of the risks I see coming is there's going to be a lot more regulatory risks from the government being imposed, unfortunately. Some good, some bad. The other thing I see coming is the expectations from the consumer is going to change that dramatically. And what I mean by that is the large retailers, the Costco's, the Walmarts, the Aldi's, are going to start expecting certain certifications, certain processes to ensure that they are not part of a recall, because that's the word you don't ever want to be part of or associated with, and it's very costly. With that being said, I think agricultural is not going to go away. If anything, COVID has shown that agriculture is here to stay, and we're working very diligently as an industry to ensure everybody was getting fed. But there is going to be some challenges, especially if we start trying to keep things here in the U.S. and trying to feed, from a food security standpoint. There will be some challenges. More to say, but I'll pass it on.
Okay, Abe, would you say a few words about the tree nut industry?
Yeah, I think that there's a couple of components to think about. Number one, let's look at the relationship of the crops that are grown in California. One of the panelists previously had talked about California growing specialty crops. That makes it sound like it's a very niche product, but here's a few statistics that nobody thinks about. California grows 80% of the world's almonds. Other countries that grow almonds are going to be such as Australia and Spain. Australia is projected to have a 30% reduction in supply this upcoming year. Spain is expecting, due to their drought situation, similar down crop. If we look at pistachios, California grows approximately half of the world's pistachios. So if you look at the value of California nuts, in particular almonds and pistachios, pistachios are about a 5.2 billion pound or $1 billion crop value, and almonds are about $6 billion. So combine those two together, that's a $10 billion industry just in those two commodities alone. We're not counting everything else. One other thing to understand is the relationship of the elasticity of demand for almonds. Historically speaking, elasticity for almonds is approximately 0.7. That means that for every 10% change in quantity, you end up with a 13.8% change in price. What does that mean in terms of dollars? This upcoming year, we're expected to have a down potential year in almonds. And if we do end up with a crop of about 2.2 to 2.5 billion pounds, you can easily expect to see a 20 to 40 cent increase in price. 20 to 40 cents doesn't sound like a lot of money until you play it out over 3 billion pounds. And all of a sudden, you're talking about somewhere in the realm of about $600 million to roughly up to $800 million to the economy.
Okay, thanks. So my area is agricultural trade, so I'll share a few thoughts on that. And Secretary Ross earlier this morning was talking about the importance of exports. The last year, or 2021, the value of total ag exports from California was $22 billion. And if you look at some of the major exports, they're almonds, pistachios, dairy, table grapes. And if you look at the specific industry, the almonds, 92% of what we produce in California gets exported. And then when you look at pistachios, 69% of what we produce gets exported. And when it comes to dairy, it's about a third of it. So we do rely a lot on exports. And obviously, there are many things that impact exports. There has to be a demand for our product elsewhere. And then when we talk about selling to other countries, the exchange rate matters too. So in the last few years, with the supply chain issues and with the currency being stronger, that you would think it would have an impact on the exports, but California ag exports didn't really decrease that much, right? So then what could potentially impact the exports, which are so important to the ag industry here in the state? One possibility is the European Union, with regards to climate change, is trying to pass laws and regulations which would require many operators to go organic, to reduce pesticide usage. So the U.S. Department of Agriculture did a study where they said if those standards, they call them farm-to-fork biodiversity strategies, if those were to be adopted globally, then world production of food would go down by 11%. So if you think about the impact of that, in terms of, there's a lot of developing countries, especially in Africa, that depend on imports of food, corn, wheat, rice, and such from other countries. And if that world production decreases, then the price of these commodities goes up, which means then you have food insecurity increasing worldwide as well. So the U.S. trade export, and the only sector is the ag sector where we have a trade surplus, meaning we export more to the rest of the world than we import from there. So that trade surplus would go away because the demand for our products would be less elsewhere. Plus, if we were to adopt these strategies of using less pesticide, less fertilizers, and things like that, that would have a further impact on yield. And as some of the panelists have already kind of alluded to, we may be seeing lower yield in terms of future with climate change and things like that. So that's kind of an overview of the ag industry, both domestically and in exports and stuff. So while you all think of some questions, I'll go to the panelists and ask a few other questions.
Can I add something to your statement? So one thing to keep in mind is that, as he alluded to, Dr. Hege, that the EU has been putting a lot more regulations and regulatory barriers for trade. There is talks of them actually, the EU, putting a limit on chlorine. Now, if anyone's ever used water in any way, majority of our water is treated with chlorine. So there's always going to be some minute amount in it. The amount that the EU is proposing would, I wouldn't say devastate, but it would definitely hurt the agricultural community in general if they were to put it in. So much so that the World Health Organization, I believe the U.S. went to the World Health Organization, or WTO, or I'm sorry, not WHO, WTO, to really bring this issue up, because we're not going to be the only ones in this boat. So something to keep in mind, that even though some regulatory stuff is really good for the general public, in this case it would be a trade barrier for us here in the United States, predominantly here in, if we're trading nuts, especially in pistachio, since it's a wash step that they use from float sink tanks. Just want to say that.
Thanks. Abe?
I just want to add on that, aside from the chlorine, there's other non-tariff trade barriers that have been applied internationally, and some of those are to, I don't know, if potentially develop their own internal markets. One example, going back into the European market, would be MRLs, which are basically residuals in pesticides. Another one would be post-farming and post-production pre-receiving and export markets, such as aflatoxin, where the aflatoxin restrictions, are much lower in the European Union. What that does, those same aflatoxin levels don't apply domestically, by the way. So consequently, production that it happens in Spain and Portugal are not under those same auspices, and the result of that is it puts California agriculture at a disadvantage when trying to export into the European Union. So a lot of these non-tariff trade barriers are designed to restrict imports coming from other countries and to promote, domestic production within the European Union. But the effect of this is that there's going to be some restrictive activities from the export market going from the U.S. into potentially markets like the European Union.
Julian, I'll ask you a question here. So you're talking about pest infestations and things, and I'm sure in the news more recently there's been that Florida lost a lot of orange crop because of the pest infestation, and that there's a possibility the same might happen here. Do you see those pest infestations getting worse over time? And if so, what could you talk a little bit more about what measures you think the citrus industry would partake in?
So with the wet year that we're having this year, we are seeing high moisture levels, which do affect the citrus tree. We're projecting about an extra $100 per acre foot in fungicide spray due to the increase of the disease, such as brown rot, which it's a soil-borne fungus. So we're having to be out there, be more proactive, and spray a little bit more. Now, as far as Florida, we currently do not have that pesticide here. We do have something called syphilis, ACP, but that currently is not here. It's in Ventura County. It's equal to that. But as soon as our team sees that in the fields, we're very, very proactive in spraying the fields to make sure that we attack that. So, as far as the operations go, I think if we maintain the moisture levels in the citrus and be proactive with the spray applications and things like that, we should be okay.
Okay. So if I could follow up with Caetano. So as we use more pesticides and all these other things, and you mentioned that the European Union has stricter standards than us. Can you think of ways in which we can still maintain a certain level of exports?
Yeah, so really there's certain active ingredients that and as Abe mentioned, MRLs that are not allowed in the EU. So there's, depending on your markets, if you know if this particular orange, or in her case, or this particular nut or these grapes are going to be abroad or export to a particular country, you can really let your PCAs know, hey, you can't use these active ingredients for these particular orchards. Yes, there's going to be some drift between orchards, but you have to make sure your neighbors are being, cognizant of that. The other way is to ensure that, hey, if I'm going to go to these markets, does it make sense to go organic? It's a long process, plus the yield's not going to be the same, right? So there's some pros and cons, but typically testing and staying ahead of it with your PCAs and letting them know these active ingredients aren't allowed in these markets usually will negate some of that risk. And typically each year there's an active ingredient list, and typically the PCAs and other laboratories will say, hey, don't use this, do use this if you're going to be going out to these markets.
Abe, I was going to come to you next.
A couple of things to add on there. Caetano mentioned organics. One of the things to consider, and oftentimes people really talk about organics, but they only talk about the farming component. There is the other side of it, which is the processing component. So you can be an organic farmer, but then after that, you also need to process your crop. That creates a lot of complications. So on the farming side, you're going to get a lower yield. You're restricted on what kind of applications you can put on, either for increase in yield or reduction of insect damage or other defects. On the processing end, let's give you the example of the nut industry. If you wanted to go organic, you can't apply any kind of fumigation on the product to kill insects and prevent infestation coming into your facility. So what you end up having to do is you end up having to put the product in cold storage and basically freeze the insects to death, right? So that you don't get an infestation in your facility. The effect of that is that it's going to increase your cost. So number one, you receive the lower yield. Number two, it's going to increase your cost of storage because everything has to be cold stored. And then on top of that, you need to be able to handle that inventory and get it out quickly to prevent an infestation of the product while it's in transit. So there are other considerations to look at when you're looking at organics aside from just looking at the farming end.
One quick note, CO2 would be another way to fumigate along with the freezing. So just,
correct.
Yeah.
So, John, you're talking about a change in crop that we can grow and things like that. Can you go into a little more detail about any specific industry or any specific crop that might be adversely impacted over the next 30, 40 years?
Yeah, I mean, there's obviously the water availability issue, but one of the factors that for a lot of crops, particularly the type of crops that we grow here where you have fruits and vegetables, tree nuts, is the chill hours during the winter, that they have to have a certain number of chill hours during the dormancy period. And that's one of the factors that is expected to change because of the warmer winters. And the crops that take, I think it's at least 1,000 chill hours, are likely to decrease significantly in yield, to the point in some cases they'll have very limited areas in which they can be grown. So probably some of the most susceptible to that are things like apples and cherries and pistachios, pears, that need longer chill hours during the winter and it's just not going to likely occur with the increase in temperatures. Because it's not just the overall increase in temperatures that matter. I think it's mean temperatures are expected to increase by about 2 degrees, a little over 2 degrees centigrade, or at least that's the projections over the rest of the century. But it's the timing that one of the major problems is that some of the increases in temperatures are going to be during overnight periods during the winter where they need the cold temperatures to be able to develop. So other crops are not going to be very heavily influenced. I mean, almonds doesn't seem like that's going to be a major problem for almonds. I think they only require, like 200 chill hours or something along that line. So it does raise another issue though, is one of the most resilient crops from at least my reading of the literature is melons. That melons are not very temperature sensitive and that there's very little evidence that there's going to be a lot of harm, assuming that the water availability is not severe. But the problem then comes into the demand aspects of it, that, you know, you can grow, you can switch to other crops, but if the demand for those crops are not there, you know, if the demand for melon is not nearly as high as the demand for almonds or pistachios or cherries or something else, then it's still not going to increase your revenue and profit. So.
Okay, and does anybody in the audience have any questions for the panel? Yes, sir.
So we talked about the economics of agriculture. I think the consumer has a lot of trust in the labels, like the heart healthy that we find on the almonds, organic label. But a big issue that we're seeing is food fraud, like fake spices or like maybe the olives in your olive oil didn't come from where they say they come from. So how do we combat food fraud, and what does that look like for the future of agriculture?
Can you repeat the question?
Sure. So I guess the question was essentially food fraud and how do we combat that, especially going in the future. Kaitana, you want to?
I'm assuming I'll take this one, guys. So Food fraud is not anything new. It's really anyone that's trying to make economical gain from deceiving consumers. That's really the definition of it. To your example of the olives or olive oil, right? You don't even have to go that far. You can put vegetable oil in there and mix it, and really you wouldn't be able to tell the difference. It's become a hot topic, especially, let's say, in the honey industry, in the olive oil, certain spices, Sudan red dye being substituted for another. The way we kind of have to combat that is we have to verify, that old Russian proverb, you trust but you verify. And it sounds very cliche, but you do have to understand where the ingredients you're getting are coming from, right? I tell, my employees or the people I've worked for me or even myself, I've had to go to China to verify a particular supplier and say, show me what you guys are doing. I've gone to Chile, South America, I've gone down to other parts here in the States and even Canada, and says, please walk me through your process. Who are you getting the seasoning from? Lo and behold, they're getting garlic from Gilroy, so I go all the way to Canada just to come back to California. But the reality is that you need companies and also individuals that are willing to really verify each of the steps. Now, everybody's going to tell me, oh, we're going to add another layer of regulatory, another check and balance, and that gets very expensive. True. But how expensive is it to be on the 5 o'clock news making the headline that you are selling something that is not, right? At the end of the day, it's your name, your brand that's on that particular commodity, and that is, call it what you want to call it, but that's worth more than the investment you'll put in. So in my view, to solve some of that problem is we really have to tighten up our supply chain, and more importantly, we have to put some additional technology in place, similar to blockchain, to be able to ensure that we're able to trace everything back, as not saying to the field exactly, but at least to the grower and what they're doing and what practices they're going about it. And it's not easy. Like I said, there's places in the world that have the infrastructure and other places that do not, right? So, but here in California, it shouldn't be that difficult, but as I like to say in ag, if we've done it for 40 years the same way, why are we going to change it, right? We have to evolve, and I think the growers do want to evolve. It's just there's always money's a factor into it. So hopefully I answered your question.
Yes, thank you.
Hey, does anybody else have? Yes, ma'am. Oh, if you wait, they're bringing a microphone, I think.
Go for it.
Yeah, go.
No. Right here.
So I have a friend who's a retired farmer, and I asked him at one point about his fellow farmers and what they were thinking about climate change, and he said, well, they're mostly focused on just what's happening this year, what's in front of them right now. And so I just wondered what you thought about that. I mean, it's sounding more and more like more and more farmers are on board and get the whole, get the climate science and understand the impacts. And I just wondered if, in fact, that really is happening.
Thanks. Anybody want to comment on that? Abe?
I want to maybe present something similar to that factoid there with regards to climate change. And if we look at the long-term scenario here, especially in the southern San Joaquin Valley, we're talking in the Kern County, maybe northern Kern County, southern Fresno County region, even in the Tulare County. You're starting to see a lot of farms start uprooting their almond crop and then changing that over to pistachios. One of the big reasons that you're starting to see that happen, in part, is, I don't want to call it quote-unquote climate change, because that sounds very cliche, but from the perspective of the changes in the soil, the changes in the environment under which your growing conditions exist. And an example of that is less rainfall basically reduces the amount of leaching in the soil, which increases the salinity in the soil. By increasing the salinity in the soil, almond trees really don't like a lot of salinity in that soil, so consequently the composition of the soil to be able to grow almonds has diminished, right, in some of these regions. Therefore, the transfer and change over to pistachios, in part, aside from the price, has also been the growing environment. You get a lower yield because you have a higher level of salinity. It's kind of like, it's the person who dies of thirst in the ocean, and it's the irony, right? You're surrounded by water and there's nothing for you to drink, right? Same thing in the trees. If all of a sudden all you had was groundwater and well water, but you're not leaching the soil, you're unable to push down those salts, thereby stressing your almond trees.
Any other, or anybody else in the panel want to add to that?
Yes, good afternoon. To the gentleman that was talking about the chill time in the trees, what is your opinion on, currently there's a lot of farmers that are currently using cover crops as a way to implementing and helping the trees reach those chill hours that they're requiring. Here at Fresno State, Dr. Garit Barar is actually going ahead and doing some trials of that. So what do you think? Is that going to be beneficial to the plant, or is it not? And are they going to be able to maybe this be one common practice in the future?
I will pass this one to Abe. He's more of the expert in this than I am.
Yeah, I think when we talk about chill hours, it depends on the region in which you're growing, right? So let's talk about Northern California as an example. For those areas that had, whether it be crops, some kind of row crop in between, or wild crops such as wild grasses, basically to prevent erosion is typically while they're doing it, or during the orchard maturity time, they're bringing in some of these grasses or some of these other annual plantings to be able to at least generate some income. The challenge that happens in that as well is there's also a backside. If you're trying to increase the chill time, but what happens if you have a frost? We saw what happened this last year in Northern California, where there were whole orchards that were decimated. We're talking they only received 20 to 30% of their normal yield, right? So there is a pro side in that, yeah, you're trying to increase your chill hours. That works in years where you have higher levels of drought, higher temperature. But on the opposite end, in years like this year and last year, where we had significant periods of either hail or snow or frost, that could potentially even damage your crop on the back end.
We just have one more question over here.
Hi, so it's more a comment than a question, I would say. So I'm European, actually, more specifically from France, and it's really interesting that you were talking about like the products that are forbidden actually for import, and I just want to precise that actually, like the list of products that are forbidden for French farmers to use on their crops is actually like way more diverse and higher than actually the products that are forbidden for imported food. And that's something that a lot of farmers in France don't understand, because there is a lot of products that they can't use on their crop, but they are okay from imported food. So I would say that's really interesting actually from my point of view.
Yeah, normally I think also when you have these trade agreements, it's what you can agree to between countries, and sometimes subsidies is a big thing. Somebody asked in the previous panel, and there are ways of hiding subsidies. You can call them production incentives or whatever you want to call it, but subsidies. So sometimes it's hard to track it down. So a lot of times when they do these trade agreements, they might say, which is not accepted in certain areas may be accepted in different areas, or it could be vice versa. Like Caetano was mentioning about these aflatoxin levels, which are much lower, the thresholds in Europe, than they're in the US. So within the US, they're higher.
Yeah, they're 20 ppb,
right,
parts per billion. Right.
So when we do import the other way around from other countries, they might have lower levels than here in the US. So a lot of it comes back to trade agreements, but I can imagine the frustrations French farmers feel when they have to comply by different. Any other questions before? Yes. Over there.
Yeah, I just want to add one solution to one of the panelists who said before that, there are whole lots of complications related to chill or frost So it's not that easy. So it varies interannually. I mean, one of my proposal is, it could be that we can have some sort of like interannual or seasonal prediction based on different climate models. So, currently I see there are many works, many studies which are focusing on climate change, I mean, the longer term projections. But on interannual basis, I see like it has been hardly applied in only very small scale in California and agriculture. So, I mean, I see the potential of using those like interannual or seasonal or sub-seasonal GCMs for projecting chill hours, so they can tell a few months in advance, okay, so this season or this year is going to be, have less chill or more chill than the normal chill, okay? So, if we can give them some, information on chill hour before season starts, I think that would be helpful. So, similar things can apply for frost or for other like climatic indices. So that, I mean, that would be helpful, based on the thing you said before. That is not a question, but just, like my proposition for those things.
Thank you. Thanks for that. Abe, do you want to comment?
Yeah, I would just say, if we're looking at forecasting, I have a lot of clients that will reach out and say, could you forecast this? Could you forecast that? And I, will do analyses and predictive models. We're talking machine learning algorithms like neural networks, random forest, adaptive boosting, partition tree analysis, predicting, things like what is the upcoming La Nina, this was last year, what would a triple La Nina scenario have? And the analysis basically suggested we were either going to get 6, from you look at the data from 1950 to the present, 6 out of 11 times you ended up with, 130+% of rainfall in snowpack. And 5 out of 11 times you ended up with, 70% or 45 to 70% of normal rainfall and hydrology. So the effect of that was we're going to have one of two extremes. We're either going to have a continuation of the drought or we're going to have extreme torrential rainfall. And you saw what happened this year. The year before that, when we had a double La Nina, the data suggested we were going to have year-on-year continuation of the drought. So consequently, there are patterns in the history of the data going back to hydrology, snowpack, rainfall. But at the same time, it's like, trying to predict the weather becomes very difficult. What we can say is looking at data like the Farmer's Almanac, looking at historical data of hydrology, there are indications of what's to come. But to have a definitive, this is what's going to happen, you're going to be just slightly above flipping a coin sometimes. And that's what I told my clients. I said, you're going to have one of two. Take your pick of which one you want to go with, right?
Difficult times, but in terms of like the chill hours, I mean, chill hour need temperature, not precipitation. And for temperature, models have very good skill in predicting temperature. So I mean, it's up to you that you use something out of nothing. Okay, so my suggestion is you have to see how models are behaving in different variables of climate, and you can use that skill score based on 40 or 30 years and see whether models are like predicting better than like nothing. Or you can compare whether just by taking climatological projections whether models are doing better or not. So that is a kind of work. And if it adds value, if it gives you some benefit by seeing by knowing those information in those years, whether you could have done something to avoid that, and if it makes benefit, then why should not we use that?
I completely agree with you. I think the chill hours, I'll give you the almond industry as an example. If you look at this last year, we had excellent chill hours for this upcoming crop. What we gained in the chill hours, we potentially may have lost on the bee flight hours because the temperatures during the bloom were much lower than any year we've ever had. It was the lowest in Northern California and the second lowest in the central and southern San Joaquin Valley. So consequently, the trees getting rested may have meant nothing if the trees did not get pollinated, and we're seeing a significant amount of bud drop right now as a result. We won't know anything for another month, but if things play out the way they have historically, we may be looking at potentially anywhere from 1,550 pounds per acre all the way up to 1,750. What would that mean in terms of a crop size? That's a 2.2 to 2.5 billion pound crop. Consequently, the effect of that is that we could be looking at anywhere from 20 to 40% increase in price, which is beneficial, but it's offset by the fact that we'll have a lower production statewide.
So we got one more question, and then I guess we'll be wrapping up.
Thank you. My question is about the labor force, and how are you factoring the fact that the average age for farm workers is 40 years old, and the pattern of migrations for people to come here to work are different. So how do you factor that in the future of the economic for the business?
Julian, you want to take that one about labor costs and future? You can pass? Okay. Okay, Tana?
So I can only speak to, the industries I've been in, but they've, the aging workforce that we currently have in ag, and typically the folks that are coming into ag are not necessarily, it's not attracting younger individuals, right? The truth be told, there's a lot of technology and a lot of industries that are putting a lot of money into technology to harvest crops, right? This is why, unfortunately, a lot of the grapes that were grown in California are now in Sonora, Mexico, right? Because the labor cost is a fraction compared to what we have now. There's been a coalition from the International Fresh Produce Association for at least 2 years at DC trying to get reform for, if you may, H-2A labor contracts. But unfortunately, that hasn't gone anywhere, right? And I'm not going to get into the politics of it because, one, I'm not a politician, but those are the facts, right? I see the industry in general putting a lot more effort into technology and trying to figure out how to replace the aging workforce that's occurring, right? Because most young individuals, even if they're coming in, through an H-2A program, they're having a hard time finding them, all right? And it's not going to go away anytime soon. But technology seems to be one option, but, we need to incentivize individuals to work in the industry, and some people have an attraction to it. I grew up around agriculture for a number of years, and I'll be frank. When I first went to a university, Cal State, I didn't see myself in agriculture at all. I saw myself working, at the Chicago Board of Trade or some office setting, right? Because my father was foreman for a number of years. But when I, found this industry, it's really changed my life. But we have to make it attractive, and it's, not just us up here as a panelist or people in education, it's also the industry kind of finding those talents and saying, look, we have different positions, different ways of doing business to really get the folks to attract, right? But in order to do that, it's going to take a Herculean effort from not just the industry and academia, but from everyone. So I can pass it on to Abe. I'm assuming he's looking at me.
Yeah, I'll add a couple of 2 cents here. So number one, I think that the industry itself, when we talk about agriculture, we're talking about agribusiness, we're talking about the farming component, the processing component, the shipping component, all of that is in transition right now. And when we talk about an aging labor force that focuses on jobs in those areas, I mean, let's start with the farming end. At the end of the day, I'm going to say automation, automation, automation. Along with that, you're also going to see a transition in, typically when we talk real estate and we talk about labor, there's going to be a shift in that as well. Historically, real estate focused on location, location, location. I tell my students there's 3 new L's that are coming into play when we talk about agribusiness in the future of how agribusiness is going to be conducted, and that's going to be location, logistics, and labor. You have to have all 3. And in that component, when we talk about how the implementation is going to go, let's focus first on the farming end. We talk about PCAs, and we talk about eliminating on the almond and mummies. Mummies are basically where almonds were not shaken off the tree. And typically what they'll do is you'd have an employee walk out there with a bamboo stick and hit the almond trees trying to knock off old almonds. Why do you do that? Well, because you don't want to have an infestation in your orchard the following crop year and have an insect damage issue. Now you're starting to see technology where you have a little robot, and I call it the 10-year-olds with little BB guns. And what it does, it basically, the little robot goes up, it's trained with AI, and it looks for mummies and it shoots mummies right off the tree. And it works 24 hours a day, 7 days a week, versus having to hire several employees to go through and shake off knock off the mummies with bamboo sticks. If we talk about areas in the production end, let's talk about electronic sorting. You used to have what would be the equivalent of the Willy Wonka and the chocolate factory room of ladies going out and sorting, right? Now that's not the case. Now what you have is you have huge electronic equipment that has electronic vision recognition and is electronically sorting that product with a much higher accuracy rate at 10 times the speed. So all of a sudden you're able to scale the business. Let's talk about the shipping logistics. No longer are you having, high school graduates, 18 years old, former linemen and linebackers on their football teams going out and grabbing 50-pound boxes and stacking them on pallets. Now you have robots that are doing all that work. And consequently, the employees that are working in those fields are focusing on value-added activities versus manual labor that could potentially end up with an OSHA violation in the future due to repeated back strains and repetitive motion. So consequently, there's a whole variety of different components related to automation that's going to come into play, along with the shift of location, logistics, and labor into the future for agribusiness. Thank you.
Thank you. And we have one online question, I think.
Yes, thank you. So the online question says, there was a lot of economic statistics shared, and earlier it was mentioned that communities are growing into ag, when in many parts of the San Joaquin Valley, ag is growing into communities. For example, Allensworth and Fairmead. These ag entities next to communities are extracting groundwater, causing community wells and domestic wells to go dry. What are thoughts on this, given that water for drinking water purposes is priceless?
I'll start off, and I think part of the theme for today has been, the future of agriculture in California. And for the future in agriculture to be there, it requires all stakeholders, all entities to work together. The policymakers, the agriculture industry, farmers, producers, as well as the residents and the citizens. So, and these kinds of conferences, I think, are a good way of doing that. We're sharing information. A lot of times, it's a lack of information, right? People say, well, the ag industry wastes water because they use so much water, to grow almonds. And we heard the ag secretary this morning say that the almond industry has reduced its water usage by 33% over the last decade. And the same goes for all the other industries as well. So a lot of it is education, which is where institutions such as Cal State Bakersfield come in. And also it's about training and learning and then sharing the information. And whether it's a government entity or a private entity, it's about having that information, sharing it, and coming at a discussion. And as an economist, there's always trade-offs. We can't basically get everything that we want, so we have to trade off. And obviously public health, education, and all welfare and all of that are paramount. And it's I think it's fair to say that the farmers and the producers want to live in healthy communities because they also live in those communities. But the question just is, how do we go about making sure that everybody is safe and the food that we produce is safe and that we're able to produce that. So I think it takes working together and identifying and knowing these issues and then trying to come up with solutions. And as I said, having conferences like these, we come up with a lot of solutions that we may not think of.
I'll add to that. Many of the, they talk about businesses or even the farmers. The shift has come where everyone wants to be a good steward of the, neighborhood they're in or the business they're running. No one's going to be in the business of, trying to shortchange anyone. Has that happened in the past? Yeah, it has. But the reality of the fact is, what Dr. Aaron alluded to was, a lot of times the organizations, as they're pumping out these waters for, they're creating jobs, and many of those jobs are helping the community. If the water source is not good enough, there's going to be a forum in which those communities can discuss it, right? I'm not getting into the politics, but I'm going in a little bit on the weeds. But more importantly, those organizations, like I said, want to be good stewards. They're going to bring folks from the community into their offices or their as they have these discussions to ensure they're meeting their needs. Now, is everybody going to get everything they want? No. You can go to a buffet and eat absolutely nothing because you don't like anything on there. The reality of the fact is there has to be a compromise that makes sense for the general public and everyone involved. But, to the individual that put that question is, I think we have to look at it from a not so cynical manner or way, but to look at it as these organizations want to be good stewards and it's in their best interest to help the community they're in. So I'll pass it on to whoever.
Well, it looks like we're towards the end of the panel, so I want to thank my panelists, Abe, John, Juliana, Caetano, and thank all of you for being here and for the questions, and for the organizers for putting this up. So thanks for having us.
Thank you very much. Thank you, Professor Hegde. Thank you. So I'd like to welcome our final panel of the day. This is the Experimental Smart Farm panel, and it'll be led by Thomas Harmon from UC Merced. And I'll let Thomas introduce our other panelists. Oh, I'm sorry. Sorry, Juliana. Thank you. Yeah.
All right. Thank you, everybody, for hanging in there. I know this is the last panel between you and the end of the day, and we'll try to make it lively. We're ending on a high note, I think. My name's Tom Harmon. I'm a professor of civil and environmental engineering at UC Merced. I'm also director of the Sierra Nevada Research Institute and co-director of the Experimental Smart Farm, which is starting up there. We put together a panel today to talk about what the vision for the smart farm is, show you some renderings of it, talk about the smart farm in relation to research, education, and industrial relations. And we have a great panel here. I'm going to introduce them briefly, and they'll each be able to say a couple words themselves. Let's see. There we go. Perfect. We have Lee Bernacki, and Lee is formerly the executive director of Citrus Merced, but recently got a big upgrade. We're super proud of her. She's the executive director of Vista F3 Innovate at the UC Merced arm of the big F3 initiatives. Congratulations on that, Lee.
Thank you.
We have Danny Royer, who is the inaugural farm manager of the Smart Farm, and invaluable. We have Pauline Cantonier from our friends at FarmWise. And we have a doctoral student from the UC Merced Environmental Systems Program and one of the first brave souls to be working out on the Smart Farm, Humberto Flores Landeros. I'm going to take the liberty as the panel leader to start off with a short story, kind of a UC Merced story. I've been there since 2003 when there was nothing, and I think it was probably, so I'm trying to think of when we first started thinking about the Smart Farm. It was probably a couple of our early faculty. I know Josh Fears was intimately involved with some of the early ideating. Sam Trena a little bit. I started thinking about it after them, but I remember, you know, it's easy as you look back at your memories to think about little things that helped you think about a big idea that came along. And it was about 2008, which was about the year 2008, 2009 was our first graduating class at UC Merced. So we were tiny then. We're still pretty small, but we were tiny then, about 800 students. And I had a senior class in subsurface hydrology field methods, and I had a student who was doing pretty well in the class, Ruby, who was from somewhere in the central San Joaquin Valley, farm worker family. And I asked her if she wanted to work in my research lab. She was doing really well in the class, and she said, sure. So Ruby came into the lab and joined the group with a couple of grad students. And at that time, we were working on soil moisture sensing and nitrate sensing. And the group took Ruby out to the field, and end of the day came, and one of my graduate students came up to me and said, you know, Ruby didn't do any work in the field, and she went home. And so I was kind of surprised, like a little bit alarmed that maybe she'd gotten sick or something, so I contacted her. And she came in the next day, and I said, Ruby, what's up? Are you okay? And she said, no, I just don't think it's going to work out doing research with you. My parents sent me to college to get an office job, not to go dig in the fields. And boy, that was just such a light bulb moment for me. And from that moment on, I realized, wow, somehow I need to teach these smart kids that, you know, there is some digging to be done, but there's a lot of theory and electronics that's going to go into this work too, and it's going to be fun. Well, fast forward to the end of the academic year, and Ruby is graduating. She's asking me for help to find a position, and she's an environmental engineer. And guess how many brand new environmental engineering jobs there were throughout the San Joaquin Valley? There were not a lot. I had a lot of contacts in the Bay Area. I had a lot of contacts in the LA area. So this was a very second big light bulb moment, a bittersweet moment where I told her, you can get a great job, but you have to move away from home and family. And that's when I started realizing, wow, I got to know my constituency. I've got a lot of first-generation college goers. Their parents haven't told them much about college because their parents haven't gone to college. Their parents haven't told them about an engineering career trajectory. They don't have any uncles or sisters who've done it, and they don't know that that's where the jobs are. And I think at that time, I started to come up with more of a line of thought about how can we make tech jobs that stay in the valley so that people that want to live here and stay with their families and loved ones can have an exciting career here. So enter the experimental smart farm. Here's a rendering from our architectural firm, Methune, that's been working on this. So what do we mean by smart farm? Well, it isn't etched in stone yet, and we can probably even get some good ideas from the folks here today. But what we really mean is that at this point in time, we can monitor most things of interest in terms of the big things, water use, energy, crop yield, and we can get ready to monitor more detailed things. Carbon, for example, work, how much work is done by the humans, how much work is done by machines, and that we can keep track of these things, especially on a small farm scale, and our farm land is about 45 acres, so that will be a small farm. We can start to move towards a situation where we have not just data piling up. The last thing in the world that a grower needs is mounds and mounds of data to sort through every weekend. But data is turning into information. Information is turning into forecasts. We heard that on the couple panels ago, looking at the weather forecast 1 week ahead for the irrigation systems. Forecasts and recommendations, and feedback and control. So things begin to get automated, things get to be smart. We also like to think about smart in terms of human resources, elevating the worker, making the work experience more enjoyable, less onerous, less prone to injury, safer. All these things are important. So this is kind of what we mean about Smart Farm. So why now? Well, to get 45 acres on your campus is no small feat. You have to convince your chancellor and upper administration that you're going to do good things with us. And we did a good job of convincing him through some really successful grant writing in the early 2000s. We hit the National Science Foundation, the U.S. Department of Agriculture, the University of California Office of the President, with a lot of initiatives, big initiatives on automation, agricultural technology, labor and automation, all kinds of things, and this bridge programs for students coming in. So it's pretty interesting when you think about it that we don't have an ag school, we don't have an ag department, we don't have an ag major. We have engineers and scientists and social scientists who work in the ag area, and that's what we're starting with. This year, this came after our successful grant run and our granting of the land by the chancellor, but we also hit another milestone where we were named an agricultural experimental station, which will give us some land grant status and some resources on an annual basis. We'll be joining Berkeley, Davis, UC Riverside, and Santa Cruz joined in the same class as us, but it's been about 50 years since this has happened, so it's quite a milestone. So the initial research vision, and this is just ideas. As you know, faculty are going to do what they're going to do, but based on who we have on our team right now and who we have in the different buildings, we had some visioning groups by these faculty and other staff, and we definitely want to work on automation, technology that increases productivity and quality at a reasonable price. Again, we're small. We're not going to be able to do a comparison of 3 strains of almond trees on our 45 acres. We're more about proof of concept, perfecting articulation and robotic movement before we upscale to field tests somewhere else, perhaps here with our colleagues at Fresno State. Wouldn't that be great? Machine-human collaboration, as I said, less strenuous, safer work with multiple pathways towards advancement. Lots of careers for mechanical engineers, computer scientists, machine learning students, or technicians who wrangle these robots and bring them to the field when they need to be taken out there for harvest time, bring them back in and service them and move them on to the next site. The third leg of this stool is the environment, sustainability. And UC Merced did have a lot of early faculty in the area of environment. I'm an environmental engineer. From this perspective, we like to think about multifunctional technology. If you're going to invest a fortune in creating this robotic device that can pick a peach without damaging it, it seems a small add-on for this device to be able to measure soil carbon, soil moisture, or pesticide residue while it's doing that. So thinking about multitasking, moving towards automating environmental compliance to keep it less onerous for the farmer, these are the sorts of things we have in mind. Community engagement is important, of course. We want to have eventually, we've got a long way to go, but grow the same community bond that we know that's strong here between the Bulldogs and the Fresno community. We want to have our community garden, plants and produce stand, our farmers market, extension classes for people aspiring to be master gardeners, school field trips and demonstrations. So this is the whole picture of what will be out there. This is on the southern edge of the Merced campus, and if you haven't been out there, we'd love to host you and show you around a little bit. But here it's a little fuzzy, not coming through quite well on this projection, but we're looking to the east at the Sierra Nevada, and there'll be this facilities and research core literally on the foot of a cowboy boot-shaped plot, and then the leg of the boot is the experimental fields. So that's your brief introduction to the Smart Farm, and now I'm going to turn it over to Pauline.
All right, beautiful. Hi, everyone. I'm Pauline. I'm the head of partnerships and marketing at FarmWise. So all of the concepts that were just mentioned are things that we work on. We're a team based out of Salinas/Santa Clara, and we deploy computer vision, artificial intelligence, that we plug into farming machines to make them more precise and therefore more efficient. And our very, very first focus is weed control. So we've been helping vegetable farms from the Salinas Valley, Oxnard Plains, and then down in Imperial Valley to automate a very labor-intensive process, which is weed control on lettuce, cauliflower, broccoli, so the traditional crop mix of these areas. And so we do that by capturing image of the plants as our cultivator traverses the field, and we built algorithms. So we teach computer to recognize things on this image so that we can trigger a mechanical response from the equipment that will be very precise. So in our use cases, we are detecting the crops from the weeds, we are locating the meristem of each crop, and then we're actuating blades at speed and with at a half-inch precision around the crop. So our goal is really to automate a process that's usually done by hand or using standard cultivation, and we're mixing all of these processes into one. It's a pullback implement. Traditionally, you have a tractor driver, the implement goes and does its job. So that's what we've been working on over the years. We started as a team of Silicon Valley people, so traditional, I'd say, software engineering background, mechanical engineering background. Now our computer vision team is based out of Paris. Our founders were French. I'm French too. I grew up on a cattle ranch and a row crop farm. Turns out the valley does attract people from outside. They don't just have to move out of it. But we are now growing into more of, I would say, more balanced team. We have people coming from, those agricultural communities who grew up in families that were picking out crops in the field and are now, moved into supervisory position where they supervise the quality of, we could call them robots. They are farming machine with some elements of robotics into them. So we have beautiful success stories around that of people who came from a strong, I'd say, operational background in ag. And there's also the other side of the company where you have crazy PhD candidates who have only worked in labs and have never put a feet in their field. And so we're kind of bridging the gap on both sides. And I have one crazy slide for you. That's our latest machine, I would say implement. We released it at the Tulare Farm Show a couple of months ago. This is kind of the fruit of labor of 5 years of in-field operation and testing. So, there's ag-tech, agricultural technology field gets a lot of buzz. There are a lot of stuff out there and cool, sexy technologies. It's really hard to build products that end up in farmers' hand and really meet their requirement. So when we released the machine, I had a couple of reporters coming up to me at our booth who told me, wow, it's probably the least appealing thing you've ever worked on. And to me, that was the best compliment we could get. this looks like a farming machine because it is a farming machine. And the emphasis was put not only on the precision and the efficiency, but also, I'd say the beauty of the tech, but also the reliability, the ease of operation. We want this implement to be integrated into every operation that's out there. We don't want someone with a special degree to be able to operate this machine. We collect a ton of data. So back to the comment you made earlier, we collect a ton of data to do what we do. We could collect even more data Goal is to not overflow the grower with data, but rather make sense of that data through in-field actuation and intervention, but also some agronomic report that could come back. We count crops, we have an approximation of the size of the crops as we go through the field, because we literally take high resolution pictures of every single crops that's planted. So there's a lot of potential with this technology, and I'm super excited to be here. We are working with academic organizations. We wouldn't be there without them, not because they fund our projects, but because they educate us. They partner with us, they invite us to speak at events. They help promote our technology. So we've been working with the research station in Salinas heavily, with the University of Arizona, of course with Davis. That's been kind of I would say a natural organic collaboration between us, and we could use some testing ground. So we'd love to talk to you about that.
Awesome, thank you, Pauline. We'll circle back to you in a moment.
I think it's...
Let's see, now we're going to, I guess we'll just go with the flow here, okay? So Humberto is going to show you just a sample of some of the first tidbits of research that have been happening out on the farm.
Yeah, so hello everybody, I'm Humberto. I'm a second-year PhD student at UC Merced in the Environmental Systems program, and I have the honor to work with Dr. Tom Harmon, and today I'll be presenting some of my work that's kind of relevant to the farm, I would say. So it's entitled, oh, did I skip forward? It's entitled Using Biogeophysical Models to Connect Soil Carbon Dynamics with Irrigation Practices. So let's begin.
Just a little bit of lag.
Yeah, so mostly I'm here to talk to you guys about the relationship between soil and water as it relates to carbon dynamics. And these relationships are very important, especially here in the Central Valley, where due to our crop types, soil types, and climate, we're not really able to do dryland farming like other places in the country. Instead, here we have to supplement with some form of irrigation. That means that there's someone making the decision of when, how much, or how frequent to irrigate. And these, of course, are all things that affect the overall CO2 production. So here's some general theory of how moisture affects the CO2 production in soils. So to your left, you'll be able to see a soil that is completely dry. It has a high O2 concentration, but not enough moisture to see any biological activity, therefore not enough CO2 going off the top there. Now, in the middle, you'll see a soil that has a little bit more moisture, still enough oxygen concentration to see CO2 production, eventually lead to high concentrations to see high CO2 efflux off the top. To your right, you'll be able to see one that is oversaturated. There, the oxygen's being depleted, CO2 production should be dropping, but the concentration will be going up as the CO2 will have a harder time kind of leaving off the top there. There we go. So of course, we're interested in looking at these relationships at a larger spatial scale. So now what you're looking at here is this map of a bunch of soil textures across the field. Red could be one soil texture, yellow another, blue another. And we can then rasterize, essentially cut this field up into different little cells. Now I want you to imagine we pull out one of these cells. For example, here you have this red one, and that cell will have values that are unique to its location and its soil properties. We'll have hydraulic conductivity, how water moves through the soil, porosity, the spaces between one particle to the next, surface water, saturated water content, That's how much water a soil will hold at saturation, and also residual water content, how much it will hold on to once it's dried. So we'll be using Hydrus, this model, to simulate the flow of water through this soil. So what Hydrus does is it accounts for the physical, the thermal, and the chemical properties. The unset chem module in particular accounts for the chemistry, the diffusion in liquids and gas, convection, and dispersion, which is where we get our CO2 efflux from. So now that we have the building blocks for our model, we can kind of look at this schematic here. So we'll have these soil types, and we'll use MATLAB, this programming software, to essentially feed our hydrous model with these soil parameters and run the simulation and get our CO2 efflux, and we'll do this continuously. We can then use this CO2e device that you see up there to validate this out in the field. Okay, so now what you're looking at is some results. So here we have the mean efflux at the field for all these cells. So you can see just how water affects the overall CO2 production. So right there, the blue lines are the irrigation. So you can see how CO2 is dropping. And as we talked about, this is probably because the CO2 is not finding a way out. But as soon as it starts to dry, we see it quickly peak back up and then start to taper. And then again, it gets another irrigation dose there and drops and repeats. So here it is a different simulation. Here we have irrigation every 3 weeks. We're getting 6 inches, so you can see how that changes. But let's say you don't just want the average value of the cells. You want to know what the entire field looks like. Let's say T equals 400 hours. We can look at that. Or we can look at T equals 1,000 hours. And the darker colors just mean higher CO2 efflux. And we can then go into the code and essentially look at what parameters are causing that and allow us to kind of make sense of these relationships. So in conclusion, CO2 emissions are dynamic and the result of complex relationships, but making sense of them are important in order to make climate-smart land management practices, perhaps inform soil carbon sequestration, allow us to use soil types or soil properties as proxies for CO2 emissions, also allow us to determine the carbon footprint of a field, or understand how we can pair carbon sequestration with aquifer recharge and AgMar. And that's all from me. Thank you.
That's awesome.
Nice work, Umberto.
Thank you.
Can you back it up to the farm slide? I think like that vision.
Danny's up.
So I've only got about 30 slides to go through, so I'll be real quick. So I'm Danny Royer. I'm the farm coordinator at UC Merced, and it's a kind of a really cool position in that I've got a really blank slate to play with, and I have no background in academia, so I'm coming into this position very much with an industry mindset and thinking about how do we create and facilitate world-class research while also producing competencies that I know our industry is in dire need of, which those are competencies in computer science and engineering and mechanical engineering. So as we look at our farm and how we're building it, oftentimes I will get asked, well, what are you gonna grow? What are you farming? And the primary thing that we're farming on our farm, and I think this is what makes us unique, is data. I'm not really that concerned about what crops I grow. I'm concerned about making sure that somebody who's doing research gets the baseline data they need to correlate their specific research data to. So whether that's water data, labor data, energy data, all those data components that create our baselines for research, we want to facilitate that and basically automate that. In research and R&D that I've done in farm settings in my past, and even when I was doing a little bit at Cal Poly and their farm operations, one of the most costly pieces of doing research is in data collection. It's in someone going and looking in a system and looking for an Excel sheet to go find a history here. It's going and looking up PG&E bills. That takes labor. That's someone's time, not to mention if you have to actually go collect data in the field from a flow meter or something like that. So uniquely, we're really trying to decrease the cost of research by digitizing what we're doing. So when you look at the farm behind me, we have 35 acres to start off. There's more land to expand on. We're unique in the UC system in that we actually do have some expansion opportunity. But right now we're starting with 35 acres, and those 35 acres are going to be broken into about 28 or 30 different 1 acre blocks, roughly 1 acre blocks. Some of them will be a little smaller, some a little bigger. But what we're doing is all of those blocks, the water and irrigation that goes into those will be automated and monitored remotely. And any of the data that we're collecting on those, we're building the data lake now. And so whether it's a Microsoft form that we're using to collect labor data, or whether it's Ag Monitor that we're using to bring in energy data, all of those blocks will have the unique ID structure, and a lot of those fundamentals in data science we get to start with now. So it makes our data really operable. So not only are we looking at collecting the data, we're making sure that when we store the data, we're going to be doing so in a way that makes it operable for the people that need it. So looking at APIs and making that data available for researchers. And then when we have researchers who want to make what data they're collecting available, making sure that that's in our lake, it's secure and protected, but if we do want to make that public, that that's available as well. So the unique of our farm is definitely going to be that we're focusing on data. And then I think the other big component about the farm is that when we look at, I have a side job where I have a consulting company that helps a lot of institutional investors that are investing in ag. And the biggest challenge they have right now is competencies in data science. How do we bring the data from all of these disparate assets that we're acquiring together into one uniform system? And there's just not people that do that. And not only are there not people that do that, it's really hard to find people that do that and get them to come to the Central Valley. So I think UC Merced has a unique opportunity in our farm in creating a playground to create pragmatic competencies in both mechanical engineering and computer science and engineering that we'll keep right here in the Central Valley. I can talk a little bit about our crop plan, very forage heavy. It's not a mandate, but it's kind of maybe my own experiment, but I haven't got any resistance yet. No intentions on using any petro-based chemicals, whether that's a herbicide, insecticide, fungicide, same thing with fertilizers. Don't know how that will go. I like having a toolbox with all the tools in it, but right now that's the direction we're going. And we'll be a forage-heavy operation to start because we're looking at soil carbon and how do we build soil. So the majority of our operation will be grass and hay, and then we'll have some isolated opportunities for research, and those opportunities will grow. And then we'll also be looking at some row crops that, and looking at how do we create some revenue with what we're doing on the farm. We've talked with our chef, and we're actually at the UC, and we feed a lot of people within the UC system. What's wrong with us producing heirloom tomatoes for a certain part of the year? And if Daylight Foods is coming to drop food, why couldn't they do a pickup and distribute some of those tomatoes to some of the other UC campuses? So looking at tomatoes specifically, only because I have a pretty strong background in growing tomatoes. So that'll probably be one of the crops that we start with. And it's exciting to think about not just the fact that we're growing it, but also looking at the supply chain opportunity of, revolutionizing or looking at procurement in a different way within the UC system. So there's some exciting things outside of just what we're doing on the farm when we start looking at the supply chain side of what we're doing. And oh, by the way, the great data that we'll have will include food safety. So all the food safety boxes that we need to check, our water testing, all the fun stuff you have to do, that data will be in that same data lake, and we'll be able to pull that data out, and whatever reporting requirements a UC might have that's different than what we have, we'll be able to meet those because we'll have the data available. That's all I have really right now until we have questions.
That's great, Danny. Lee, if you could please now connect that farm to the big world.
Oh, my pleasure. Thank you for the opportunity. It's been an amazing day, and I've learned so much from all of you. I'm coming from Farms Food Future, which is the group that was formerly known as F3, and I come bringing good news. I wanted to thank you all for your support of this program over the years. It started in 2019 in Fresno, and it's really come to fruition. And so the farm and Fresno State's farm and many other farms in the region are the start of it. Then in the middle is the food. We have to keep the focus on the product, and then the future. So this opportunity to work with Climate Now and the Maddy Institute to share a vision, I think a shared vision is really wonderful. For us, that vision is a pathway to prosperity through inclusive innovation in agri-food technology. When I was here last, it was 2019. We had survived another year of the drought. It was PPIC presenting on the impacts of the drought on San Joaquin Valley agriculture. And it was just in this room. Sigma was a dawning reality, and we were not cohesive about how we were going to react to Sigma. And since then, it's rained. We've built a new coalition, and people have accepted that Sigma's real. Let me share a little bit about the F3 coalition and what we have currently in terms of resources and partnerships, how we're going to do it, and how that connects to Fresno State, UC Merced, UCANR, and all the other organizations involved. So our coalition is a group of people who envision the Valley as a climate-smart ag tech leader for the world. We're not going to just export almonds, we're going to export ideas and technologies. What's new is we have unprecedented federal support. We have $65 million. It's the biggest investment that we've ever received in this region from the federal government, and it is the biggest award. They gave out $1 billion across the US from the Build Back Better Regional Challenge, and they chose this region as the place that deserved the most funding. Not just because we needed it, but because they trusted us with it. We've also had generous state support from CDFA and other partners. The thing I'm really excited about is our educational partners. Fresno State has been amazing to work with, especially the researchers, a vast network of community college leadership is working together to build the workforce pipeline that includes existing farm workers as well as students who might come and lead these tech companies or these new jobs of the future. We also have UC Merced is ready to work on agri-food technology. We weren't ready a few years ago, but now we've realized it's a strength, and our university is focused on research and delivering on improving the economic sustainability of this region. We also have a strong network of community partners, and I'm excited to learn and work with all of them and make sure that we deliver on what we promised. And if you're with industry, this is my one request from you at the end of the day, like, please bring your problems to me, to us. We want to work with you on them. And so we have community, industry, and academic partnerships to solve real problems at multiple scales. And then we have our experimental smart farm as a place where we can do these things. Our approach is a little different. This is not Silicon Valley. You all know that in the Valley we have a different vibe, a different pace, a different climate, 65 days over 100 degrees. We just have a different way of doing things, and we're not going to use the same approaches for investment in technology. We're going to use inclusive innovation to include more people in the agricultural and food system. So that means for us co-development of knowledge from day one. We're going to include the people who are affected by the problems and the people who are affected by solutions so that we can solve things differently. We're going to accept the expertise of this region in agriculture. That's not something we're going to throw away. This is something that we're going to build on to build the future of agri-food technology. And we're going to make a conscientious effort to deliver on the technology for multiple audiences and stakeholders and make sure that it's available at different scales and that it's accessible to many users. You know, with our diverse cropping systems, we need to really adapt existing technology to new situations, be flexible. So basically, UC Merced and our partners across Farms Food Future are open for business. We're here to help. I'm going to ask you to help us build the farm of the future, and the farmers, technologists, climate consultants, economic development specialists, and people like Pauline and Umberto, and companies like FarmWise, like, please help us build things like this. Help us build the future of agri-food technology. So I'm not a therapist, but you can share your problems with me. please share your vision of what we could do differently and what kinds of jobs are going to be like, not the jobs that we're training undergrad students for now, but like what's my 4-year-old going to do in the Valley in 2036 when she graduates? What are those kinds of jobs, and what are the cool like climate accounting jobs and helping people access cap and trade funds, and there's all kinds of new jobs. So help us understand that future, and finally help us work on the farm. We need help. It's not just a place where our faculty can fight over resources. It's the venue for our wedding, you know, of many different kinds of academic and industry research. And so we need your help there. I encourage you all to check out f3innovate.org. That's our website currently, and this has been a long time coming. I'm really grateful to all the partners persisting through drought, flood, fire, and federal granting, and I'm looking forward to your continued partnership. Since the premise of this conference was about the future of agriculture in California, I'll just share that our vision is for California to be and the San Joaquin Valley in particular, to be a global leader in agri-food technology and climate-smart agriculture. And I dream of a cleaner, greener, safer, healthier valley of connected communities and economically secure individuals.
Outstanding, Lee. That was really good. So I've got a few questions for the panelists, and then I welcome the audience to cook up a few as well. First, I wanted to ask Pauline, as FarmWise or other ventures like that in your life grow, what kind of, not necessarily majors, but skill sets and knowledge do you find ideal for students that you would be recruiting?
So the good news is that we recruit, I'd say, across the board. We are always looking for experienced techs and fabricators. Those are our, say, some of our most precious resources, and also the harder to actually find, as everybody, you know, the entire Salinas Valley fights for techs. People who are, you know, hydraulics experts, people who are electricians. It is a challenge. So there's that, and then when it comes down to engineering, the bad news here is, or like, I wish I had a better kind of story to tell, but we do hire a lot outside of ag, like people who have no context and worked in the space industry, in electronics industry, autonomous vehicle, which is very, I'd say, like dominant. Big tech also, we've had people coming from Apple, Amazon, and whatnot. So we are fighting with companies who have much more resources, budget, perks, and you name it, that you wouldn't imagine before actually like getting to know about these programs. So it is really challenging to hire them. So what we hire them on is the mission and the vision, and like we work on real technology. Like we are not working on a product that will have reality in 50 years. We're working on a product that has an impact on the farm today, that generates cash, that saves growers all from a lot of pains. So that is not all we have to offer, but that is a big kind of piece of the puzzle for us, or a card that we have to lay on the table in order to hire those talents. So in the world of engineering, we seek electrical engineers, mechanical, hardware engineers, computer science folks, so people with front-end development, back-end development, machine learning, computer vision, camera perception experts, you name it, embedded software engineers, so people who integrate, who help our machine be precise, like, oh, how do I take this input from the camera and turn it into this smart action, like the movement of the blade, for instance, in the ground. Like those folks are really, I'd say, precious commodity and hard to find. So a lot of fields. Mm-hmm.
That's awesome.
Very nice, thank you. Next question I have is maybe Umberto can take a swing at it, and maybe Danny, and maybe Pauline too. But one point I alluded to was that we have these devices. They look like maybe they're not terribly cheap. What added value can be incrementally added to these types of things? And maybe start with Umberto. And I think you mentioned your CO2B device. Maybe give a little bit of additional information of some directions you've been going with that.
Yeah, so that CO2B device that I showed earlier in that slide, if you remember it, it kind of looks like a little chamber, almost like WALL-E, if you've seen that Disney movie. Essentially, it's this little chamber that we put on top of the soil, make sure that it has a good seal so that no CO2 is escaping. We hit start, and then it starts logging the CO2 as it's climbing. And yeah, I've been using it at the farm site now for a while, and just keeping all that data and essentially coupling it with that model I shared to eventually, cross-validate, because do we really trust computers that much? We also need to validate out in the real world. So essentially, it's what I've been using it for, just coupling.
And who's been doing that?
Who's been doing the actual CO2s? We got a team. It's not just me. We got even Dr. Harmon's been out there. Some people in the public, even Angel, if you remember him from an earlier panel. So we got a few. We got undergrads out there. So
what about next year? Who do we hope's doing it next year?
That's a good question. I don't know. Well, we have a robot.
Yeah. There we go.
I don't know if I was supposed to reveal that, but we have a robot in the works. Hopefully, eventually, it'll go out there so we don't have to, and it won't just do CO2. It'll have some prongs on there to measure the soil temperature and moisture, and along other things, hopefully implement some computer vision to it or some LiDAR technology, so we can look at the canopy, et cetera.
Yeah. If you're familiar with the burros or the Amigos, these little carts that know their way back to the truck and that sort of thing, we've been working with some Stefano Carpine in our computer science department about an actuated arm on the rover, so it can just put the chamber down every once in a while and take the place of the displace our undergraduate helper. So we'll have to find something else for the undergraduate helper to do, but I'm sure they'll be happy.
Yeah, it gets hot out there.
Danny, you want to take a crack at added value on tractor or something?
So, I mean, the carbon comes to mind, but it's such an abstract space, especially in specialty crops right now. But, more and more we need to move to systems that monitor and measure digitally, or not even necessarily digitally, but we don't have to do much to measure it. The collection of the data becomes easier, and as we move towards, and now blockchain doesn't have a good connotation, but forever that's what we talked about. But as we move towards more transparent and secure ways of transferring information between spaces, I think that things like these, a robot that's going out and pulling out, carbon emissions at different stages of cultivation, or after different applications that we're doing in the field, at different stages of growth. I think there's interesting things you can start quantifying in terms of carbon metrics, but right now it's really hard because it's so abstract. So that's definitely one of those 5 to 10 year, problems, but it's definitely something we should be focused on today.
Pauline, any ideas?
So we take high resolution photographs, I'd say, of plants. So there's a couple of stuff we can draw out of that, whether it's counting the stems, we are drawing the contour, like the outer edges of the leaf. So we have, I would say, an approach of the diameter of the plant. We also have like the stem to stem spacing. So we're able to offer a couple of data back to the farmers, which I think are of value. That allows them to evaluate the performance of previous operation, like how is my emergence rate doing, my stand, like did my transplanting contractor mess up transplanting, or did someone like run over crops, like there's poor emergence at this side of the field, maybe I should investigate. So that's what we're interested in, kind of giving back from the data. That's what it is easy for us to give back and what we're interested to give back. I think now sky's the limit. We have a machine that traverses the field. So as you're doing that, might as well, you could potentially envision adding other sensors. So our little box that generate lights and capture the images have, right now have, I would say, an overkill amount of computing power, and we could add other camera lenses to be able to capture different things, whether it's a measure of the chlorophyll level index or other kind of light reflectance. So we're very eager to partner with people who have kind of use cases in mind for our technology in our industry. So we're predominantly serving, I'd say, your leafy greens and cold crop growers. Having an estimation of yield is very interesting. Usually it's done through human forecasters with, kind of like simple math and some samples, out in the field. So having a way to kind of have data at scale for that could maybe help those forecasters review their prediction rather than replacing the forecasters necessarily, but just having some like benchmark would be useful. So that's something we're eager to work on with grower partners.
Outstanding. I'm going to come back here at Lee and Pauline on this one. I'm intrigued by the expression inclusive innovation, and there are different levels of innovation, right? There's somebody who realizes I can use machine learning to recognize weeds. But there's also the person who realizes I can build a better actuator than anybody, and actuators are used in everything. Do you see that fitting in, that the second level of innovation as a good fit for some being more inclusive in the valley?
Yeah, I'm trying to think of how to respond. Do you have a ready response?
I don't.
I stumped
Always
the,
with
I stumped
hard
the panel.
questions. Nailed it. I think for inclusive innovation, and this came through many conversations with the Central Valley Community Foundation and our community partners, is that there's a whole part of F3 that is focused on local food production, and that means like making salsas and working with very small food operations, and then also working with local farmers of all scales, a lot of small farms. I've worked with Ruth Dahlquist Willard for a long time followed her work as she helped Hmong farmers navigate the drought, and I often think about them. How can they access the technology? We lost a wonderful strawberry farm in Merced due to rent and issues with water access. And so how can these interventions serve the farms, maybe ones that are embedded with communities? And so I feel like thinking of a specific litmus test and having those use cases where can they access it? Can they access it? Can they afford it? What are the who's being excluded from this technology is, I think, a question we'll have to ask of every intervention, and how can we make it more inclusive? So, for example, at the World Ag Expo, we saw a farmer driving the Amigo and like not speaking English. So it doesn't have to be in many languages to recognize how useful a small weeder could be on many scales of agricultural production.
That's interesting.
Yeah, so inclusion is I'd say it's a tough concept because it can be interpreted in so many ways. I'll say it because it's obvious maybe. I'm the only representative of my company here today. We're 70 people and I'm a woman, and I'm sitting next to a woman, and I think this industry could use more women, so pretty proud of that. Now, inclusion on our side is making sure that we're including the people we're serving in the product development. There is no technology that gets built without the farmers, and we built a service business. That's how we've been kind of generating revenue over the past few years, and that's been our way to put the technology into growers' hand and get firsthand feedback, and that's how we've been iterating on the design, like both software and hardware, over the past 5 years, and that's how we've been able to come up with this next generation, which we think is like a total next step up from anything we've seen in the market. So without them, there is no product, there is no company, there is no FarmWise, because our investors, which are Silicon Valley firms, will ask for growers' approval before sending us the check. And if farmers are not saying they believe in what we're doing, and if they like what they see, what they're using, how their operators are using the equipment, we don't get any money, so we don't go anywhere. So that's been, I'd say, the journey for us is how can we be mindful of their time, make sure that we're bringing efficiency and value to their organization while also developing the products. And I believe there is a irreducible field time that needs to happen before you can actually successfully achieve that. So I feel like we're finally getting there, but that's, I'd say, our approach to inclusion. And making sure that we cater to the communities. We hire a lot of local workforce. We upskill a lot of local workforce. We have a team of 25 people, and we're a small company, but we have a team of 25 operational folks, mechanics, fabricators, inventory folks, sales managers, and field scouting crews. So these people are coming from ag, from the community, and we try to do our best to source from those rather than, I'd say, uprooting people from elsewhere.
I'll just add one thing from our research at UC Merced that we found representation in the media that there was little reference of connection to SGMA, the Sustainable Groundwater Management Act, to communities. It was largely represented as an agricultural issue, and so it kind of excludes the communities, at least that one sect of media. Some other people do a better job out there. But I think your point about the communities is really important. Citrus is focused on the interests of society and making that technology available, but also the impacts available to a broader community. And I think some earlier panelists talked about how not only are we all affected by agriculture here, but agriculture affects, what's grown here affects the world. And we all eat here.
Thank you. Are there any questions from the group?
Great panel, thank you. I do have a question, I believe it's for Danny. You had mentioned on the 42 acres that it wasn't a lot of land, obviously, for extensive research. One of the questions that I have is related to geographical bias and the soils. Obviously, if you have 42 acres, but it's one composition, so sandy loam is going to behave differently than clay soils in a certain regional environment, so forth and so on. So I love the idea of having all the data collection and being able to use that data to find unfound correlations in the data, being able to create predictive models, potential yields, et cetera. How do you get around some of the regionalization? Would you bring in soils from other regions?
So I would say that our farm isn't going to be very focused on that type of agronomic research. We might have researchers who are, and that would be their place to bring in that more regional data and have a more regional look. I think what we're going to have a lot more of is little robots running around trying to sense things in different ways, and then creating templates and models for how to collect that data, put it into, I don't want to call it a database, but put it into a lake or a warehouse that can then be fed into a modeling system that can train a machine to learn. So I don't know that we're going to be looking at very specific agronomic research like that, so that's not incorporated into kind of my thought process. But if a researcher came and said, hey, I want to do this here, and I'm doing this other research around soils in these other 5 places, I'm going to be able to give them all the data they need from our place.
Yeah, just to add a few sentences, we envision having the blocks well characterized and monitored, sort of a canvas for the researchers to do their work on. They'll know their moisture, they'll know their microclimate in that zone, but we'll tell them, you're on block 28 and it's a little clayey. Is that going to affect your plants? That sort of thing.
probably hear you. Yeah, we could probably hear you.
Thank you. How large a plot would you have to have for the Vulcan system, or whatever you call it, to be cost effective?
Yeah, that was also something I wanted to mention about inclusion, which I forgot, is right now our system is going to provide like a 2 to 3 year ROI, like payback period for a farm that's farming over 2,000 acres of land. So we're not catering to small farmers yet. So our journey is definitely going to be one that how do we make sure that we nurture other segments. One could say that this is the state of the world and it's very sad, but we see more and more consolidation of farmland, so we're gonna see more and more like those absentee landowners or mega, like they might be still family farm, but they farm on tens of thousands of acres, so they are a very good candidate for what we do. They might have operations in different regions, so they are transferring equipment from region A to B, like let's say Salinas Valley down to Yuma, Imperial Valley in the winter. So these guys are definitely our people at the moment. Now moving on, like your small company, you gotta be focused and you gotta allocate your dollar on the right thing until you can just be a tentacular organization and serve many, many different people. I think we'll get there. The great news about that, in my opinion, is that the cost of developing those technology has gone down. That's why we exist. It's gonna keep going down, and that's what's going to be making it possible for us to deliver products to smaller farmers. Especially thinking about other regions we might serve, like European, farmers might be structured differently, right? Like Salinas Valley is the only valley in the world that is set up that way.
Question up here.
So first, I just wanted to mention I'm glad to see another French woman working in AgTech here. So that's cool. So that being said, I'm not sure, maybe I missed it, but I wanted to know what kind of crops do you have in your smart farm, actually, in New Somerset?
So for the last probably, we aren't 100% sure, but 100 years or so, the land that we're developing the farm on has been irrigated pasture. There has been periods on some of the land I can't verify on our plot specifically whether there's been corn and some other row crops that have actually been produced. What we're doing right now is we have a winter forage planted that we planted in the fall. It's the first time the ground has been tilled in a good period. We actually aren't 100% sure when the last time it was tilled. So we're starting with a winter forage, and then we'll move into a grass-heavy and forage-heavy crop rotation on probably 80% of the land, and then move into, on that other 20%, more intensified row crops. And right now, this is our first year having anything planted ever. So this is a blank slate. So I don't even have a new irrigation system yet. That should be getting installed this summer. And once that happens, we'll have a whole lot more modularity and flexibility in what we're doing. But the crop plan is kind of a blank slate. So if somebody came to me and said, we want to do some research, I would say I need to figure out what it's going to cost, and then we could come to some sort of agreement, because we aren't even at the point where we have those types of service level agreements or those types of contracts in place yet. We're developing all those types of governance programs and systems as I'm speaking.
And one more up here.
Okay, I have a question on the robots. Are they the intention of adding also ways to actually check, do radar detections for like salinity and all that stuff in the future or right now? Or is there something already on the way, maybe like, to calculate that?
So I think there's a couple ways to answer that question. One is there are absolutely people who are working on complete solutions to do those types of things. I think what's unique though, and we've hit on it a couple times, one of the neat solutions out there right now, not to take away from the awesome work that FarmWise is doing, but a different solution that's more of just a platform is we've said Amigo, it's the Amiga from FarmNG. And I think that that's a really interesting platform because it's super cost effective, it's very cheap, it's got open source programming that allows, if I'm just got out of school and I'm going back to my family farm, or maybe I have greenhouses or I have something like that and I know how to do some base coating, I can learn how to use this and start doing different things that I need done around the farm. And then I think the fact that it's so versatile and open source in the programming, it opens the door for research institutions to start putting the attachments onto them. So like at UC Merced, we have Stefano Carpine, who has software engineers that are programming different routes and how to make it move and stop and recognize that, hey, we need to stop here. And then we have Reza Sini, did I say his last name right? I think I did. So then we have him looking at the mechanical side with another unit where they're looking at what types of attachments could we put on this that could do different mechanization, that could do different sensing. So I think we're at a really interesting time for the development of those types of technologies, because we're starting to see these base platforms that are affordable, and that's going to allow a whole lot more innovation to happen on top of that. Similar to the drone that flies and grabs the apples, you know, they've found that partnering with a platform that's already existing is a whole lot better than recreating their own platform. So I think that as we see those platforms that are becoming base, and now we can start attaching to them, things to them, and the data is operable between the two, it's going to accelerate the adoption of these types of technologies substantially faster than we've seen in the last decade.
So I realize a food forest doesn't exactly fit in with what you're planning right now and what you're doing, but I think when you mentioned a community garden down the road, perhaps, I wondered, yeah, whether food forestry is also something you'll be looking at.
So long as I'm understanding food forestry correctly, we are going to have, so like we have windbreaks that, you know, our architects we've worked with, and those windbreaks are going to end up being edible windbreaks. So instead of putting a hedgerow up, we're going to put a pomegranates up. Or, you know, look at olives specifically. So looking at types of infrastructure that's going into the design and making sure it's edible and multi-use. So yes, we're going to block the wind, but we're also going to make utilization out of the water that we're going to have to use to grow that vegetation and produce some fruit that, you know, I know our chancellor likes pomegranates, so that's definitely why it's on my radar.
Hey, great stuff. This is kind of a late afternoon musing, maybe something for Humberto. So with the CO2 flux monitoring, for example, how much in reality and in your modeling comes down to the physical chemistry of the CO2 flux, like the partial pressures and the solubility, versus how much of the flux is driven by biologically? And then drilling a bit deeper, what's the capacity or vision for the smart farms to do monitoring of microbiomes based on composition and the physical chemistry?
Yeah, I would say for our model, it's not too good at the biological part in terms of microbial diversities and everything. There's people at our university working on that, TEMRAT and them. But I would say our model, and it's showing that it's very much the physical properties that are kind of dictating the CO2 efflux.
I don't like any more, but once you nail that down,
yeah,
that CO2 flux with the physical chemical conditions, the other physical things like light, you can kind of control for that. Any difference, you can start to look at how much of that is biologically mediated.
Yes, that would be some next steps for us to take, is start looking at the microbial diversities and the chemistry deeper. Yeah.
So far, and Humberto showed the model results today, but he's also got some wonderful empirical data sets that show hot spots and hot moments that, you know, I mean, the microbes and roots and things are doing it, but the moisture and the temperature is kind of mediating it. And you'll actually, we haven't quite verified it yet, but you can kind of see the edge of the clay area where nothing can come out, and it's kind of cascading out the side and stuff. So it's also the scale of what you're looking at. And later, hopefully by next week, we'll have our first flux tower up so we can see the CO2 sort of big footprint, and how does that compare to the point scale numbers.
We've been pulling eDNA samples at different stages of like when we did our cultivation, we did pre-cultivation, and then I ended up making a couple passes. So after one pass, they came in, pulled samples, same location. So there's been that's Aaron Hester. So there's been other labs that are coming in and pulling those data sets together, and we're in the process as they get those data sets together. We're bringing them into our lake, so that way they're available.
We hope the smart farm will just keep getting smarter so that, you know, all of a sudden that the canvas that includes moisture and temperature and microclimate also includes CO2 fluxes, and then a couple of microbiologists come out there and scratch their head and say, I want to do a study and look at the biomes and why this pattern looks this way.
Thank you so much. We're going to wrap up this panel and move to our closing remarks, but that was fantastic. Thank you very much. So I'd like to bring up Mark Kepler of the Maddy Institute, our partner in this event, to close us out today. Thank you, Mark.
Microphone or that?
Whichever you prefer.
Okay. Let's see if we can do it. Oops. Yeah, see if we can do it this way. Thank you for hanging around. When James asked me to make the closing remarks, it kind of reminded me something. I've been on the faculty here for 35 years, and this is actually a true story of someone making kind of a closing remarks at a conference. We had a colleague of mine in the business school was presenting a paper in Las Vegas, and he was in the last session, last paper presented, and when he goes to present his paper, he walks in, there's one person in the audience. And he says, well, the school paid for me to come here and present my paper, so I'm going to go through it. And he goes through his analysis, empirical analysis, whatever. At the end of his presentation, he turns to the person and says, do you have any questions? And the person says, I'm with hotel staff. I just want to know if you're done with that slides. So I thought, is this the same thing that's going to happen? And we have more people here today. I want to let you know that we had over 400 people view this online, and we had 280 people RSVP, 200 of whom showed up today. So we had actually a very, very good attendance. I want to thank our partners, Lawrence Livermore Foundation and Climate Now, for helping us do this, really putting this on. And I want to thank you for your participation in this one-day event. It kind of begins the discussion of how we can maintain the economic viability, environmental sustainability, and social equity of Valley agriculture. You know, our success is really your success, and it's not just a matter of local concern. I really believe this, that the Valley's agricultural economy is essential to our nation's food independence, and that means it's essential to our national security. I think it's that important. And that has to be done while we're facing the challenge of climate change. But that is no small task, as I'm sure all of you know from the discussions today. And it's going to take the work of all of us together to find solutions. And we began to hear some of those solutions today. We started the day with remarks from California Secretary of Ag, Karen Ross, talking about what the state of California is doing to help farmers in the Valley to respond to climate change. We then heard from folks about carbon-friendly natural land and agricultural opportunities for farmers and ranchers to actually supplement their income with things like solar and geologic sequestration. We also heard from producers about the challenges they faced. We had a panel of ag leaders with Fresno State President Salia Mendez-Sandoval to discuss what they'd like to see government do at all levels to help them deal with climate change goals in a way that actually supports and doesn't challenge Valley agriculture. Finally, we heard from the Maddy Institute's 4 partner universities, and one thing you may not be aware of is several years ago, we negotiated agreements with the other public universities in the Valley. The Maddy Institute started at Fresno State, but we discussed having partnerships with the other Valley universities, Cal State Bakersfield, Cal State Stanislaus, and UC Merced to create a 4-university collaborative, which is what we are. When you see the seals, that's what that represents. We're working together. And you heard, for example, that Fresno State's working on water management and the latest in water technology. You heard that Stan State is finding ways to profitably repurpose fallow ag land. You heard from folks from Cal State Bakersfield about the business and economics of ag in light of the geopolitics going on and supply chain challenges. And then finally, you just heard about the experimental farm that's being done at UC Merced that really gives us a glimpse of what the future of ag is going to look like. You know, the Maddy Institute was created in 1999 by unanimous vote of the California legislature to really honor the legacy of the late Senator Ken Maddy. He was a person who exemplified fact-based, problem-solving, bipartisan approach to politics. The Maddy Institute really is dedicated to that public policy vision. And I think there's no more important public policy for the region than the future of valley agriculture. As I said in my opening remarks, maintaining a strong valley agricultural economy in light of our environmental, social, and economic challenges is really a national security issue. It's that important. I do believe we have the expertise and the leadership to meet those challenges. The Maddy Institute's going to do its part. One of the things, if you're like me, you've probably attended many conferences in your career, and nothing happens. I don't know about you, that's a tremendous frustration to me. I'm not going to let that happen here. We're going to do something. Our goal is to come away with 2 or 3 actionable items that will be implemented before we do this again next year. One of the things we're going to work on right out of the blocks is create a fellowship program, scholarship program for undergraduate students throughout the valley that they can learn, can really get an internship opportunity to work with regulatory agencies in Sacramento that regulate ag, to get a better understanding of how they operate. I'm hoping that also some of the regulators might, after talking to some of the students in ag, get a better understanding of the implications of their regulations in a real world context. So I hope you'll consider joining the Maddy Associates and provide money to create that fund, but we're going to be working creating a scholarship fund to have that implemented by next year. By the way, you're also invited tomorrow. We're doing our annual legislative update with federal and state legislators and their staff, talk about what they're working on in Washington and Sacramento. It's going to be here on the campus. Tomorrow it's a luncheon from noon to 1. We have a few seats still remaining, so take advantage of the fact that it's a holiday tomorrow, and so we didn't have a sellout. We have a few seats. We encourage you. We want to have people attend, so if you're interested, just log on to our website, send me an email, and we'll get you registered for the few seats we do have remaining. The other thing I want to mention is that in a few weeks, I want to follow up on this conference. I know Climate Now is going to be following up on this to kind of get input from you about what you liked about this conference, what we can do better, and what you think the path forward is for valley agriculture. Because this is just the beginning. I was talking to someone from Bakersfield yesterday, and they were talking, bemoaning, frankly, the fact that the challenge the valley ag has. And I said, what's that statement that a journey of 1,000 miles begins with the first step? And this is the first step of bringing people together to solve the problems the challenges that we're facing. And I truly believe we can do that. So we're looking forward to getting your input. We feel at the Maddy Institute that we are your institute. I'm just here to keeping a seat warm, but this is your institute. And so to the extent you think we should be working on things, I encourage you, I implore you to let me know. Mark, do this, don't do that. Let us know what we can do to serve our community and our region better. And with that, I wanted to encourage you to stick around for a little bit, network, talk to some folks, and I want to just thank you again for spending an entire day with us learning about the future of valley agriculture. Thank you very much.